Well, good morning, everyone. My name is Tim Spears. On behalf of CAL FIRE and Office of State Fire Marshal, welcome to the California Battery Energy Storage System Fire Safety Symposium. We're glad to see so many here today representing a range of perspectives across energy storage, fire safety, and emergency response. Before we get started, a quick housekeeping note. If you haven't found the restrooms, they're out this way and to the west of the auditorium in the lobby. In case of emergency, please exit the auditorium using the nearest exit and proceed outside. If a fire alarm sounds, please follow the instructions of building staff. And if you notice anything unsafe or need assistance, please don't hesitate to reach out to any member of our team. To open today's event, it is my pleasure to introduce State Fire Marshal Chief Daniel Berlant.
Good morning, everyone. Who doesn't love to come to Sacramento at 8 a.m. For our meeting on the first month? No offense to my City of Sacramento friends, but the first month of raised parking prices. But the good news is we were really stressed because the return to office was going to occur at the same time. And so not only were you going to join us here, 3,000 of your closest state worker friends were also going to be in this building, adding to the line at lunchtime. And fortunately, that is not the case. While there are still plenty of hardworking work happening, they're not all in this building this morning. But welcome to the CAL FIRE headquarters located in the California Natural Resources building. If this isn't your first time in Sacramento, I do hope that after 5 o'clock today, you take an opportunity to walk around downtown. We're only 3 blocks from the state capitol. And so it's a good opportunity just to see government in business. The legislature is on break right now. So there are no hearings or any exciting politics happening. That's not true. There's always politics happening. But again, I hope you spend more than just this morning in Sacramento. But we do appreciate you attending this morning. Obviously, battery energy storage systems, lithium-ion batteries have really become an integral part of our state's energy reliability strategy. But with any new technology, it's critical that we bring the fire service in to really make sure that we're setting codes and standards to adopt around those changes. Make sure that for response, you are prepared to be able to handle and understand not only what is in those systems, how they are manufactured, how they are regulated, but also what happens when an emergency occurs. And so we are super excited to not only bring the fire service together, but to bring in experts. As Tim said, we have really pulled together a who's who of battery energy storage systems, from the research arm to firefighter safety, to our state agencies and the work that is happening around us, not just at CAL FIRE related to fire safety, but with our partners at the Energy Commission, the Utilities Commission, and many others. But there's so much research that's happening all at the same time. And so making sure that we're bringing that to California and that we are staying on top of it is really our goal today. If you don't know, we have been an early adopter here in California of national fire codes, really across the board, but really focused in on battery energy storage systems, making sure that as at a national level, and even an international level, standards are being set, that we are setting the pace here in California, that we are setting the track that the nation then can follow. And so while a lot of good work by many people in this room have gone into setting those standards, we have continued to make sure that we bring those in to California early. But we do that in a collaborative process. Again, with many of the organizations that are in this room, many of the organizations that you're going to hear from today, we are spending time with our team, not only on a number of committees nationally, sitting with the International Code Council on their battery energy storage systems working group. You're going to hear from, I believe, Chief, you're the chair of the committee, so you're going to get the latest of what's happening nationally. That group, along with our team, you'll hear from Chief Crystal Sujeski from our team, who also sits on that committee. But they have been working to really identify the gaps in the code, in training, and in education. And again, our continued goal and why we have pushed to have our team as part of that is to really ensure that you all are informed of what is happening nationally. And again, so that we in California can lead in this space. But also you hear from some of the key folks, the governor has been very much focused on the understanding of firefighter safety related to these systems. And when we talk about lithium-ion batteries, often we go to electric vehicles as kind of the immediate, that's the problem. But in reality, we are using lithium-ion from everything from your cell phone to your vehicle to how, again, we are storing energy in our state overnight to keep the lights on and to keep reliability. And so our state agencies under the governor's leadership have established a collaborative to make sure that across the energy sector, the fire safety sector, the emergency response sector, that we are all in a unified approach to ensure, again, that we are meeting not only the state's energy reliability goals, but also ensuring that our communities and all of you, the fire service, are safe. And so you'll hear in a moment from all of them. Again, just teasing a little bit, in just a few months ago, we brought forward over 30 code changes to the California Building Standards Commission, which they accepted in March, incorporating the latest in battery energy storage systems. Again, this is a point of pride, no offense to our national code leaders who are still working to put that into the international model, but we have brought those into the California code and will be incorporated as part of the 2025 code that will go into effect in 2026 in January. And Crystal from our team will talk more about that, but that's been really important. There's been a lot of discussion from industry about making sure that we are not only making it easier for companies to bring products and systems into California, but again, at the end of the day, making sure that they are meeting the latest safety requirements. A lot of great work has occurred from our partners at NFPA. You'll hear from them in several portions of this, not only in the work that they're doing to develop the latest standards, but also, and actually I would argue more importantly, in the front end, the research that they are doing that then goes into what those standards look like. And so looking ahead for us here in the state, look for a number of code changes to go into the code. Now, the reality, and just to maybe cue up some of the questions, is while in a lot of things in the code, we always are making it better for new construction or new systems. What do we do with existing that may not meet today's level of standard? And that's going to be a continued discussion point for us. So with that, I'll stop talking. Again, welcome very much. Please take the opportunity at the breaks and at lunch to get to know each other. We're so appreciative of our industry and stakeholder partners that have joined us. We have, again, worked to bring many of those manufacturers, systems, programs, trainings out in the lobby so that you can have access. Again, at the end of the day, that's all we are trying to do is bring access. This symposium is the first step. We have a website as well that, again, we are trying to make be a hub of information. I think at some point throughout the day, we will put that up there. But with that, I'm going to turn it back to Tim to introduce Chief O'Brien, who really is internationally known for leading in firefighting response and firefighter safety on battery energy storage systems. So with that, Tim, I'll turn it over to you to introduce the Chief.
Thank you, Chief Berlant. Now it's my honor to introduce our keynote speaker, Chief Michael O'Brien from the Brighton Area Fire Authority in Michigan. Chief O'Brien has been a leader in fire and building code development for more than 25 years. He serves on the board of directors for the International Association of Fire Chiefs, Fire and Life Safety Section, and represents them on the broader IAFC board. In addition, he chairs the IAFC's Lithium-Ion Battery Committee and recently served as the chair of the ICC's Ad Hoc Committee on Lithium-Ion Batteries and Energy Storage Systems. Please join me in welcoming Chief Michael O'Brien.
It's 1998, and I'm working as a paramedic somewhere outside of Detroit. And it is probably the hottest day that we had. And for Michigan hot, that's over 100 with high humidity. Okay, so in our system, we had 3 people on an engine, 2-person on an ALS unit, and we had 2 stations staffed, and we were turning somewhere about 6,000 calls a year. So that kind of tells my responder friends the volume. That's what we're doing. Now, mostly 1-story bungalow houses, a couple 8 or 9-story buildings. But we get dispatched to smoke coming from a really large industrial process known as an incinerator. Now, they used to burn trash back in the day. Now, they told me the air was scrubbed. It was clean. Basically, inside this building was a 6-story pile of trash. We get there, the captain says, you two go upstairs. There is a hand line, put the fire out. Now, if you think about firefighting, how much education does our firefighting forces get as it relates to systems and structures in their response? Fire sprinklers, fire alarms, standpipe systems, clean agent, wet chem. National standards, it's about 4 hours. Yet many of us in this room spend weeks, months, days designing some of the most intricate systems for them to use when there's a fire. So we climb up this stair, there's no smoke, but I've never heard a building quite make this noise before. And we had done lots of site tours. They would take us out there and the cranes would be running overhead. It'd pick up the trash, it'd put it into the incinerator, and the fire would go and it would burn. And we would what if this thing to some extent. Now, for the most part, I would say the fire service, we were checking the box, right? We needed to do this and it was in our way. We were running 20 calls a day on a squad, a medic unit. There wasn't a lot of time for that. So we get upstairs, and for those of you who know, there is this hand line, and we can't see now. We get upstairs on top of the 6th story. If we go too far, we fall into a pile of trash that's 6 stories in height. So a little bit scary. And we get this hand line that they told me was a standpipe. It was a 1-inch line with a red nozzle. Now, if you think about it, yes, in some aspects, that is a standpipe. It's not going to help us put out a 6-story pile of trash in an incinerator. And it may have been the first time I opened up a hand line and the water came back at me because the velocity from the heat and the smoke and the air movement. That was a long day for us. We went for a long time trying to get this fire extinguished. We finally took a real standpipe up. We finally got additional work. We finally got ladder trucks out there, and the fire went out. But it was probably part of my case of saying we spend tremendous time building safe buildings, building safe structures, but how much time do we give our firefighters in how they use those systems? And in that case, it drove me to seek to understand how we develop codes and standards. How do we keep our buildings and occupants safe? Because most of our firefighters every day go to a working home fire. There's probably within 30 miles, there's probably 2 home fires going on right now. And so the firefighters are very used to working in that environment. When I now take that experience and I apply it to a commercial setting, can our firefighters get in trouble? Case in point, I think the biggest sprinkler that you can install in a storage occupancy, I think if you have a 55-foot high ceiling and you want to store 35 feet in height, you can put a K33 something sprinkler in. It discharges 260 gallons a minute. Now, how do we tell the firefighters why that's important to them? If they walk in and the fire's getting bigger and they see at least 8 of those open, what happens? It needs to change something, because if I changed it and said, listen, you have 8 2.5-inch hose lines open and the fire's not going out, does that change your perspective? And how do we get it? Because not every building has that sprinkler system, right? The sprinklers in this building, 10 gallons a minute? Drastically different commodity, drastically different case. And so much of what we do within the fire service, we forget at times how important our are with all the work we do in codes and standards, and we forget how their interaction goes. Case in point with energy storage, our viewpoint on what energy storage is going to vary. So energy storage might be to you the UPS. You have no clue when I say, hey, look, we put in residential ESS. Now I'm in California, so most of the fire departments are very well aware of what stored energy is in the home. We know what those commercial names are. We've seen a very high success rate with them, high safety standards. They're a very regulated commodity for the most part. When I travel the country, that experience doesn't apply. So when we say, hey, look, we're going to put stored energy in somebody's home, they don't understand that that may be one of the highest permitted things that we see around here in California. Case in point, last week, building official in the Midwest says, hey, can you do a plan review real quick for me? I said, sure. What is it? Residential ESS. It's their first one. And this conversation for me takes place probably once a month. And the building official sends me the drawings, and I'm expecting to see a manufacturer, a submittal, a location, safeguards, compliance with the residential code. I get a data sheet for some lithium-ion batteries, a sketch that shows they're going to install something around, let's just say a whole wall of batteries, and there's no listing. It's homemade. Now, the person submitted for a permit, which is really cool. That's homemade. And to them, it was energy storage. They were buying brand new batteries from a reputable manufacturer, they bought an inverter, and they knew how they were going to install this. That's not energy storage from the picture that we think of when somebody says, hey, look, I want to put X manufacturer on the wall of my garage, connected to my PV on my roof, and reap the benefits. So experience, just like when we go back to how do we interact in the built environment, our firefighters, our battery experience is drastically different. I'm from Metro Detroit. 2004 was probably the first time somebody called for code help, and they were getting a facility that was going to start making lithium-ion batteries for the automotive sector. Ford, GM, Stellantis, Toyota all have facilities in the Metro Detroit land. And back in those early 2004s, that's what they wanted. That was probably the first request. So my initial battery experience started in the automotive side. We had a lot of test facilities, laboratory spaces. But then these batteries needed to get out of their buildings. So we had capture locations. And my friends from the Department of Transportation called us and said, hey, we keep getting these batteries catching on fire in these 55-gallon drums in transit. And they said, hey, we're going to burn this. Do you want to come watch it? I said, yes, I'll even bring a fire truck. And so our experience with batteries, whether it's energy storage, whether it's in the built environment, is very different. And we know the fire experience is drastically different. The cell quality that we put in a non-listed mobility device is not the cell quality we put in a modern car. It is not the cell quality that we put in a Megapack or BYD Cube, G product. But the only thing we see on the news, these rashes of fires occurring from lithium-ion batteries. So from a fire service perspective, right, if we look at our fire chiefs, our fire marshals, anybody who is working to reduce the impact of fire on their community have to have this dialogue of how we safely use batteries in our life. Coming up, Fire Prevention Week is going to be talking about lithium-ion battery safety. I am excited about this. I hope that, and I know that our fire service is going to lean into it. But here's the catch. We're in a city, we're in a state building here. Somewhere in this building is a computer room with a kid working on laptops. Somewhere in that room, they are collecting lithium-ion batteries out of laptops. Okay? Are they being stored correctly? How are they being handled? How do our fire crews respond to it if something happened? Now think about it, it's here in this building, but now we're going to go into Fire Prevention Week and say something like, hey, if you're not using your batteries or they're swollen, they're hot, they don't hold a charge, please get them out of your home and start recycling them. Maybe the fire marshal comes and says, hey, Tim, this power bank I use is hot to the touch. What should we do with it? If we as a community can't answer that question, how can we expect everybody at Fire Prevention Week that we're raising the bar to answer that question? So we have tremendous amount of work to do within the battery space. But if the perspective of the fire department is only mobility devices And now they're getting one of the most sophisticated energy storage systems that's going to have 500 containers put in a farmland next to a PV. How do we make them successful? Because their taste for batteries, every fire department in the United States has fires with batteries in them. And if they say we've never been to a battery fire, I'm going to tell you, you're not looking. Every garage fire has how many damaged batteries in it from here on out. And so if that's the perspective of our fire service, how do we come together as a community and start to say, look, we want you to be prepared for these things? Because that field and us putting those 500 units out in a field, it's tremendous. We're going to walk through it this morning. The work that is done to make sure that is safe is incredible. Maybe you're not getting that. But I can tell you that if you have a major highway, there's product moving through your area. Now, maybe it's energy storage that's being assembled somewhere else. Manufacturers assemble their ESS all over the place. Some of it is coming in from overseas. Some of it is American-made products, and it moves on our highways. We hope that when they're being shipped at a low state of charge. We'll talk about that today. If you ever look good, if somebody says, hey, we're going to have this building and there's going to be batteries in it, your first question should always be, what's the state of charge? That will guide us through so much more. But regardless, before that unit in San Bernardino was put in, it fell off the truck. Now, there was some errors. There were some lessons learned, just like how we make codes and standards. We have learned for a long time about how to make better codes and standards. This highlights the need for even training at that local level of what size unit or what size and type of trailer should be on this. What role do the manufacturers play in that third-party contractor that's delivering units? I don't think we have to talk much about MOS. I think everybody here is very well aware of it. But it's a drastically different system than where that one was going. Drastically different in size, volume, and how it was constructed and when it was constructed. I don't care where you're at right now in the United States, but if somebody's working on a battery project, I guarantee you the words must come out. So if you're a local fire chief and you're getting a stored energy system and this is on your mind, how do we help equip them to properly navigate this? This was a very large repurposed building, not an enclosure-based system. It had very different technologies, well, similar technologies, but it did create some very significant concerns to the battery industry as a whole. Well, maybe your battery experience is with data centers. We can put stored energy in our data centers. All we're hearing about is how much power our data centers need. And trust me, there's a whole cycle of people trying to tackle this. And it's not just batteries. Look at the work that our generator folks are trying to provide for standby power or prime power or whatever it may be. Very drastic change, but we're seeing battery incidents that are occurring in our data centers. Have you ever thought what happens to a battery pack when it didn't work in the manufacturing process? Where's it go? Maybe we're assembling energy storage and the unit didn't meet spec. Where does it go? Michigan just recently had an incident, took a couple of hours. I'm not sure yet if it's a success or not. It was a complicated scene, but they had stacked EV battery packs inside of a structure. Now, from a fire service perspective, does it look like that building's going down? That is light smoke. Crews, though, were inside operating because they wanted to separate the packs that were on fire, get them to the exterior, and then turn the building back over. They had to move. They had about 8 cartons with EV battery packs inside catch on fire, and they had about 8 K25 sprinklers operating. Now, some of us from an engineering side might say that's a success. 8 sprinklers, probably out of 12-ish in the design area. We understand that. To our fire folks, sprinkler systems are designed, many cases, we don't design the whole building to operate at once unless it's a deluge system. We say, based on the commodity, based on the storage, based on what we're going to put in that space, we need a design area of so big. If we stay within the design area, the engineers got it right. NFPA 13 got it right. When we leave outside of that, that's where we usually start to see. The International Fire Chiefs has become drastically interested in safety incidents as it relates to transport. Now, I think most everybody has seen these two, but recently we were at a meeting where there's been about 12 battery or ESS systems come trailers with no incident. Now, the good thing is not many people are tracking that. And that's probably one of the hard parts. I'm not even sure in Nearest how we pull that data when we transfer over to Nearest. But where my focus wants to go is, how do I equip a firefighter at 2 o'clock in the morning with a rolled over ESS on the side of your freeway to be successful? Do the hazards change compared on transit versus on the parked in a permanent spot? And so the in-transit is becoming something that needs a lot more conversation and discussion. How do we ship on rail? Is it an issue? So how do we get the really smart people? I look around the room, and for those of you, I hope you network today, including the fire service, reach out. There are tremendously smart people in this room. Some of the world's best engineers and fire protection engineers, both who work for manufacturers as well as who work for third parties, are here. And I hope you shake their hands, get their contact information. Likewise, we have some of the best manufacturers in the world. We have some of the best innovator manufacturers in the world here. Because the interesting part is, how do we start to gain that information and share it on from those folks? Because if I stay in my fire service bubble, we learned a long time ago, if I stay in a fire service bubble, I don't make really good fire and building codes. We don't. When we network with industry, when we network with advocates, when we network with people who are against, we typically can make really, really good progress in fire and building codes. I think the same goes here. DOT, PHMSA, a great partner. How are they moving these products and how do we equip them? How do we get the resources for this, right? You look at this, we've got a UN number. So let's pause and think what our fire service has. You have a big red fire truck worth $1.2 million. I'll give you a staff of 3 because it's California. Okay? It's a big red fire truck. They have a CAD computer in there that half the time is a brick. The kid riding backwards, that's usually the firefighter, has more knowledge in their cell phone than a lot of times what's in their CAD computer up in the front. So they roll up on this thing, they have this indicator, and if we did our job right, they would look at that and say, there's a UN number. Now, if we did our job right, they'd pull out an orange book, and hopefully they pulled out the 2024 edition orange book, because there's a typo on lithium-ion batteries in the 2020. So if you don't have the 2024, now maybe they don't pull out the book, it is California, you pull out your iPad that has the app that has the response guide. But how do I make them successful? Because those of you in this room, if this wasn't on fire and you saw that light smoke, what are our firefighters going to say it is? Now, the gentleman, I think, initially in this, came out and said, hey, it's a semi filled with batteries. Are they wrong? It's a trailer filled with batteries. But there's indications here that should give our firefighters, this is something a little bit different than that. So how do we equip them beyond that orange book? Because that orange book doesn't say, hey, with that UN code, it's an energy storage system in transit. How do I identify this? Who the manufacturer is so I can pull up a response guide? You know, we look at the fire service right now and they have response guides for EVs. Half the cars, most of us can't identify to get to finding the response guide. We know what a Tesla looks like. We know what a GM product looks like. But can anybody, how do you tell the difference between an X and a Y? 2 o'clock in the morning, rollover accident. How does our firefighting crews know the difference between an X and a Y? This is Tesla, if you don't know my model numbers. There's one pure thing, and that is, right, it's the handle location on the doors. If the handles are where they're supposed to be, Y. If the handles are where they're next to each other, X. Now, some of you as engineers, you're like, why would that matter? I don't know. You ever try cutting the door on a winged car to get a patient out? How do we make our firefighters successful? The same would go here. I can't tell you what manufacturer that is to find a response guide, although it's something somebody has worked on in quite a bit. So we get these accidents that occur. Now, the different part here that when we start to deal with large-scale ESS, do we have to change our mind what's successful in fire and building codes? So let's go back to a simple home fire. Can a home fire ever be successful? If you're the homeowner, you're going to say no. Now, from a firefighting perspective, I could say success is we had the right on-duty staffing, we relied on our training, we were able to get through the door, we made the save, put out the fire, limited its spread. Some of our firefighters will say that's success. Is that fair? Now, can fire prevention ever call a home fire a success? Those involved in maybe community risk reduction, fire prevention materials. Now, what if we say this? The smoke alarm went off, they closed their doors, or their doors were closed, the smoke alarms got out, they had already practiced their exit plan, and they got out of the home. Would prevention call that a success? So we can have different opinions on what success gets. And I think codes and standards we start to get. So this fire back, some time ago really happened because of a leak on top of the unit. It had nothing really to do with cell quality. It had to do with maybe a manufacturer issue in the process that was fixed, and they've learned an absolute ton from this. So this is the fire crew, right? We let the initial mega pack burn out as per protocols. So if it didn't spread to the adjacent units, it stayed within the container. Should we be happy with this success? Now, firefighters are not used to watching things burn. They are action-oriented humans. And if you've ever been an incident commander, when you pull up and you have to make the decision that your firefighters can't go rescue somebody because of fire conditions, that will weigh on that crew for a long time.
Streamed it to this one, so now I can hear it.
How do I get them okay with this? How do I get them to say, look, you need to understand the design process?
So tell your guy.
There was a Herculean effort put into these to make them safe. You think about the work that went into making this building safe, from egress pass to sprinkler systems to fire alarm systems to employee training. The same goes here, that we're starting to be able to somehow check the box as we move through. Now, EPRI is a great resource in trying to share a lot of information as it relates to incidents. And I think most of you know how difficult it is to get data relative to battery-related incidents.
536 on.
Nearest might help us out. We're starting to roll out Nearest across the country. We're trying to get more and more fire departments to log their battery incidents so they can tell their story locally. And so when we start to look at this, we have this very drastic increase, right, in total installed amount on the ground. Last year, it was stated at a symposium that Matt Pace and PNNL hosted from California that they want to install at least 5 gigawatt hours of stored energy per year. Michigan is trying to push 1 and 2. Most of the Midwest, New York's trying to push a higher number, and Texas wants to beat down California. If you go to Texas right now, Texas wants more stored energy than California. Drastically different code environment. You heard from your state fire marshal this morning. California is the pinnacle, right? They said, hey, look, codes and standards are very important. We're going to talk about it a lot this morning, that codes and standards are a very critical part of this. Without current codes, how can we regulate some of the most advanced technology in the world? Is that fair? So when you look at some of our other states, they're still on the 2015 building code. 2015 building code was made in 2013. They're using fire codes that have really gone away. In fact, 2015 building code and fire code doesn't even really talk about stored energy. So when you start to look at this chart, we have this massive increase. It's estimated we're going to see about 20 gigawatt in 2025. I think that number is a little low. And it's not just California, it's across the country. Because you have these massive goals of meeting stored energy demands across. And so how do we actually know how much? I would need LG, Tesla, Samsung, BYD, any of the integrators to tell us, hey, here's how much stored energy you're putting in. So really, if we start to look at this, we can see that our rates of incident are going down. 2018, 2019, I hope you go back in time. If you're interested in energy storage, go back and read up on those incidents. Thanks to people like UL and others in the IFF, they studied a lot of this, which drove into our model codes where we're at. The IFC has been around since 2000, and it was found on, right, 3 other groups. That code has a lot of rich history as it relates to egress, as it relates to suppression, as it relates to fire alarm systems. Stored energy didn't start till about here in the codes and standards arena. Right? The first edition of NFPA 855 was here, IFC was here. And we really was a response because this growing community and trying to meet and how we address. The fact that we're releasing the 2024 fire code that has some of the IFC has some of the most complex and regulated issues as it relates to batteries. Not just energy storage, but the IFC has some great, and the California Fire Code has some great things, and that's down here. And so the bar has really been raised, so we do expect to see this spike go up. We want to keep this incident rate going down. And so we're hoping that through code, standards, training, everything keeps driving that down. I don't think we're ever going to hit a point in our life where there's no more home fires. I'd love it. I would love for our firefighters to never have to go to another home fire. It's not going to happen. Same with energy storage. I want to make sure that we are installing the best systems to keep our community powered, healthy, safe, and I want to make sure that those failures through a lot of different things don't come up. So what's a successful failure? Now, what that chart doesn't show you is how many times did the system within that energy storage do what it was supposed to do? So let's think about basic fire prevention. We got a lot of inspectors in the room. You don't need a fire code to inspect this building. First, if a fire occurs, we want to make sure everybody gets out. So we put things like fire alarm systems in. We make sure there's egress, correct? We want to make sure all that happens. Likewise, when there's a fire, we want to keep it small. So we do things like fire sprinklers, compartmentalization, engineered solutions. We weigh all those things in. When we start to deal with ESS, those simple concepts are put in, but much more technical. We have expectations on our manufacturers to keep what's called cell-to-cell propagation to a minimum. They have to meet a test criteria to meet that. Now, we're the fire service and we don't just trust one thing, right? What happens if there's a catastrophic failure and what happens with the system and how does it work? But we have to be able to tell our firefighters that these systems, these boxes, these buildings, these server buildings that have stored energy, there's some processes in here that are going to happen. So we put things like cell-to-cell propagation. We put fire alarm systems in for early detection. We put, when we're doing building base, we put fire sprinkler. It's not going to probably extinguish the fire, but it might limit that spread when it's building based. So there's a lot of things here that are also working in the background. Battery and energy management systems, moving power, being smarter than us. Doing something, noticing spikes in power, voltage, how it moves, and noticing those and doing proactive measures before it occurs. So when we look at this, we're going to have a lot more incidents than what show up on this chart. and we may not be dispatched. So that's a little bit clunky, I think, for the fire service. In Michigan, we have a law that says if you have a fire, you got to call us. When is a fire with a battery? One cell in an installed containerized system goes off. Battery management does its job. Does a big red fire truck need to go? How do we get to those real discussions? How do we help support them? They replace that module. Does it need a permit? Who do they call? How does it happen? So to me, when we start to look at stored energy, we have this very foundation that's in all of our codes. Some have called it a three-legged stool. I'm going to call it four probably for today. So when you look at this, it's very easy to go, oh dear God. And some of you are going to go, giddy up. Hell yeah. Now, how do we make this successful in its just ginormous magnitude to all of us? Well, right, we need manufacturers to push their limits and make really great cells and really great systems. We need them to learn from each other. We need them to have high standards of what makes a great system. We need them to push what technology can do. Over the pond in China, there's a law that's coming out, or a rule, in which batteries aren't supposed to go into thermal runaway. That is a very high bar. And I think there's a lot of people scratching their heads. But if you think about it, we want our manufacturers to make really great products. They don't make money by these catching on fire or having smoking incidents where they have to de-energize them. They want to provide a robust product that goes up and down and up and down and up and down for 20 years or 10 years, whatever their lifespan is. So that is one part of the stool. Good codes and standards are the other. It takes all of us in this room to make good codes and standards. And all of us have a part within that because we all have a perspective that's drastically different. Education and training is another key component of what truly needs to happen within that space. And then really, to me, the last part's enforcement. How do we make sure what we're saying is being done is being done? If you ever get your first commercial utility grade containerized enclosure-based ESS, it can be pure overwhelm. There's a room of people that have spent their last relative career. They have fire protection engineers, they have designers, and here you are, the fire marshal with your full-time inspector, wondering, how do I navigate codes and standards for this? It's like drinking out of a fire hose while being on crack. It is not a good time. So how are we successful in this? Well, let's go back with that first, or one of the first legs. It's really good codes and standards. So the California Fire Code is coming up Jan 1, in which the 2025 California Fire Code, and if you go back, the Fire Code is a very pivotal part that isn't just ESS. The Fire Code gives us a lot of things such as authority, emergency planning, site access, fire flow. It is always the basis of where we start, regardless if it's energy storage. Just like we've updated the California Fire Code, you do have the California Building Code. Installing a residential ESS does require some building-based permits. That's typically, it depends on when it's going in. We should have electrical inspectors and building code officials involved in our energy storage process. In the case of California, these are pretty well harmonized. Most of our states and other localities, they're very well harmonized. The tricky part is, right, these over here, number 1 and 2, are developed by the International Code Council, modified here within the process in California. So how do you get involved? Well, you can watch the code changes. We're going to be in person in October for this thing down here. You can come visit us. Cleveland rocks. That's what they say. I don't think anybody leaves Sacramento to go to Cleveland. And so this process is there. Well, maybe you're like, man, that's too much. then go get involved in the state. I'm sure you're going to hear from Crystal about work groups and this and that. There are so many ways that you can get involved in helping shape this thing. And it doesn't have to be about stored energy. It takes our voices to make sure these are really good. And when we make codes and standards in a vacuum, they become really, really bad. NFPA 855 right over here is about to release its next edition, the 2026 edition. Now, here's the interesting part with fire code and standards. So the California Fire Code refers to certain editions of NFPA. And we call those their reference standards. Now, this thing over here, 855, is going to have some really powerful tools in it coming up. So code officials, sometimes you get this, hey, listen, let's go away from energy storage and let me equate it to fire sprinklers, because more of you have probably done fire sprinkler plan review than you have ESS. Can I follow the most recent edition of NFPA 13 to put in my sprinkler system? And some of you are going to go, no, you got to use the reference. Well, in the most current, it covers this sprinkler and it actually gives us what we need. Is it okay that we follow that? I think you're going to continue to see that same question here in NFPA 855. NFPA 855 had a very high interest. They had tremendous amount of work groups that led to this update in the 2026 edition. You're going to see major changes and consolidation with the residential. You're going to see a lot of new technologies start to be addressed. The most complex part with NFPA 855 is at times you want to say it's a performance standard, but it's not a performance standard. It has to make sure it covers all of these different chemistries, all of these different categories of technologies on energy storage. Energy storage is not a one-size-fits-all. Tesla, LG, Samsung, NextEra, whoever it is, they do not use the same cells. If they don't use the same cells, when they have a bad day, they create different gas compositions. So how the systems handle those and how it's designed, we have to have this standard that addresses those things. So one of the very important parts as it relates to stored energy is making sure we're on the same page. Now, this is a good coordination. Both NFPA and then the fire code, the residential code, use a very similar, if not identical, definition as it relates to energy storage. Now, typically in the fire code, it says, hey, anything over a kilowatt hour that uses a battery for somewhere in the future, that's stored energy. That's an ESS. Where it can get a little bit clunky is we're seeing this stretch of what is an ESS. So for instance, if I put a 5 kilowatt hour battery on a stove in somebody's home, is that ESS? Well, read the residential. You see the part that says RB in front of it? That means it came out of the residential building code. One device or multiple devices assembled together capable of storing electrical energy to be supplied at a future time. If it's over 1 kilowatt hour, it's regulated. It has certain things that have to be done. I can tell you that when we probably worked on the original language in the IRC, I don't know if we were thinking about a battery attached to a stove or a fridge. Do the hazards change? Don't know. And so we have some work to do, but the definitions are also what are really, really important. So it's important that because we don't all have the same visualization, some of us think stored energy is just what we put in a container. We just go buy a Connex container, fill it with batteries, put a couple air conditioners on it, call it a day. They're much different than that. And so definitions are really very important to us because we start to get into this dialogue of what happens with protective measures when we change the configuration. So cabinets or enclosures are really starting to be the biggest thing. And you can see that they're not all the same size. Case in point, I can put energy storage with vehicle charging maybe in areas that don't have a robust grid support. But if I'm over that kilowatt hour that's in the code, there are certain permit requirements that need to take place. So we can start to get stored energy that isn't in this semi-size container. And we have to change that perspective and know that it can be in different sizes and shapes. Just like we can have building-based ESS. Now, I think many people are going, not sure 100, 200, 300,000 square feet of batteries in one space is a great idea anymore. Just because of the catastrophic nature. We don't like lots of flammable liquids in the same space, right? The fire code has addressed that for years. And this is a spot that there's a little bit of, well, I can tell you there's tremendous discussion. I don't think we're seeing a lot, but where I think many of us are going to deal with this when we get to Chapter 11 requirements about what are you supposed to do with existing buildings, this is going to be a very drastic conversation. The firefighting force needed for this is incredible. Incredible. I think in one of the panels, Chief Rezendi out of San Diego will talk a little bit about that bottom picture, I'm sure. But when you're flowing ladder trucks for 3 or 4 days, we probably need to take a hard look at how we're going to support that. There are a lot of existing things called walk-in units. And walk-in units is an interesting topic where we can create these enclosures with those size limitations, and somebody might have to go in and access this. Most manufacturers are starting to get their systems that we don't walk in anymore. This is going to be one of those changes that you'll see a lot of changes within the next edition of NFPA 855. But walk-in units can create a unique hazard, obviously, with staff inside. I was at the IAFC's Hazmat Committee to do a presentation with their team on batteries. And it was a very interesting conversation. And afterwards, a young man from one of the fire departments outside of DC, who has a tremendous amount of stored energy for server buildings with 3-letter names, says, we go on smoke investigations in walk-in ESS units all the time. Now, most of us go, what? And they say all the time, we are on fire alarms where this ESS is powering a building and we go inside there and we have that. And so I think of where the difficulty from an ops perspective, what do firefighters do on smoke investigations in a commercial building right now? You get dispatched to smoke coming out of a big box warehouse, or not out, but inside. You walk in, you see nothing flaming. I need a truck or an engine up on the roof. They send them up on the roof, and what do you start doing on the roof? You start taking panels off. To find what? Where the smoke's coming from. Most of our experience is going to tell us that if we have light smoke inside of a commercial building, probably somewhere has to do with HVAC system in some way. I'm going to rule that out as an incident commander. We get an alarm activation, depending on how our training is, depending on what that community knows, depending on what the site manager knows, our firefighters are going to have that natural thing. We need action. We have to get in here. So when we start to think about simple things like what's in the emergency response plan, it's easy to talk about a flaming fire. It's difficult to make sure our plans cover what's supposed to be or what could be light smoke. So we have code requirements that say, hey, look, enclosure-based systems have these size limitations. Do I think those size limitations are going to stay forever? I don't. But there are some size limitations before we put heating and cooling and some of the others. Natural fire break. If you go back to what's basic fire prevention, we're limiting the amount of fuel or combustibles that can happen within a space. Now, you can never do a lithium-ion battery discussion and not say, don't forget, we have a lot of legacy stuff still out there that isn't lithium-ion. I call it the old Ma Bell buildings. I'm sure they're here, but there's these brick buildings that if you've had a fire department, I guarantee you there's one in your jurisdiction. And you go there, the fire crews walk around, you see what looks like 1980s switchgear. It has a weird smell like the Space Museum because everything's old. And then there's a room filled with batteries, right? And we used to count up that aggregate amount of part in the, right? We used to count up electrolyte. We used to, how we handled these were way different than where we're going. Another key component that we have to talk about is what's called mobile ESS. Mobile ESS is a way different thing, but it's the same stuff. We're just moving it around. Why would we move it around? Our dear friends at Tesla have they have a charger attached to one of these. So if they've got an event or a wildfire, I know they rolled a couple in around the LA fires. They set them up. They have stored energy and they had vehicle charging. We're seeing a ton at concerts. Generators are loud, noisy, they smell, right? If I can roll up, this is Austin city limits. Austin city limits has no more generators. They hook these up, they're temp hooked up, they pull power at night, sufficient power to power the event and the festival. How do we equip our fire inspectors to handle this? You imagine walking around at Austin city limits thinking you're going to look at a bunch of tents and then you see a corrosive symbol? Would that change your perspective if it wasn't properly permitted? And so mobile energy has this concept as well. Now, there's some things that could be a little bit different here. We're moving a product probably at a very high state of charge. Should there be differences? How do I equip our firefighters to recognize that, yep, that's vehicle charging, but that thing right there is a megapack? Different response profiles. How do I get their toolbox to get that up? When we're teaching firefighters about EV firefighting, it's easy, right? We talk about there's 400 combustion vehicle fires a day in the US. Is it safe to say our fire service has a muscle memory in dealing with car fires? Now I make it an EV, they don't have the muscle memory. So we have to do a lot of muscle memory through training, through education, because we might say, hey, look, I don't have a megapack, but all of a sudden, I'm the site for some temp charging, and I've got to get on top of that. Well, here's a random question. Is that mobile ESS? There is a strong desire to get batteries on semi-trailers, not for propulsion, but to power other things on that vehicle, like cooling. Unfortunately, the way mobile ESS is defined, it creates a little bit of an issue. I don't think any of us said, yeah, we should probably regulate that, but we could. So how is an ESS made? And we're going to go on this journey because I think the next hour here, we've got to start to talk about, okay, we've got this history, we've got this breakdown. How do I make that fire chief, that company officer, that plan reviewer, that engineer, how do we get that system to be successful? And so we've got to understand how they're made. And we're going to talk a little bit about listing. You've got some great panelists this afternoon that are going to bring this together. But when we look at everything on here, some of it may be included, some of it's not required by code, but we start to look at this very complex part of where ESS. So on the surface, we have to say, hey, look, these cells are dramatic, or these cells are extremely high quality. Kevin's here from LG. LG just recently gave a pretty big tour of their facility in Holland, Michigan that was retooled from an EV space battery into stored energy. And if you've never been into a battery facility, we had a massive influx of battery making to the US, really based on the Inflation Reduction Act and trying to get more local sourcing. But cell manufacturing is a very, very key part. It's probably the basic component of all of our stored energy. They have to be listed, they have to meet certain performance specs, but what kind of cells they make and how they make them is really up to the manufacturer. Now we hear about this magic thing, right? This LFP that a lot of people are going to, but this is when we say, hey, it's a lithium ion technology. There's a lot of chemistry types that are coming out. And they're also evolving. What goes on the anode, what goes on the cathode, what goes with the secret sauce in the cell isn't on us in codes and standards. It's on the manufacturer, and what they want to do is get the highest energy density product at the cheapest cost. And if you probably put all of these chemistries up, some are really good for holding energy. Some are really great at holding energy, but the price is just astronomical. And so where the cell is going matters. What the cell is going to be used matters. And so we have this family of what we would call lithium ion. Now, there are other technologies coming out in stored energy specifically that are drastically different, and they have different responses. And so as part of the next edition of NFPA 855, we had about 10 or 11 presentations from manufacturers trying to spin up different technologies. And they came forward with their testing in which the question became, should this be included in the next edition of NFP 855? Now, when we say should it be included, it just means, is there a specific line in a lot of the tables relative to that style? If not, it gets clumped into other chemistries, which has a little higher safety standards and a little, I shouldn't say safety, but a little bit higher requirements throughout. And so all of these chemistries were very, very fascinating. Because here's what happens. Big Mike's batteries, I want to make batteries. And I've got something that's going to bury my competition. But I need funding. So I ship out a massive press release. I'm in the Wall Street Journal, I'm in Barron's, I got USA Today, that we came up with the next new technology that doesn't catch on fire, stores more energy, more cost effective, doesn't need the nickel. And I'm going to smoke the competition, and it runs like crazy. For me to publicly come out and say that, do I have to be at production scale? I maybe just made like a couple dozen of them, right? I want to create this interest that you're going to invest in my company. So part of it is we see a lot of desire, and we saw that with the committee. We'd say, hey, you've got a really good concept. Where's your testing? 2 weeks, 2 weeks. Okay. Month goes by, we're back. Did we get the data? So it's one aspect, I love it, right? We should all be in a constant state of learning. I want to hear about your new technologies. I want to see how you're doing this, and then I want to see where it meets in the complex nature of the code. Because some things we are starting to see. This article's coming around, and it's not just this manufacturer, but we've got a lot of battery makers in the US pivoting into the stored energy market, right? EV sales are down. We've got these beautiful plants that are going in all across our country that are some of the most sophisticated buildings in the world. Look at DeSoto, Kansas. DeSoto, Kansas is the home of Panasonic. Cameron and his team there are like 3 people. 3 people in the building department, getting one of the US's biggest battery makers at 6.6 million square feet. Okay, so how does our codes and standards help them? How does our codes and standards help this in those transitions and what they're needing? So batteries can come in all sorts of different shapes. We can change what goes on the inside, chemistries, and then we can change how they go, right? I think we've seen a lot of cylindrical cells. If we rip the top off our EV packs and look inside, GM's using a lot of pouch. A lot of Tesla products are using cylindrical. We're getting prismatic, which is that blue thing over here. And the same can go for what goes into our stored energy. From our perspective, it doesn't really change how we do our plan review. It doesn't change how we do our response. It does change how the engineers and how the systems are submitted. So just like we can put different ones of these in the car, we can do different. But that's this right here, right? So if you think about where the fire service could be involved, we know that there's a lot of US battery production. And we don't always make our batteries in town X and just go over one town and assemble them into modules for our ESS. They go on a semi, and they are shipped across the country to go to who? Whoever the assembler is part of our stored energy. So we have a lot of raw materials and batteries that are moving across. There's reasons we test batteries for performance, for fire considerations, all of those. And we use them, and we hit end of life, and we say, okay, what's next? This is an area that's going to be really cool to be a part of coming up, is all of this large-scale ESS. What is the plan for end of life? And there's a lot of people spinning up, but there's going to be a ton of work for as much as it's going on the ground. At some point, it's going to come off the ground, and it's got to go somewhere else. Andrew and the Redwood team are here. Stop by and see them. And you can talk about this collection piece in many, many categories of how we're collecting batteries. Maybe for you, it's how do I take care of Fire Prevention Week and collect residential batteries? But for some of our manufacturers, it's like, okay, how do we handle these? And so we have this very unique ecosystem over here that our firefighters are dealing with. Maybe it's not ESS, but it's part of the economy regulated to ESS. So if a battery pack doesn't meet specification, and that's in our community, and it's part of the manufacturing, the assembly, we are in this. So there are many different ways, and one of those spaces I'm going to tell you that is on a drastic increase is our university campuses. We need more US-based PhDs and engineers in battery science, period. To keep up with what is going on, we need a lot more of that. And so the universities are building tremendous lab space for a lot of different things. What I like being in Metro Detroit is we see some very unique things. From a code perspective, in a town called Plymouth Township, they have a manufacturer that is working on a separator that goes between cells. So they have a lab where they literally force cells into thermal runaway to see the performance of that material. And they do it every day. It's a neat thing. It's a neat thing as part of the process. But laboratory space could be a whole bunch of different stuff. It could be the folks at UL, but we need more lab space because of the energy storage market. They are backed up. And so there's a lot here that could happen that we can start to see. Likewise, maybe you don't have a place that's making batteries. You typically kind of know where those are. Maybe you have a facility that's starting to make modules. How do we prepare? How do we do a plan review? The International Fire Code, the California Fire Code in Chapter 3, this is an important part. 1207 is where we handle energy storage in the fire code. Chapter 3 is where everything else battery comes from. So the IFC and the CFC have the most robust requirements as it relates to battery manufacturing, battery storage, battery testing, battery recycling. Any of those are found in Chapter 3. Here's where this becomes very important. One of the things that's happening in stored energy is people are making up rules because they're unaware of what codes and standards exist. They're adding requirements that aren't code-based, but in many times are fear-based, although I will say they're truly intended to be good. They just don't realize that a model code exists. So if you have a place that's any of the things we've talked about, that's not found out of 1207 or NFPA 855. There is a little chapter, but that's not where the California Fire Code drops you to. It says go to Chapter 3. And just like mobility devices are regulated, we have storage, we have a lot of really, really good requirements. So if you think about this, we have places that are low state of charge, 30% or less. They're putting modules together. They're making ESS. Those are happening in our built environment all across the US. And, right, this is a manufacturing line. That is a almost near completion Tesla Megapack, right? We have all this stored energy. We've got all this cooling system. We have all this stored energy. That is a really cool process to see. Now, if you have that in your community, I hope it's you would have properly permitted it. You would have gone through all this, but it's interesting to see what happens when all the doors are off. So if we go back to definitions, this is what's called an enclosure. So that length, width, height have limitations in the code. This is an enclosure. This doesn't go back in a building. This is going to be out on the ground somewhere. And you can notice that you can access everything from the exterior. Now, one of the things, since I have Tesla up on the picture that's really unique, how when one of these cells has a bad day, it's going to create a unique gas composition similar to that. So one of the things that we have to teach our firefighters, what presents as light smoke in a battery failure is gas. Put your face piece on. The sneaky ones are EV fires. They're presenting as out, they're not, and then our firefighters get in a trick bag because they're tired of wearing their air pack at hour 2. In the case here, right, if this was installed, if we started to get a problem with a pack. We hope the battery management does its thing. It shuts it down. It stays with one cell. If it doesn't and it keeps going, Tesla, I dub it a self-destruct mode. It will ignite the gas. Now, why do we need to say that? That's how they're handling their product. Not every product does that. So if we get gas inside of a container, we have to manage that gas before it hits what? Flammable or explosive limit. In their case, they're saying, look, this thing's going away. So why is that important? Because if I'm going to have a conversation with ops folks and I say, listen, this is the design, this is what's going to happen. And they're like, we still put the fire out. Yeah, but they literally lit it on fire on purpose. And that's part of where we all have a job to say, look, these are the safety measures in here and keeping the fire small. They're going to have way more one cell issues that battery management handles than they ever will conflagrations. But how this container handles all of that, I keep hitting the black button, really starts to become very important. So how do we go from that manufacturing and transportation? For maybe some of you, you're like, hey, we don't have ESS yet, but you do have the transportation. Start having the dialogue with your operations staff. What is our plan? What are best practices? If you look, this is on a nice low boy, I would question these straps. If this is your energy storage system, right, we should see a lot of chains and other things. This has some significant weight to it. And I think you're going to continue to see this, but here's part of the question that we have to have. Maybe Fire Marshal X over in Santa Cruz says, hey, you can't bring any of your energy storage here yet to the site. So they said, well, the neighbors over here, their fire marshal's a little bit sleepy. We're going to stage them all in a dirt lot. Is that okay? So transportation issues and that ESS design are drastically different across the board. So when we go back to that chair, right, we've now talked about how important it is that they make really good products. Part of what the job now is, what are codes and standards doing? And it's not just one. So the California Fire Code is that main body that really directs us to everything else. And we have these other things that are very much part of it. The listing of the product, UL 9540, big, very, very important. And it includes a sub-document called UL 9548. This thing brings all the listings together. There are a bunch of listings to make successful ESS, just like we need a successful NFPA 855. Codes cover a very specific section, so if we open the fire code, there's 1207. 1207 has all the requirements for ESS, and new to most of the country, in the 2024 edition, we now say you have to meet this section, this code, and NFPA 855. And you're starting to see a little bit more specific requirements directed at too. Now, we have all the technical things that this box needs. But before we ever get to that, there's a whole bunch of stuff that needs to be covered that is the crux of the fire code. Site access, fire flow. These are things that not everybody's used to. They say, hey, look, I just want to open up the book. I'm an aggregator. We install, we buy these products, we put them in. I just want to follow one code. We're used to this very complex code that covers all of the aspects to site regulation. We even tell you how to put an address on a building. And so the fire code has these things that we have to cover. Now, for some of our ops folks, yes, codes are going to say, hey, look, we need design criteria for fire and explosion. There needs to be requirements for how we vent that gas. And depending on when it's built and where the codes are going, we have a lot of listing requirements and a lot of large-scale fire testing requirements. It's really some of the first time in fire codes where we said, listen, don't care about your safety measures, burn it. Now, at some point, I think we're going to be tired of burning batteries. I don't know if we ever will, but we're going to get close. But really, part of the design says, hey, look, there are certain times you have to do what's called a large full-scale test. Not all the time, but a big portion. This is a big item. And so we need to make sure a lot of our folks, because some things don't make sense. You're telling me that you're going to put these units back to back, 5 inches apart, 10 inches apart. Yep. On the surface, does that sound good if you're not involved in design? But as a designer, as a fire protection engineer, you might have to say, hey, chief, maybe you and I can just have some time, fire marshal, just the two of us, and we can go through the large scale fire test in my report, and I want to open up and just let you talk. The weight of a gold badge or an inspector's badge is tremendously heavy. And I don't think most people appreciate how heavy that is. Because if we think about what they're signing and what they're approving, sometimes, and I'm going to talk to maybe our engineers, aggregators, designers, sometimes you need to buy a box of donuts and a couple cups of coffee and go with your laptop and say, hey, can we just talk through this? I'm not asking for any approvals, but I want to give you a safe environment that you can ask me all the dumb questions you want. Because that weight of the badge and not looking stupid to everybody else, because maybe you don't have experience, it doesn't mean you don't bring a wealth of knowledge in the rest of the code. So listings are a very, very major need in how we tie these things together. And it's much different than just looking for a UL stamp, a UL listing on a light bulb. There is a lot that has to go into this. And it's broken down into a lot of categories that come forward. What happens in many cases, and let's just talk enclosure-based. People look at saying, hey, we're just buying this enclosure, I'm setting it, I'm hooking it up, and it feels like it's a piece of equipment. From codes and standards, it's a lot more drastic than that. Maybe someday we'll be there. But we've got to have, look, we're looking for this 9540, which includes all these other things. So 1973, 1741, and 9548. The equipment listing, so we say, hey, look, chargers, inverters, energy storage, all the stuff outside of the cells have listing requirements as well that you have to include. From an ops side, we trust a listing. Now, it doesn't mean it's not going to burn. It just means that there's certain things that are going to happen within that unit that we want to make sure we meet. And so, for the most part, within the IFC, we're pointing to those listings, but 9540 is that big one. So we've got the basis for safety, and just like we can develop codes and standards, UL and other standards-making organizations do the same thing. You're going to hear from them this afternoon, and if it's something like, man, I'm interested in being on a technical panel with UL, those standards have a lot of they rely on our feedback to be part of the discussion and process. Now, one thing I'm going to speak to the fire folks. It's intimidating the first time you go to a fire code hearing. There are some people who have some verbal judo. And there are some people who need to be muted by UL on some of their standards calls, but they won't. But it's part of the process, and it's okay to flub. It's your words. It's okay to not be perfect. But the important part is, how do we get the voice out? I'm going to look at Alex and not, but on some of her calls with 9540 in the update, she'll say, there's 120 people on this call. Somebody has to have an opinion. And it's hard because we're in this virtual environment to stay present. It's hard to stay present with what we're looking at in many cases, but there's a great opportunity for us to continue to be involved. Now, 9540A has been a great standard, and it says, look, you've got to do these 4 different tests to get to success as part of the process. So 9540A, which is a big part of this, says, look, you got to do cells, you got to do modules, and you got to do unit level. And so, right, module level testing evaluates the tendency of a cell thermal wave propagation, the heat, the gas release rate of the module, and the potential danger of ignition and deflagration. Cell level test evaluates thermal runaway characteristics. One of the cool things is it captures the gas. And this becomes part of the foundation for how we do what's called a hazard mitigation analysis. It's part of the foundation in how they develop the emergency response plan. This test data is something really cool that we don't see in a lot of our other codes and standards. We don't say, let's burn this and see how the exit system works. In batteries, we are, because if we don't manage what's happening here, then it becomes quite an issue. So large-scale fire testing is one of the biggest things going around in debate. UL 9540 and their team are working on their test standard. It's not currently included, it's coming up. We know that 855 has kind of taken a stab at large-scale fire testing. So this large-scale fire testing has been hanging out there. And it's not required on everything, but we need it to help us in many cases for size and separation. The more units I can put together, the more profitable my piece of property or inside the building or will be. And again, this isn't just for enclosures. This could be for building base and other things. It helps us start to tackle things that could be included. One of the things that I will bring up here with fire suppression effectiveness, we're programmed in the fire service to say, sprinkler it all. I'm going to tell you, containerized based, we don't want sprinklers in there, which is so counterintuitive. Now, buildings are completely different things, but they're going to have very limited things. But we want that large scale fire test to help us out, and it gets us a lot of the data. The data can be cumbersome. And what I mean by that is, you're going to get this large-scale fire report that we want to see that a fire protection engineer licensed in the state of California, if you're from California, for those of you online, within your whatever, has reviewed that data and is going to provide a technical synopsis and then correlate the rest of the project. For those of you who are manufacturers or installers or aggregators or engineers, one of the hardest things that happens to AHJs, I get a report from X fire protection engineering firm. Then the HMA has a report from this firm. And then I get another report from this firm. If we pause for a second and say, let's look at the built environment. When we built this building, there was one design professional and responsible charge. That is a defined term in the building and fire code. Their job is to regulate the MEPs, mechanical, electrical, plumbing. Their job is to bring that together. As code officials, that's what we're used to. And so there's some nuances that can happen. Paul and his team are very busy, and Noah's very busy, and I need my fire test yesterday. Right? And so we can end up with a lot of different things in this large-scale fire testing. There is CSA 800 that just recently came out, I think at the end of 24. It is something that is out there, lots of discussion. It is not referenced in our codes and standards yet, but it is hanging out there. And if you're like, man, I'd like to know a little bit more about this large-scale fire testing, feel free to reach out. We can start to get it in. So when we look at a community base and how this happens, when a site is selected for stored energy, there's a lot of things happening within the community. So a developer says, hey, look, we're going to do this. So the community goes out, and they put the signs out, zoning is proposed, or project is developed. Most of our communities, it starts at planning and zoning. The International Code Council's ad hoc committee, when we looked at gaps, the tools for our zoning administrators is woefully understaffed. And how they navigate this as probably a face piece for the community is big. There is no doubt that if we said, hey, look, we are going to put in a gigawatt hour on this site, on this location, there will be plenty of sessions where we're going to sit and talk, answer questions, and there will be high public interest. And I guarantee you that planning zoning administrator is going to get a lot of questions from the mayor, the township supervisor, the county commissioners. And so how do we equip them to be successful? And in many cases, it starts with a site plan. Now, us navigating site plans as a fire code community, as a building community, is pretty routine. Here's a subdivision, here's our roads, here's our access. And stored energy can come in a lot of different ways. Hey, we know we're going to put in a gig. We don't know our technology yet, and we don't know who our provider is. But we want to start the process. Well, I can't do all my plan review. Right? I can't tell you what the separations are going to be. I can't be. So there's a lot of difficulty that should start to happen. But it doesn't mean we don't start our community development process. So what is in your community if we're going to start doing some of these large-scale stored energy sites? Does planning and zoning know how they're going to administer it? Do they understand what the checklist should be? Heck, as a fire service, did we give them a checklist for navigating codes and standards? Because I guarantee you, your planning and zoning has a checklist for everything else. Right? They're going to show you how to navigate. The interesting part is most of us in this room are the ones that are going to navigate it. I will tell you that this stuff here gets a little bit clunky. Because again, we might have technology-specific people. They're not used to, and nor did they hire a design professional responsible charge to navigate these things. How much fire flow is needed? Chief, fire flow is not needed. It's a defensive stance. It's not needed. I'm sorry, but the fire code doesn't say that. So how do we navigate that requirement? Likewise, Chief, you can't say, well, Mr. Manufacturer, how long is your unit going to burn for if it's a full-scale conflagration? 13 hours in our fire test. Okay, 13 hours times 600 gallons a minute times stored water. That's not the way we get to that either. So part of what has to happen here is this goes back that the California Fire Code, the International Fire Code, has requirements that regulate all construction. And it doesn't, and nor is it a specific carve out to stored energy. But it's part of that four-legged stool that we have to start having a conversation. Chief, we are going to design a defensive stance. We do want these to burn out. We also realize that there's other things, wildfire concerns, vehicles, maintenance issues. So we want to come up with a respectable amount of fire flow. This may or may not be hydrants. It could be stored water. It could be. So this is where this starts to get very clunky. Now, the University of Michigan has really been doing a really good job. And so they've been trying to help local and state policy as well. So sometimes we have friends that aren't in the manufacturing, aren't in engineering, they're not in codes and standards, but they're trying to help the communities navigate this. You will hear me say that the fire department needs to own this in their community. If you could walk out of here or watch this online and say, look, we are ripe for getting a stored energy project. Let's just start having regular meetings to see how our community is going to handle this and how do we get prepared. What training could we go to? Who could we work with? Do we have a neighbor? Do we have somebody that we can learn from? Do we need an ordinance? Do we not need an ordinance? Because zoning and planning, they get into things that I don't know if we care about. Does the fire code care what the sound level is coming off of all your stored energy? Nope. But do you think that planning and zoning administrator, if they permit something too close to a residential sector, is not going to have to answer it? Now, we might have to help talk about setbacks, and right, but we have setbacks on everything. But if we get too complex, let's say, so Texas had a bill that everything had to be, Nick might fix me, but 1,000 feet setback for energy storage. Now, I want you to switch gears. Don't think stored energy like a big field. Think stored energy to support a building. What happens if I did that? So it's not all the same. This is a complex issue that I can tell you that the fire department needs to start by saying, hey, look, let's start this conversation and let's talk about what's in our codes and standards and what it looks like. Let's talk about how a good submittal should go. And so if you start to build that up, the CFC or the International Fire Code says, hey, look, there's these permit requirements for when you're doing stored energy. There's some limitations that don't apply. And we've got this thing that we can start to get in, and we've got some exemptions. So what makes a great submittal? I'm going to tell you that a lot of submittals come in that are so piecemealed, no wonder why everybody's frustrated. From the applicant to the designer to the code official to however it goes. And I'm going to tell you that a lot of projects go like this. Please, can we have a permit? And I will give you data tomorrow. And it makes it very, very hard. So part of what we want to look at is, and I'm just going to tell you how a typical building submittal, if I'm going to build a 1 million square foot storage facility, we've gone through zoning and planning, we've met those requirements, and now we're navigating fire and building code requirements. There are drawings, and I'm going to roll them out, but it's now on a screen, right? It should start with a really good cover letter, signed by somebody in charge. Typically in a building, we would get a cover letter from the design professional. But I'm going to tell you that a cover letter in plain language does tremendous things in helping navigate a community. The next should be the title page of our series of documents. It should show the location in the community, it should have the address if there is one, or what we're going to call this thing. It should have a date. It should have the AHJ, but you know what else? There should be a code synopsis of what is in play. That's what would happen if this building was in play. And typically they start to cover all the other things. So let's go away from building-based, but let's talk container-based or enclosure-based. Right? We would start to talk about things that are there. Hey, this is a F1 site. This is how many units. This is where we're going. And then one of the most important parts that happens in the built environment is something called deferred submittals. Maybe at this point, I don't have my decommissioning plan or my commissioning plan ready. To hold everybody accountable, list it right there. Commissioning plan, deferred submittal. So when the fire code official, the building code official are starting to issue something, they can understand. Now, some things that are happening down here is complete and accurate technical reports aren't always being submitted. We're getting summaries. NFPA 55 has given some pretty specific instructions what's supposed to be in these. Likewise, one of the open areas, we get a product from overseas. It has detection devices that are activating the NFPA 69 gas concentration reduction system. Does that require a local licensed contractor to submit that fire alarm? And I think most people are going to say yes. So is that a deferred submittal, and who's submitting it? Who's going to take responsibility? How do we have that conversation? Better yet, let's not even make it overseas. It's made in Michigan. God knows you're not going to accept Michigan products here in California. But how do we handle this? This goes back to our checklist. This goes back to the things that are supposed to be done. Because they're probably going to have to hire somebody that's going to take responsibility for that product. But it depends. There's too many variables. 3 units installed to support a building, drastically different than 1,000 units out in the middle of the high desert. And so this is where the variability comes in. And so there are some assets that can really help your community out. Hire or have somebody in your back pocket that's working for the community. The CFC, the IFC, the IBC allow building code officials, fire code officials for a long time to hire technical resources to support their process. You walk in a room, the first time you played fire marshal, and the room was filled with a bunch of developers. How'd that feel? One day I get a call from a local fire marshal. He says, hey, can I buy you lunch today? This is odd. What do you need? And I said, yes, I'll buy lunch. He says, great. We're going to stop by a construction site, though, on the way. And I said, fine. So I pull up to the construction site. I get out of my car. He's there. I said, hey, how you doing? Good to see you. Hey, you got a minute for a meeting? I do. And I walk in, and there has to be 20 people on this hospital project. And for those of you who've been in the fire alarm business, there was a little time in NFPA 72 where we flip-flopped and started to create this thing called survivability of wire. There was $1 million change order on the table for this local hospital for survivability on wire. And I walked into this conversation because that fire marshal had no technical help. It was him versus this room of 20 wanting to defend a $1 million change order in code compliance. This is no different, folks, right? The code allows you to get the right people so you can help streamline this process and hopefully help set some clear expectations. You know, it's hard to find sometimes the people that you want to trust, but make sure they've got some experience. But when we look at submittals from an ops perspective into codes and standards, there's a good rationale of what's going to cross over here. We've got to have all the typical things like layout and how the ESS, technology, hourly rating. So think about what the code is doing. We're saying, look, this isn't just containers. This could be buildings. This could be other size systems. And so the fire code has to have this pretty complex list in 1207 that starts to come in. And so, again, go back to your cover letter that's being submitted. If you're the people doing this, this is the checklist. It's in the fire code. Start there and start to get those processes. Location and content require of signage. Now, I know that sounds simple, But we've done a really good job of training the fire service not to go in energized fenced areas. Is that a fair statement? Power transfer facility with a fence around it that says call PG&E if issue here. Any of our firefighters cutting that lock and spraying water anywhere in there? I'm guessing that if we're putting 500 containers out in the high desert, we're probably going to have a fence within proximity. And so what should be on the signage? Who should they call? One of the hardest parts about being in the fire prevention division is keeping adequate context for emergencies with all of your buildings. One of the simplest things prevention can do is make sure ops has access to it. It's 2 o'clock in the morning, they can't get a fire alarm off. Who should they call? Call the building owner. Now, half the time they're gone or moved on or somewhere else. So the fire code continues on and says things like, hey, look, you've got to have all these details on suppression, ventilation. You've got to have the support arrangement for anything specific, commissioning plan, seismic, decommissioning plan. So how we test, how we're going to accept the systems. How do we take a system offline safely so that maintenance is done? We could add in here, when our permit's going to be pulled. We'll talk about that. A fire safety evacuation plan. NFPA has some more clarification on the technical information that's needed specific to those requirements that we just said. So you've got to have the fire and explosion testing. You've got to have a hazard mitigation analysis in accordance with Section 4. Let me pause there for a minute. Both the HMA and the emergency response plan lean on each other in some ways. The scope of both documents should be clearly defined. And the HMA should be specific to the technology. For those of you submitting technology, so maybe you're an aggregator that uses different boxes from different manufacturers. We have seen where HMAs are submitted and they forgot to update to the different technology. So a very simple thing is this the right HMA for this project? And is it specific enough? One of the big changes that's really starting to come up is how we handle the gas inside the containers. We do not want to see an explosion or a deflagration inside the box. So many years ago, or currently, we have these two standards, NFPA 68 and 69. One has openings, one does a gas concentration reduction system. One of the interesting parts that happens is over in NFPA 68, it'll say, over certain amounts of concentration of hydrogen gas, we're not a good product. So the question is in this design, how does it go back to that UL 9540A test and how it's brought together? And so within all of this technical data, one thing that happens a lot with submittals is it's just shotgun and it's not correlated. It's not correlated by that design professional. It's not correlated by the fire protection engineer. And so there is a lot here that comes out of the code. Now, fire prevention, CRR folks, or people doing plan reviews, building code officials, this is where we sit down with some of our key ops folks and start to describe what was put into the design. Because it's fair for our ops folks to have a lot of apprehension. If they didn't sit in this class and say, hold on, you're telling me that they burn one of these and they see how it works? I'm telling you that. Huh. Can that change our view when it comes to spacing? If you've never seen one of these and you get a Tesla Megapack, I think they're allowed, Tesla's going to nod their head, Abid will nod his head. 6 inches? Thanks, bud, man. It's good seeing you. They can be 6 inches apart by their test data. Now, I'm a trained fire operations person. Does that sound normal to you? It may not. So, prevention folks, we don't want to sit on this. If we're the people doing the plan review, take time and sit with your ops folks and start to have that conversation. When you start to look at what else needs to be in this permit and plan review, a couple big portions that are also in there relate to things like you might need a fire alarm permit if that's how the community is looking at it. I'm going to tell you that most people are saying, look, if part of your system design includes NFPA 69 gas concentration reduction system, you have gas sensors, you have fire alarm systems, you need a permit. Some might talk about, hey, those gas concentration reduction systems, how long are they going to be powered for? Does it correlate to your HMA? What's the time frame? Maybe indoor systems, I need data that tells me what the fire sprinkler design is supposed to be in here. When I open NFPA 13, what is it going to say about lithium-ion battery storage? Not covered by this standard. So, right, if you think about other permit requirements, if I go to building-based energy storage and you have stacked units, you're going to have all the things we talked about, but I'm also going to need something to help me here with fire sprinkler system data. And so we have a lot of other things that start to come in play. And this is something that happens in the communities. Can we please just start pushing dirt? Pretty please. Go back to that first part. What does your community want? We do foundation-only permits all the time. Not in ESS, but in the built environment we do. Hey, we need to start pushing dirt. Okay. But we clearly define what that is. So my question is, let's change our mindset. We're going to set 400 containers. We got transformers, we got inverters, we got conduit. What's the process if they're not done with this? They're not done with this permit process, and they say, hey, look, we want to do this. How does a community handle it? What's the best practice? Well, part one is we can say no, right? Now, some people are going to be like, Mike, it's pushing dirt. We got to make it flat, nice and level. Okay, push the dirt. What's the community standpoint? Can they start putting conduit in? How does that request come in? And typically, I think most of us would say, hey, your design professional, your team on letterhead needs to submit a letter to the city, to the community to say, hey, look, this is what we're doing, and this is how we're going to do it. Because if we don't have the technology, this request is, when we've worked for third parties for people, I'm telling you, this request comes up all the time, and they don't even know their technology yet, which to me is bizarre. But that's how some of the space is going. It's moving so fast. So, right, if we get this, if they start pulling this conduit and this dimension's off, I'm not a construction manager, but for me to move the rows of this 2 feet by 2 feet by 2 feet because they got the dimension wrong, I'm pretty sure that's expensive. Correct? So, how this is handled could matter. And so, one of the parts that I like to say, even when we issue the permit, things that aren't clearly identified. I'm going to bring a big crane in. I'm going to bring a real big crane in. These suckers are heavy. If I bring a really big crane in, that's expensive. So I want these units all staged. Do you have an expectation how I stage them? Is there a separation distance? Can the manufacturer help you out? Because if we wouldn't let these sit like this all together, when they bring them in to stage them, we have 300 units. The crane's coming in Friday. We're going to start setting units Friday. What's our construction fire safety plan? If we required water, you ask any fire code official, when can I start combustible construction on a construction site? You're going to say, hydrants better be on, boss. So if I have stored water, I'm out in the middle of nowhere, we want stored water as part of this project. I think most of us are going to say that at this point, when combustible materials are coming on, which means containers, you better have our fire protection water in place. Now, it might be a draft point, it might be hydrants, it could be whatever. So what happens when we move past this design? So part of what this design is hopefully telling us to do is that there's a lot of things happening within that box to keep it safe, right? So when we look at this product, right, we've got batteries in certain parts, we've got transformers and inverters in other parts. And so what we want to make sure is our systems are all tied together when they're required. And so that commissioning plan comes in a very important part. Case in point, for those of you not in the fire business, the surest way to get your fire alarm project inspection not complete, don't test your system before having the fire inspector come out. Okay? If the fire inspector comes out and they say, okay, let's start with the pull station, and none of the strobes go off. Okay? They'll probably give you about 2 more devices, and then what's happening? We're rescheduling this thing. The same, right? The fire code, both 855 and 1207 say, hey, look, you got to have a commissioning plan in how we're going to handle this. And it needs to be a real conversation. Inspecting 400 units. Anybody's fire prevention bureau overstaffed? Okay, I'll take that as a no. So I'm not sure how fast we can inspect 400 units. Are we going to inspect all 400 units? Will I take a technical report from your team? Maybe you hired a company like Hill or some third party, maybe not the community, but the installer. Maybe we don't have life safety systems. Do I have to test if I do have a NFPA 69 gas concentration reduction system? Do I need to test the CFMs? Who's doing that? How is it being done? How do I verify the design? And so the commissioning plan should be when we have good, clear heads. That's why it's part of the initial design. So we can say, hey, look, this is what's in this technology specific system. And remember, what's in Tesla's is not what's in LG's, which isn't what's in Powin, which isn't in et cetera, et cetera, et cetera. And so this needs to probably be its own meeting with the team to make sure it's handled right. And likewise, we have to make sure the decommissioning plan is in there as well. Now, here's something that is coming up across our communities. There is a big concern, what we'll say at end of life. Who's responsible? How is this going to handle? My guess in many cases is stored energy is becoming a commodity that's going to be brokered and sold like real estate anywhere else somewhere down the road. The economics of this thing are very, very unique. And so part of our plan is there's a reason why the CFC and the IFC say you need an annual permit. Because if it changes hands, somebody's got to pull a new permit and then agree to everything that we were willing to put in here. But planning, zoning, and communities are very, very concerned of end of life. And what does that look like? How do we return a site back? Is that our requirement in local ordinances? Fire code's going to say, hey, look, you need a decommissioning plan, but that's mostly aimed at how we maintain the systems, how we integrate the systems. And I would also say it's also how they modify the systems and what needs to be in there. Now, a key component of the system is emergency response planning and firefighter training. This is a struggle bus for many people. What should be included and what's not in here? NFPA 855 does a wonderful job of outlining what's supposed to be minimally in this document. If I take PV and put it with stored energy is saying you need an emergency response plan. Defining the scope of this emergency response plan is very important because we should probably make sure that the PV solar we have a good conversation with one ERP. So NFPA 855 starts to talk through these things. And this is where I also think you need to have a conversation. A smoking cell in a container, most are not calling the fire department. Is your district, your authority, your fire department okay with that? When will it get escalated? So part of this, who fire watches? Let's say we do get dispatched. Dispatch, fire alarm, nothing. Dispatch, fire alarm, nothing. Dispatch, fire alarm, BMS data. What's going on? Can we put Firewatch in? How does all this work? And so to me, what needs to happen here, what makes great ERPs, it starts at the top and works all the way down to very complex. And what are the audibles that the fire department's going to take? You're going to find out that there's a design parameter in the UL 9540 and the large scale fire testing as it relates to wind. Can wind affect our separation distances? Could. So let's just say it's a weird thing and it's 60-mile-an-hour winds. Is that a variable our firefighters in their ops should consider? Because here's what happens in fire departments, right? Big red fire trucks respond, and if there's a battalion chief, a chief, or somebody with them, or the captain in the front right, we say the front right, that's the person responsible for that rig. The first thing they're going to do is establish command. They're going to do a 360 as best they can on the site. Now, some of these sites are too big to do a 360, so they might do it by vehicles. But they're going to try to get as much situational awareness as possible. Fire alarm, dispatch information, people on site, emergency contact phone numbers, all those things, right? It's easy when it's flaming. It is not easy when they pull up at 2 o'clock in the morning, they've been dispatched, and what? There's nothing. But the first part they're going to do is establish incident command. So in the ERP, we should acknowledge that. And likewise, there's an input into command. And we would call it unified command, but we want whoever's product this is or whoever's site this is to be integrated there. Because most of us aren't going beyond that fence without the right people helping us make that decision. And it's our firefighters on air, it's our firefighters that are going to have to go out there and do it. Now, how do I equip them in navigating? So there needs to be real conversations like, this is how we've identified this place. We're putting out street signs, or this is row ABC. This is what the nomenclature needs. How do you guys store pre-incident plans within your product? Because the ERP in firefighter training, this can get so blown off. And we forgot to stay basic. Person collapses doing repair work. They overheat, unconscious. How do you know they didn't get zapped? So should we have that dialogue with our firefighters? What indicators might help them? What can they rely on if they got dispatched to those things that happen? Because there's a lot of other things that can happen in here. And right, we want our firefighters to own their pre-incident planning. It doesn't mean they do your emergency response and your emergency operations plan. They need to take what you've given them and put it into their system. And that would be things like where Knox box connections to open fences might be, location, current contact information, variables, other things that might start to come into play. So the IFC does have, the International Association of Fire Chiefs, does have a couple resources in helping fire departments start to navigate this. We can dumb this down. Let's go away from 300 units. You have a stored energy in a residential setting on the outside of the structure having a thermal event. What does normal look like? And how do I tell our firefighters what normal is? Smoke, gas coming out of it. If there's flames coming out of it, something oops happened. But if there's no flames, let it do its thing. Contact, figure out who the manufacturer is, call them, have a conversation, figure out what's going on. But how do I go from that level in training all the way to large building stored energy? And so there's a lot here that the IFC has tried to say, hey, look, there's a plan. But really, if you start to think about, I would say that the emergency response planning is something that is heavily pushed off. It is pushed off for a later date, but there is so much angst starting. The fire chief wants their firefighters prepared. Their firefighters are expecting to be prepared. They do not want to look silly, especially as they're all starting to go out on the site. Because nothing is like, you can hear this at a firehouse. Hey, have you guys gone out and looked at the stored energy yet? Nah, fire chief hasn't told us anything about it yet. Nah, fire marshal's not doing anything about it. You do know that your truck could go out there with us. But how do we break that down, right? Hey, I'm going out to the site. You guys want to come out with me today? We might not have this done, but we've got to start bringing that forward. And so part of when you look at the end of the day here, for everything that's going on in stored energy, this is one of the most regulated products. It's a very new product. It's growing leaps and bounds in their safety. And I think even from a fire service and building code official perspective, we are drastically growing and really helping what needs to go in the built environment. You're going to hear that today, right? These panels that are coming out in front of you today are some of the best people that are working on stored energy, that are studying it, that are helping build it. And we're going to see just how much, but there is this gap as it relates to emergency response planning. A PowerPoint's not the answer. That's not an emergency response plan. And so there's a lot that has to happen here. So I'm going to give you a little bit of an example. I wish every manufacturer would do this. It should be the name of your webpage, bigmikesbatteries.com/first responders. I've asked every auto manufacturer to do that. You can make all the apps you want. You can make all the stuff you want. Your web page, if you are a manufacturer, should be your name / first responders. It is hard enough for me to identify your product. I don't care if it's car. I don't care if it's ESS. Think 2 o'clock in the morning, a stored energy product on the side of a building, a home, is on fire, and that company, that incident commander wants to get technical data. You've got to make it very simple. Like if they're like, oh, that's this company. So let's look, right? And this is Tesla. Energy's right there. So tesla.com / first responders, energy. So if you think about this, so now I go in. Now I've got solar roof, Powerwall, industrial energy. So far I'm at 2 clicks. 3rd click, I get to their industrial lithium-ion battery emergency response guide. If you're a manufacturer, it needs to be that easy. Perfect world, it's on their CAD, it's attached to the resource. The hardest part about that is it may not be up to date. But this can start to give them some of that needed information and other things that start to happen. And so this is part of it, right? When we look at emergency response planning, when we look at site layouts and all those submittals that are supposed to come in, getting and making stuff that simple is really easy. Now, here's an open conversation that probably a lot of us have to have. We spend tremendous effort, energy to get a great submittal, to get it permit, to get it inspected. What's required in the long run? So if you're a fire inspector and you came to do your annual inspection of this building, you'd be looking for what? Sprinkler maintenance records, fire pump test records, fire alarm test records, training. That would be a conversation that has to take place. What's required in our stored energy? 1207 doesn't necessarily call out and say, hey, look, there's these ITM requirements. The fire code does, though. The fire code says, hey, look, you've got to maintain these. Now, I'm not sure, like if we put an NFPA 69 gas concentration reduction system on 400 containers, NFPA 69 has detailed requirements for ITM. That is a big process. What happens if our fan motors are starting to not propel air at the same rate that they were designed to? 20 years of a fan running, I don't know if it's true in California, but one of the leading causes of fire in Michigan is bathroom fans. Drastically different fans. Please do not correlate what I just said that these are bathroom fans. But 20 years of running, or could be running, or on and off, or not running, how do we make sure that all of this is still taking place? We know our prevention folks aren't overstaffed. We know that they're going to have regular conversation. They should be issuing a yearly permit for all these sites. And that permit should serve as our method. Fire chiefs, force your folks to issue the permits on these. Issue the annual operation permit and let that be the means to making sure these things are going. Because all this stuff that we designed, all this stuff that the manufacturers did, it's a big portion of it's for our firefighter safety. It's keeping those incidents small. It's basic fire prevention in many ways. And so the same would go for mobile ESS. Now, I think mobile ESS is going to become, how's everybody tackling food trucks? Okay, so all the battery people are like, I like tacos. Okay, so food trucks a couple years ago put this new permit requirement because we were having issues with food trucks at events. How the gas and product works and the ventilation systems. And so all of us have been trying to navigate regionalization, coordination, and how we handle it. You know, mobile ESS, if we say, hey, look, everything within that permit's required for mobile ESS, how do we get this done? Because I guarantee you there's a lot of concert providers who are like, this is way better than generators. So if you're one of those places that you think are going to start drawing those in, have that dialogue, right? Tesla's mobile charger might be drastically different. They could probably come in and go, here you go. Here's what we want to do. because they've been through this a couple times. And I think you're going to see the same with the mobile ESS. Now, the question is, I permit this for a temp install for like 10 days, 2 weeks for a big festival. How do I get my fire ops folks on top of this? What can they put within their pre-incident plan? How can I get them to identify this and that it makes sure that it's safe? As we kind of wrap up here today, one of the things I'm looking around the room, and I'm sure online, there are an absolute lot of people who were part of the ICC's ad hoc committee for lithium-ion batteries. We recently gave a presentation to their board of directors, and they released the report. So if you Google ICC ad hoc committee, you can end up getting to this full report. And the full report identified quite a few things that we've talked about today. And our job was to kind of take this deep dive within the documents and really see what could be going on. Within the ICC code development process, we have these things called code action committees. Robert Marshall's over here, and you all know Robert, that's from California. Robert has served as the chair for the last couple cycles. And within the CACs, they use tremendous amounts of work groups to help develop codes and standards. And so we said within the report that those CACs need to continue their work in making sure the ICC remains on top of all things batteries. And it's not just ESS, it's the built environment, it's everything that's within those codes and standards. That was a big proportion or big item. And there's some open code questions that we have to probably handle. What should stay in the IFC versus like a standard and say, go to NFPA 855. The way it's written today, the way it's written in 2027, there's the IFC requirements, and then you go to NFPA 855. What's required? You're never going to be able to skip the CFC and the IFC to go, but you know, what needs to be in there? That's a big question. What should planning and zoning codes have in them? Should property maintenance talk about energy storage and batteries? Some things that we're seeing that have nothing to do with ESS, but it is a form of ESS, is battery hoarding in homes. There's a lot of communities struggling with battery hoarding. What do I mean by that? They are getting and buying off-spec or end-of-life EV batteries, and they're figuring out means to power their home. And so if you start to think about where the family of codes address some of those issues, this is one of them. But one of the biggest things that came out is just everybody needs training on this topic. If you think about that code official that sent me those cut drawings to say, hey, look, I got my first residential ESS, and they send me cut sheets on lithium-ion batteries and an inverter. How do we equip that code official to be prepared for when that day comes? Because every community is going to be permitting stored energy in homes. There may not be state requirements in every state, but every community is going to have it because homeowners are expecting it. They want it. They want that safe technology. So I appreciate all the people that are in this room that were part of that. And I think it really serves as a pretty robust roadmap. Christine Reed was very instrumental as the staff rep on that. And if we continue to say, hey, look, we've got to do this education and training. Not only just how do we do a plan review, how do you do an inspection at a site facility? How do we start to equip, hey, hold on a second, we're in a building, that's not the product you submitted. Inspector comes back a couple years later, it's not the same chemistry, it's not the same design. How do we handle those? So we do have the 2027, it's hard to believe, the 2027 edition of the IFC, IBC, IRC, any of the I codes, NFPA 1, if you're an NFPA 1 state, is also in development. But if you start to look, we are in what's called Group B. So codes and standards are broken up into Group A and Group B. So Group A was last year, we're now in Group B. Cleveland in October, we will be working on that. And then what happens in the ICC process, we do code development on all Group A, Group B in front of the members. It's the last kind of formality in the code development process. There was something in excess of about 90 battery code changes in the 2027 edition. And the reason I bring this up to you is, for those of you from California, the chief and Crystal and the whole California codes team do a wonderful job of bringing the right stuff forward. And so over the next year, they'll be looking at what got done and saying, hey, look, we need to bring this forward or not bring it forward. Those of you in California, you're blessed. For those of you online, I highly encourage communities to make sure they're staying aware of what's happening in new codes and standards. I would rather see a fire chief, fire marshal, and inspector lean on the 2024 edition for guidance. Say they're on the 2018 fire code and they get a stored energy system. We do not want them reviewing that per the 2018. And I'm going to tell you in a couple slides why it becomes a problem. We want them to lean on current codes. I think all of us will say, please don't just start making up requirements. And in batteries, we're seeing it. And then we'll even see the misapplication of stored energy. And so what I mean by that is a major auto facility was going under repair in which they were going to be testing cells. They wanted to use aggregate volumes of cell quantity per NFP 855, which is the most weird grab of code that I've ever seen. And somebody had to be the designated adult and say, hold on, let's just use the 2024 edition of the IFC. You have everything you need. And they were like, didn't know it existed. And so I think a lot of us have this. I look around the room and there's a lot of you involved in the code process. You're going to hear probably a little bit later today that the next edition of 855 is now on pre-sale. Does anybody buy them anymore, or is everybody just using Link? Yeah, Link, yeah. I don't know if I buy anything. I just wait for it to come out. This was cool. I find it very rewarding to sit in a room with extremely smart people and learn from them. If you look at 855, the voice of the fire service, I will say, is one of the lowest voices. And so there is a definite attack, not on 855, but in codes and standards in general, that the fire service voice not be heard. And so if I were to ever make a plea that maybe has nothing to do with stored energy, go get involved in codes and standards. Because that's how we're going to make a difference, is getting the next people and more people involved in codes and standards. And we saw it here. There was a tremendous high interest. And it was very cool to be a part of. And there are days that I swear I had to go open up a battery book to figure out what somebody was talking about. Because some people can talk chemistries and they can talk what's on the cathode, the anode, and they know what the impacts are. There are plenty of resources. If you want to geek out on batteries, there are quite a few really good books that you can open up and go, okay, now I know how that chemistry worked in the past and where we're seeing it in the future. You're going to hear about the next edition of UL 9540. It'll be good because they're going to have a lot of clarification. But this is what's happening. Batteries are an everyday thing. And you're going to look at it from a different view, hopefully, after today. We know there's a lot of work in making them successful, but we're going to see continued products come out. You're going to see them and you're going to be like, hold on a second, is that stored energy or is that not stored energy? When we start to move it around, is it mobile stored energy? Is this just PV or are there batteries with it? If there's batteries with it, does it matter on what the quantity is of batteries and how we handle it? Okay, let's take the batteries out of this. How do my firefighters respond to this if it's on fire? This is a product that just popped up in Metro Detroit. It's got like wings that come up and it's got PV and batteries for setting new charging infrastructure. So it doesn't hook to the grid. They can just start rolling these out. Now I sit there and go, hold on a second. How much stored energy? It depends. And so is this mobile ESS? Is this going to be fixed? What permits are required? But the interesting part is this is like one of the best things about being an inspector plan reviewer was getting into some of these buildings and see what people are doing in their structures to help us out in our lives. And when you start to look at batteries, I love the ingenuity that's coming up. But sometimes with our code minds, you're just like, you got to be kidding me. Now, but how do we navigate this? How do our codes and standards make sure they stay on top to address this? And so the DIY space is there. It's there in the commercial market. It's there in the residential market. If you're bored, not today, but if you're bored later this week, go to YouTube and just type in home energy storage system. Now, I've seen what it takes to cut off the lid off a Tesla pack by a company intending to do it. There are people who can do it in their garage that Tesla needs to employ. Okay, but people will take stored energy like this and make their own. So let's go back. How do I create battery awareness training for all of our operational firefighters? Right? Manufacturers, regulators, your job is to make tremendously great products. Our firefighters are going to respond to those great products and made up products. So how do I give all of our firefighters awareness training in this category? What do they need to know? How do I get them to recognize that that's not light smoke? That's gas you're standing in, and this thing could go boom because this homemade thing, I guarantee you, didn't go through any deflagration testing. It wasn't made to stay within a container like a Tesla product or somebody else's product. And so when I say EV firefighting is easy, it's easy because we know it's there. This homemade stuff is a drastic wake-up call that's going to happen. I think last night at dinner, we started a brief conversation of at what point do we start to see enclosure-based ESS becoming a commodity in the used market? Like, pause and think. We know where we're at today, and many of you in this room are 10 years behind. Most of us in the industry feel like we're 3 years behind, at least. But let's look out 10 years. A product isn't performing to our specifications. Now, I think most of us just thought it's going to recycling. Can I retrofit an entire cabinet? What's the limitations? But let's say the whole site's going away. Can I resell that? Now you're the plan reviewer. Hold on. You guys are doing what? Yeah. We're moving everything from project X and we're shipping it over here. We're going to reinstall it. Like, that's partly where a lot of us have to start thinking beyond, because 2027 codes are done. I mean, we've got to clean them up and we got to have some hearings, but they're done. So at this point, we're working on 2030. The next edition of NFP 855 would be the 2029, right? That's not that far away. And so we have to start having a lot of conversations. But the one last little caveat that hangs out here in the fire code, which I don't envy anybody trying to do this. So in Chapter 11 of the California Fire Code in the 2024 IFC, lithium, Chapter 11 is the retroactivity chapter. Many states delete it. But this is the statement that says, hey, look, ESS installed before the adoption of the 2021 code. You need to make sure that the owner-operator is getting a permit and they're doing an HMA based on a FEMA. So if you're like, hold on a second, Mike, we have one of the first ESS systems installed. There you go. Now, how fast does this have to be done? CFC goes into effect Jan 1. I'm a local fire marshal who does this. You have one of these. Now, maybe you, the fire code official, you buy the donuts, you buy the coffee, and say, hey, we need to have a conversation and we need to come up with this. Anybody know what the crux is? Why 2018? Has to do with listings. Right? So you have a lot of product non-listed, and really, if you go back into 2018, what we had in the fire code was minimalistic. There was some stuff, but we didn't talk about it. So somebody's got to go back and look and say, hey, look, okay, so you did it, and I love this in any retroactivity. I will sprinkler the building over the next 15 years. Does that work for you? So what's the corrective action plan? What should it look like? What's the time frame? This is all out of Chapter 11. So things like system impairments, eliminating or mitigating and identifying hazards, maybe it's an updated plan. There's a lot of different things we can start to do within this space. Now, again, not in Chapter 11, but part of our process when we go to sign and seal this thing, this is part of the conversation that has to happen at a local. If I repair a fire sprinkler system, do I need a permit? Most of you are going to say no, right? If a valve is bad, I replace the valve with like. That's part of ITM work. I move a line of sprinklers over permit. Okay. So now what happens here? What's considered a repair? Like for like? Take the module out of my enclosure, put a new module in, run the system tests, run the diagnostics, follow our commissioning plan. Do I need AHJ approval? Okay, I'm Big Mike's battery pack, the X1000. It came out 10 years ago. I can't buy those cells anymore. And I need a whole module replaced. Permit? Okay, so this is where we have to change the mindset. You have a lot of expertise in this space. What's the hazard that could change, right? So you heard us talk that we need cell level, we need smoke, we need gas composition, we need to put it together. There is a complex web that is happening. You heard us say that lithium ion is not the same chemistry. And so we have this part here that we have to have dialogue. I think everybody here is going to agree that, look, modifications, repair, hey, let's delineate what repair is. And then more importantly, in our operations plan, in our commissioning plan, in our decommissioning plan, let's make sure we talk about when permits are required. And let's figure out where that dialogue goes, okay? And so all of this comes in 120739. 1207 has all of those requirements for you. And then even our folks over at UL are starting to address it. Probably one of the biggest and last little bits is what happens post-incident? Now, fire's out. I guarantee you most of our fire prevention folks get to somehow babysit this thing for the next 3 to 6 months. Depending on what it is and depending on how it goes, there is a lot within the community. Rightfully so. But most of us don't monitor post-home fires, right? If you think about we have a home fire, we might re-detail a crew out to do smoke alarms in the area for the next couple weeks. We might have the fire inspector stop by, talk with the homeowner, see how they're doing, check everything out. What's our roles and responsibility here? We got a building-based ESS. Is this now a regular visit from us? Are we going to get rekindles, what I would call rekindles? Most likely. How do we handle this? What's a fire watch? What's not a fire watch? What does mitigation look like on the site? And so many times it's going to be, well, let's start the conversation. Let's get the people in the room. Because I like, from the fire service perspective, we have to lean into this and our staff have to lean into this. And say, get the right people in the room. Let's start having a dialogue. And when I say in the room, it's probably Zoom or Teams or something else. There's a lot of stuff coming up, and I'm going to kind of tease you with this. What you know as energy storage today is not what it's going to be for some time, right? It's going to change. We have a desire to fill barges with batteries, float them into a town, and provide emergency power when needed. We have a desire to start stacking units. How does that work with seismic? How does it work with fire testing? What happens with weight? What happens with maintenance? We have lots of discussion coming up. What should be a container? What's not a container? What's an enclosure? What should be a building? Where should sprinklers be? Where should they not be? We've got the next best chemistry. So once in a while, if you want to join, this is our email list. We try to send current things out. And so as we go through today, there's a couple things that I hope you take advantage of, both online and here in person. We have got some great speakers, and I applaud the Fire Marshal's office for getting it done. They're going to actually give you a QR code that you can interact with the panels. And it will be a really neat experience to be able both online as well as here. What I would say as it relates to stored energy and this journey that we're all on. Unprepared communities, unprepared developers are creating a lot of angst. And so many times when we just lean into it and work together, the process goes tremendously well. We have had significant success with a lot of deployed energy. If you really start to think about how many units go on the ground to hit nearly 20 gigawatt hours, and we're not even talking residential. how much is happening, and it's thanks to the efforts of our code officials. It's thanks to the efforts of really good design. It's thanks to the people who are writing good codes. It's thanks to the people who are writing really good standards. Oh yeah, and all those people that are researching it. So I hope today did a good thing and it brought some light from different perspectives, because I think at the end of the day, we are all trying our best to make sure our firefighters are really prepared. We realize that accidents happen. We realize that once in a while mistakes can happen. But if we did our job and we keep it down to that cell, we keep it down to that module, it did what we train people to do in fire prevention, then this whole industry blossoms because we hit that minimum code, because we did what we were supposed to do. So thank you for having me. I'll look forward to seeing you all later. Tim.
Thank you again, Chief O'Brien, for the very informational session. Before we go into our next session, I do have one announcement. If you can take a look around your area, if you see a backpack that maybe is not yours, we have one that is missing. So if you could take a look and just raise your hand or bring it up here, that would be fantastic. We're going to now take a short break as we set up for our first panel. Please feel free to visit our exhibit hall. We're going to reconvene right at 10:35 for our first panel discussion. Okay, so if I could have everybody take a seat, we're going to go ahead and get started. Our next session will focus on codes, standards impacting battery energy storage systems. Moderating this discussion is Robert Marshall, who will introduce our panelists. Robert?
Good morning, and thank you, Tim. Really appreciate it. Okay, so we are going to talk about codes and standards. Hello, Kara. Thank you very much. So real quick, actually, wait, Kara, wait, stop. Stand right there. Stand right there. Turn around and wave to everybody. So definitely want to thank the State Fire Marshal's Office for having us and doing this, but the real star of the show here is actually Kara, that this would not have happened without her. There you go. Okay, so you guys all were really waiting for this particular thing, right? You guys all really wanted to hear about codes and standards. So yeah, I can tell Kevin is really excited about it. But I am, excuse me, I'm Robert Marshall. I apologize for the voice. I developed a cold and the voice just hasn't come back yet. So I don't know if it's the sexy voice or the, oh God, what's he doing? Why did he kill a cat voice? But it's one of the two of those things. But anyway, I am Robert Marshall. I just recently retired from the fire service after 34 years. I now work for UL Solutions as a senior regulatory engineer. As Mike mentioned, I've been very involved in the code development process. I am currently the chair of the Fire Code Action Committee for ICC and have been involved in the ICC code development world for quite a while. As chair of the FCAC, I have been very involved in the battery world and developing the codes that are in the code currently. And we continue to do that. As Mike said, we had about 90 different code change proposals that will be going into the 2027 code. And we'll continue to do that, particularly as all of the technology changes. So, just keep that in mind. I want to introduce the panel because this is actually more about them than it is about the stuff that I am going to talk about. But we'll start off right here with Crystal Sujeski.
Development and analysis, and to have been involved with this battery storage since 2018.
Please pick up the handheld mic.
And Mike,
That'd be great.
microphone. There you go.
Good morning. Crystal Sujeski, CAL FIRE Office State Fire Marshal, Chief of Code Development and Analysis. Been involved in the code development process for battery storage since 2018 codes, 16 codes before that, and happy to be here. We'll talk more later.
Good morning. I'm Christine Reed. I'm a Fire and Disaster Mitigation Program Manager with the International Code Council. I am retired Fire Service Battalion Chief Fire Marshal, retired after 32 years, kind of a retirement fail. After a few months after retirement, I joined ICC, been involved in local, state, national code development for many years.
Good morning. I'm Paul Hayes, Fire Protection Engineer with Hiller. I have had the honor, the privilege to spend an awful lot of time on the codes. I managed probably 10 plus task groups on the last cycle of 855. I've had the privilege to see a lot of products in the marketplace, from all the way from public engagement through, unfortunately, fires. I'm wonderful that I live about 2 hours from a lab in North Carolina. I can drive up, watch batteries burn on purpose all day, and then be home at night. So any questions, please feel free to ask.
Good morning, and thank you for having me. My name is Brian O'Connor. I'm a senior engineer at the National Fire Protection Association, where previously I was the staff liaison for NFPA 855 for the initial development of that. I work on a lot of different codes and standards, but these days I'm working a little bit more on products. But I've been there for about 10 years now, working on a lot of battery-related projects, and here to talk about NFPA 800.
Great. Thank you all for being here. Really appreciate it. So when you think about codes and standards, one of the things that we have traditionally done a bad job with is the speed of technology. As Mike mentioned in his presentation, we really didn't start to get into this code world with batteries until 2018. And even then it was very, very light. As the technology has evolved, we've had to keep up with those code changes, and that becomes very, very difficult. Anybody have an idea about how many codes you're responsible to know on the code enforcement side? How many codes your fire prevention people are supposed to know? Too many. Yeah, very nice, Stephen. Appreciate that. What's that? Yeah, all of them. That was one of my favorite things as an AHJ. It's which one do I need to comply with? And I'd pull out the books and I'd stack them and I'd say all of them. Well, but which ones? All of them, right? It's about 27,000 pages. Okay. Now, do all of those apply? Not necessarily, but if you get down to it, really you go to, there's a goal, right? And the goal really boils down to three things. Stop the fire from starting to begin with. That's the number one thing, right? If we can stop the fire from beginning, everything is great. But how many of you know that we're never going to stop all those fires, right? We know that, right? So what's the next goal? Keep everything small, right? Keep everything small. So make sure that we keep that fire as small as we possibly can. And if we can't do that, then we need to get everybody away from that. We need to get people out, and we need to get our responders in and out safely, right? That's the goal of the code development process. Now, how quickly we can do that, that is where the problem comes in. And particularly when you have a new technology like battery technologies, that's where it becomes very, very difficult, because you have to try and do that. The thing to remember is that the code development process is a continuous process. You're going to hear from all four of these people today talking about that continuous process. We're getting ready to release the 2027 code. We'll vote on that. We'll have all of those things go out. But as soon as that's done, and in fact, before that's done, we're starting on the next process. We had a meeting yesterday with all the FCAC people to talk about exactly that, about starting to get your ducks in a row to know what it is that we need to move forward with. As Mike mentioned, there's a lot of new technology that's coming. Some of the technologies in the battery world, we have some things that can't go into thermal runaway. That's great. However, when they go into overcharge situations, they produce different gases. One of the gases that they produce is oxygen. So now we're going to trade a hydrogen-rich atmosphere for an oxygen-rich atmosphere. What kind of problems is that going to create? So we have to keep on top of all of that. We have to keep talking about all of the different technologies, all of the different things that we need to do to keep everybody safe. And that's what this panel's point is today. Okay. last thing that I want to talk about is getting involved. And Mike touched on this a little bit, but there are a lot of us who have been involved in this for a really long time. And there's a lot of us who are getting much older in doing that. We need other people to take over. If you are a fire chief or if you are a fire marshal, my thing to you is you need to start letting your people go to these code development pieces. It is vitally, vitally important. I can't tell you how often I've seen people say, well, that's dumb. Why did they do it that way? The reason that they did it that way is because you weren't there to say anything different. That is super, super important. Best example I can give you is in 2010, we were able to get residential sprinklers into the fire code. We got them into the International Residential Code, created a huge ripple effect all through the industry. It changed how the code development process worked, right? When that vote was done, everybody was high-fiving, everybody was really, really excited, right? The very next vote that happened after all the fire people got up and left the room because we had been successful with the sprinkler thing was a proposal that would have required labeling of lightweight construction in residences. You would have had a marker on every building that had lightweight construction. But fire service got up and left the room and didn't vote on that, and it got voted down. And that got voted down very specifically because everybody was pissed off that the fire sprinkler thing went through because fires stacked the room. Otherwise, it was going to pass. You have to be involved, and it's not just on the things that are sexy. You have to be involved in the whole process. So please consider that. Please consider sending your people to that. So with that, let's move on. I'm going to turn it over to Crystal to talk about the California versions of the code development process.
Thank you, Robert. So is this the clicker here? All right, so CAL FIRE, Office of State Fire Marshal, we get our authority from the Health and Safety Code. This is a law. Legislation gives the State Fire Marshal a very broad authority to protect fire and life safety standards. 13108 authorizes the State Fire Marshal to promulgate and prepare, adopt those codes and standards that will help achieve that. And one of the main aspects of that is safeguarding against flammable vapors, toxic gases that were just said, all of these things that are battery energy storage system related. And the empowerment of the State Fire Marshal to establish these minimum standards for that fire protection includes the design, installation, and the maintenance. So while the CPUC, or the California Public Utilities Commission, and the California Energy Commission, they partner to regulate performance, the State Fire Marshal maintains the primary authority for protecting those fire safety components. So adopting and amending Title 24, Part 9, that is the California Fire Code, is a very important piece in that mission or goal. And so with that, we coordinate with our local AHJs, with our sister agencies, and we really take the step forward in creating these work groups. Those work groups are the consensus process where we can get your buy-in. How is this going to benefit you? What are the cost impacts of the regulations that we are promoting or proposing? And what is the overall outcome when they go into effect? How will you be able to enforce them, right? Because it is a delegation of authority from the State Fire Marshal to the local and, you know, ultimately the inspectors that are boots on the ground. So State Fire Marshal also leads in training, guidance, putting those best practices out there. We are a customer service organization, and you can call us for code interpretation requests. We are holding this symposium really because of this hot topic, the interest from all of you, and we really want that participation. So please subscribe to any of our mailing lists, participate in that national development process as well as the state process. So the baselines of the requirements you heard from Chief O'Brien this morning, system thresholds and classification. What is the size? Over 20 kilowatt hours requires full compliance, right? Over 600 requires those enhanced mitigations. Location, access, and spacing. Is it indoor versus outdoor? Minimum separation distances. Fire separation, detection, hazardous gas management, safety analysis, signage and labeling. We need to be able to get our first responders in there, let them know what they're going to expect. Contact information, plan review, inspections, and that pre-planning component are all going to be your baseline requirements. Statewide response to incidents. So we heard a few incidents this morning, but Moss Landing, there was an incident in 2002 and 2023. San Diego, Otay Mesa, 2024. These events promulgated the California Utilities Commission safety rules. It also increased state fire marshal engagement. We were there to create a report, do an incident management response plan with partnering agencies. We have lessons learned. Firefighter PPE is now being researched and evaluated. Is it the right PPE that our firefighters are wearing? Defensive tactics. We used drones, we used robots. There were other things that came into play. EPA and the county environmental health, as well as air monitoring. Moving forward, we'll be updating the fire code with available codes and standards. As was mentioned, there is a intervening code cycle here that we have the opportunity to early adopt codes and standards that are in the development process. So we'll be doing that, looking at those model codes, the NFPA 855, the international codes, as well as the UL standards. So there is some active legislation. SB 1152 was in the 2024 session, and what that did was directed the State Fire Marshal's office to update the building codes and standards and mandating those emergency action plans, as well as SB 38. And then there is a Governor's Order 167, which said that there is incident oversight from our sister agencies, and State Fire Marshal will help in those responses. So hosting training programs like this, we're also available to go to your local fire building or fire official meetings, either county-wide or region-wide. So please reach out. Improving data collection. This is one of the big things that we found as a gap. And we want to enhance the awareness of collecting that data so that we can make the codes robust enough for those safety. And then increase alignment with our other sister agencies for certification and permitting, which you'll hear later. So I really appreciate the opportunity to be here. My name is Crystal Sujeski. This is my contact information. And again, subscribe to any of the State Fire Marshal's newsletters so that you can get the up-to-date information. Thank you very much.
Good morning. So before we get into kind of what's currently happening, I wanted to give a brief history of the I-codes related to batteries. So 2006 codes is when the lithium ion battery was first referenced. but the legacy codes talked about stationary battery systems like lead acid. So it was really 2006 that the first references to lithium ion batteries were introduced. But as Robert said just a moment ago, it really wasn't until the 2018 codes that batteries were really addressed. So this work was happening in 2015 to get ready for the 2018 codes. And that was the majority of the work by the Fire Code Action Committee. So it was the 2018 codes that first introduced Chapter 12 and the enhancements for batteries and especially lithium ion. Once we got into 2021, it was a further expansion from the 2018 codes, and it also added some outdoor and rooftop installation provisions. So you could see this evolution as we saw batteries and ESS in our built environment over the years, the continual need for reevaluation and code change proposals to stay up to date and stay in the real time when it came to this issue. The 2024 codes, that was an enhanced exceptions because we were seeing that we were really protecting from fires. So there were enhanced exceptions for in the 2024 codes, and that's when NFPA 855 provisions or references were first introduced as it was a new standard. So we made those changes to be able to refer the user back. The interesting thing before I get into the 2027, so if you are interested in seeing what the changes from the 2021 to the 2024 code is, if you subscribe to ICC's Digital Codes Premium, if you go into the respective code and click on Insights, Insights will take you back into the code, but now you can look at what the new language is, what the deletions were, and it also links you to the actual code change proposal. So if you wanted to read how it was presented, what the changes were, what the committee's response was, you can do that all through Insights. So it's a really great tool for you to refer backward to see what the changes are for your information and reference. So as mentioned before, the 2027 code cycle is in progress. There are a few changes as well as we continue this evolution. Chapter 43 is a new chapter that is going to put a lot of the battery provisions in one place. Now, in the 2024 codes, we created section 320 for storage and 322 for micromobility devices. So the proposal that's on the table now that is in this 2027 process is to move 320 and 322 into this new chapter 43. It also, in the 2027 cycle, is reevaluating Chapter 12, now that NFPA 855 has been out for a while. It's reevaluating the charging and enforcement language in Chapter 12, and then removing language that may become duplicative from NFPA 855, and then just referencing it back. So it might lend to less confusion. And then in the residential code, R330, we did the same thing. We enhanced or clarified some enforcement charging language and then referred to 855 for correlation. So I wanted to talk a little bit, I wasn't quite sure Chief O'Brien had it in his presentation, but I just wanted to give you a little bit more information about the battery and energy storage ad hoc committee that ICC stood up. This committee was an important committee. Not all issues are addressed by the formation of an ad hoc committee. It took a board of directors approval. So the fact that this ad hoc committee was approved to be formed and given the scope that it was, shows the importance that ICC has on this issue and trying to stay current with what is happening in the built environment and trying to stay in current issues within the codes. So the scope of what the committee was charged with was to explore the built environment and how building safety was impacted by the ever-changing evolution of batteries and ESS. The committee was made up of 23 members across the country, led by Chief O'Brien as the chair of the committee. Code officials, manufacturers, researchers, fire organizations were all a part of this committee. But I will say that beyond the 23 in the committee, we had over 100 interested parties that were wanting to be a part of attending meetings, to participate in the discussions, to help the committee formulate their findings. The goal was to identify the risks that the built environment is seeing and what gaps or areas of effort need to be addressed in the codes and beyond what we actually found out. But the original scope was to look at the codes. But we found that it developed into a lot of other aspects exclusive of the codes. So we had 4 work groups with 4 different focus areas: residential ESS, commercial ESS, manufacturing, storage, and recycle, and EV and micromobility. And the work that was done by these 4 work groups was astronomical in being able to develop the opinions and the needs that we found. That was all compiled and put into the comprehensive report that Chief O'Brien referenced. If you go on the ICC website, if you do icc.org/AH-BES, that's a quick way to get to it, then you'll be taken to the Battery and Energy Storage Committee webpage, and you can reference it. A couple of clicks with resources and so forth, but you'll be able to get to it. And I really encourage everyone to take a look at it. It does talk more than just what the codes are, but with regard to recycling and response and mitigation. So it is more than 50 pages, so it is a long read, but it is definitely very, very informative. So ICC is continuing our efforts in the battery and ESS topic arena. Our technical services team continues to work on code development and mainly through the FCAC to keep current code proposals going into the 2030 even. What do we need to address that hasn't been addressed yet in this changing environment? The fire and disaster mitigation team, subject matter experts that can help all of you. We are here to support you moving forward as we maneuver through this. Content and product development. How can we get more training opportunities, more online technical guides to assist all of you in your research and your data collection and your information and education from a code development side, from a code official side when you're doing plan reviews and so forth. And then government relations team, we are working towards the member engagement. So everything that we're talking about that you may not hear from any other specific team, our government relations team, which is really kind of our backbone to all of our chapters and to our members. They will be disseminating all of this information in support of getting feedback from all of you and anything that we can do to help support you. So this is my contact information. Please let me know if you have any questions or concerns. If you would like to be a part of our Fire Service Membership Council, which is a membership council that isn't strictly for fire officials. You can have building officials, sustainability, code officials. please let me know. You can sign up through the website, but this is where this battery issue really grew legs when it went through the Fire Service Membership Council. So we do talk a lot about current topics that I would encourage you to be a part of. Thank you.
Good morning again, and it's absolutely an honor to be here. Again, my name is Paul Hayes. I spend way too much time talking about battery safety, but I'm really excited to be here to talk a little bit about 855 today. So what presentation would be complete without a legal disclaimer? I am not while I am a principal member on 855, I do not represent 855. I do not represent NFPA. These are my own opinions, so take them for what they're worth. But I will say that we are getting really close to publishing 855. There are a few challenges in the industry right now that we've got to work through in the next month or two. Keeping our fingers crossed, it will be published probably September, maybe October at the latest. If you haven't had a chance to look at it, I don't know whether you can maybe get online, but there are an awful lot of best practices in there. This was developed over the last 3 years with some phenomenally talented people that I had the privilege to work with. A lot of them are in this room. A lot of them you guys engaged with. So I always encourage, you know, one of the biggest things I see with this group here today is meet your peers, learn from them. They're facing the same issues. Talk to some of the experts, get their opinions. There's a lot of value in this room and online. So as you guys know, probably I ended up having to fill in for Bob. If you haven't run across Bob, he's probably one of the most knowledgeable gentlemen that I've ever ran across when it comes to code issues. So I'm going to try to fill his shoes today. I may not, but I can tell you that I can wear his hat. And I will do the best that I can. So what happened from 23 to 26? So I'm going to spend 5 minutes trying to tell you what we accomplished over the last 3 years and the effort that went into this. So a lot of things that were already in the code, we better clarified. We came up with a better way to describe it, give more information, give more guidance. We didn't fundamentally change what was in the code. The change from the 2019 or 2020 code to the 2023 shifted away from fire to explosion after one of our sites, McMicken. Haven't heard that word yet in today's presentation, but it tends to still be one of the defining moments, the bellwether event that kind of changed us from the concept of fire to the concept of we may have to deal with the deflagration. We had 28 plus task groups. I know I kept hearing, okay, well, we had, 70, 80 inputs. Even for the third cycle, we had 300 plus, and I don't know what the number was, public inputs, and then 300 plus public comments. So there is still changes. And even as such, we are already looking at task groups for this upcoming cycle. What is it we need to address? Because we're always behind. No matter what we do in code language, consensus standard, we are always behind. So what is it that we've learned in the last year? What is it we need to adjust? What did we miss? What can we define better? I would encourage you guys, as we had the question, get involved. These task groups are open to anybody that has knowledge, and we welcome that knowledge. That's the best things that we've done. Some of our task groups have been 30, 40, 50 people to get input. So please ask one of the committee members. There's a lot of committee members here available today. Participate. Give us your insight. Give us your lessons learned. We all benefit from that. We have looked at a lot of the failures in the world. We understand some of the things that happen. Can't always give you all the information. It's protected sometimes behind NDAs, which fundamentally, I like groups like this because it share the knowledge. As much as we can share what we learn, best practices, please take that to provide that data to the rest of the world. What can we do better? So we have taken into a lot of consideration the things that we've seen. Haven't seen a whole lot of surprises. Now, have there been events that have been newsworthy? Obviously, a fire tends to be newsworthy, especially some of the ones we've had recently, but none of them really came to us as a surprise. The industry, the codes have kind of taken these into account. So again, as soon as we can get this 855 into play, even if you're just looking at it and going, hey, this makes sense, take advantage of the data and the lessons that we've learned. So a couple of the overarching assumptions. An event can happen that will overwhelm the inherent safety systems that we have in place. A lot of the things that we've seen were not necessarily started with the batteries. Were they, and I'm going to steal from somebody in the audience here, were they the victim or the villain? So a lot of times they're the victim. They didn't start the fire, but they had to pay the consequences: water intrusion, lightning strikes, failures of just people. You know, things happen. We write the codes on the back of failures. So we want to control propagation between units. We talked a little bit about let it burn. You guys have a propensity for action. Don't let it burn. We want to put it out. But there's a reason that we let it burn. Events are over quicker, no stranded energy, no reflash, no water runoff, and probably most important, we don't jeopardize life and safety. Now, we also realize that there may be situational conditions that may define that you have to respond, or the mayor may live across the street and that may not be the most palatable approach that you have to take. Ensure listings, reliability, and survivability. We want to make sure that the critical safety systems survive a failed event. So we moved away from this concept of a single fault condition. Okay, we lose power, what happens? We have a high heat condition, what happens? We have a battery failure, what happens? So those critical safety systems, the combustible gas concentration, the gas detection, the fire system, even the HVAC, all have to function if we lose power or there is a failed event. That's taken into account. We want to protect life and safety. We talked about that large-scale fire test. Very critical for defining that we don't want a whole field to go up. You can have faith that, even at 6 inches apart, that even if we lose one unit, that we don't go across the aisle. Because the assumption is if we go across the aisle, we are probably going to see a fairly significant event across most of the units out there. That's the last thing that we want. We are working on the large-scale fire test. We're real close. You'll hear from Alex a little bit later that'll talk about where we sit on that, but I think that's a big improvement in the code and what we're doing. So looking forward to the continued improvements. So let it burn. As I said, no reflash, no stranded energy, no runoff, and an asset is not worth a life. Always keep this in mind. It's a piece of equipment, so what? Let the insurance companies worry about that. So let it go. Do not engage if there's no reason to engage. So what do we change? HMA, it's just required. We used to have a lot of conditions in there. You just got to do it. Bottom line, get it done, put it out there in the marketplace. Critical safety systems. That changed that fundamental approach on how we address things. So we've defined a whole range of what we consider critical. 9540 listings. We were finding that even though we had that nice little mark and stamp on it, that not everything was done. So there's an exception requirement now. What did you not do? That is required to be submitted to the HJ. What didn't you do so we can bridge that gap? Now, your fire protection engineer may be able to bridge that gap. Maybe they didn't do an evaluation on the 69 system, but your fire protection engineer can. Power backup. We went from what would you traditionally see in an NFPA 72, says 24-hour and 15 minutes an alarm. Now we're saying, based on the fire test, what is your power backup requirements to keep those systems functioning up until fire? Okay, once fire's in there, all bets are off. Your fans are not going to survive. Your fire panel's not going to survive. Although I will tell you, we did a large scale fire test one time and we left the fire panel on. Learned a lesson. Do not leave your horns and strobes on. That horn and strobe went on for 8 hours during that test. Data reliability, make sure there's information available to you to make an informed decision. No suppression. We don't want to stop it. Water tends to be an abuse condition, makes it worse. Large scale fire test. Integrated testing. All of it has to be tested together. Explosion control, better clarification, requirements, details on what to expect. And again, container propagation. We do not want to see propagation from container to container. 1 unit, okay. Love that term, successful failure. We saw a little bit earlier. 1 unit went up. That's what we tested to. Successful failure. We failed and it did not go any further. So that is a 5-minute dissertation on 3 years worth of effort. But again, great. I think they did a phenomenal job. We're looking forward to the next cycle just to continue. Please provide your input. So there's my contact. Reach out, ask questions. I've heard the comment many times today. Have those early meetings. Absolutely 100%. Engage your guys, ask questions. It's okay. We want to go into a meeting and basically tell you, I'm here to give you information early and often. Don't be afraid to ask that question. So thank you.
All right, saving the best for last. Although I regret to say I do not have any props. Paul's a tough act to follow. All right, let me see if I can grab this. All right, I'm going to be talking about NFPA 800. So there's a ton to learn over, honestly, today's conference. So if you're going to walk away from today with only 2 or 3 things from me, one, there is a new provisional standard, NFPA 800, that's currently in development. It should be the roadmap to go to when you don't know where to go for battery regulations. That's pretty much it. That's the big takeaway. So I'll go into some more detail, give you more information about how to get involved, about what it's going to cover, and kind of some of the thoughts and questions that led to the development and the initiation of NFPA 800. All right, NFPA 800. So on the screen here, we have a couple of the problems that NFPA had a little brainstorming session saying, what are the big issues going on with batteries and what's something that we can do to help provide solutions for that? So one of the big things that we've noticed is that except for maybe NFPA 855, a lot of our technical committees who develop our codes and standards don't have an in-depth, supply of battery experts on their committees. We'll often have people going who submit public inputs and public comments who represent, either battery experts or manufacturers. But it's really tough for someone like, I think Chief O'Brien mentioned, NFPA 13 doesn't have information on how to protect battery installations. And it's because they said, hey, we're not battery experts. We don't know how this should go. So one of the solutions to that is NFPA 800, a technical committee that does have this vast knowledge, in-depth knowledge of batteries that isn't necessarily only put in the box of energy storage systems like NFPA 855 is. Something else that we constantly get feedback is it's tough to find battery regulations for things that maybe not mainstream energy storage systems or installations that maybe don't quite look like a battery, but might be, or things throughout the life cycle of a battery, such as your raw materials, your storage before they become batteries, the manufacturing of batteries, the manufacturing of products that have batteries in them, the storage of these. So there's a long life cycle, including the end of life, recycling, disposal, that there's a lot of steps that we're looking to find information that we don't necessarily know where to go. Even if there is some regulations out there, it's very difficult to say, all right, well, where do I find information for, how to protect a recycling center or disposal area? Something else is that there's hazards present, unique hazards present throughout the life cycle of batteries. And that's, again, from raw materials, manufacturing, transportation, storage, use, end of life. There are unique hazards for each one of those steps that aren't necessarily addressed, or if they are addressed, they're very difficult to find. And that last one, NFPA 855 scope creep. NFPA 855 in the NFPA ecosystem just is our group of battery experts. If we're looking for where to put new battery requirements, that's where we would go. They started creeping a little bit outside the scope of energy storage systems to storage of batteries, but like it was needed. And so that's where we put it. And that was the group who had the knowledge to do that, trying to relieve them of covering everything batteries. NFPA 800 technical committee has been formed. Bottom there we have our solution. So again, this is the group of experts, the technical committee on NFPA 800. This should be a roadmap. I'm going to make a lot of promises that I don't personally have to follow through with because the technical committee writes these. So I'll thank our chair, Matt Pace, as well, who's hopefully going to be backing up all the promises I make. So thank you in advance. So it should be a roadmap to go to, especially for this initial cycle of existing documents and where to go with them. It's going to address the entire life cycle, and even if it doesn't necessarily have regulations for each part of the life cycle, if we say, hey, let's look at the whole life cycle, let's match up existing regulations where they exist, then that should really highlight where those gaps are, because there's going to be some spots that say reserved. We don't have any regulations in this area that we could reference. And there's going to be an appropriate scope, so they're within their kind of own jurisdiction. All right, so NFPA 800 has an official technical committee scope that's paraphrased on the screen there, has a responsibility for documents on hazard identification, prevention, control and suppression of your fire, explosions, and related hazards, of cells and batteries during, and then I have items 1 through 9 here. It's kind of a big scope, but these are kind of what we consider the life cycle. Your handling of materials, manufacturing, assembly, transportation, storage, installation, operation, recycling, disposal, repurposing. All right. Sorry, I know you guys know how to read, but yes, that's what it's going to be, and that is the technical committee scope. The document scope is something that the committee itself will help form to help narrow that even further, to say, hey, this is NFPA 800. There are technical committees that have multiple documents. There are documents that have multiple technical committees. Right now, as this is starting, it's going to be a one-to-one, one technical committee, one document. All right. And then I feel like this is kind of the more important stuff. Where are we now? Where are we going? How's this going to work? So I mentioned, I think just very briefly, that it's hoping to be a provisional standard. Provisional standard is something that only has kind of one cycle of revision, only maybe a first draft meeting, and not, as most NFPA documents have, a first draft, second draft, notice of intent to make motions, and it goes to our technical session. This provisional standard should only have one revision cycle, one revision layer in there. And that's just to expedite the process, to get something out there that does have, hopefully, these references, we won't have to reinvent the wheel for the most part. And so that's going to be closer to a 1-year cycle than maybe our typical 3 to 5 year cycle. Again, making promises I don't have to keep. So hoping to have this a very condensed revision cycle that allows us to be able to get information out there on these newer technologies that is difficult to keep up with for our codes and standards. This does mean a few things. One, we're only going to have a first draft meeting. There's going to be no second draft meeting or NITMAM, as I mentioned. Public inputs or public comments, whatever we're going to end up calling them, don't need to be responded to. So if you are going to help in the development of this by submitting a public input or submitting a recommended change to the initial draft, you typically would receive a, hey, yes, we made that change, great job, or no, we didn't make that change, and here's the reason why. For this provisional standard, we won't be submitting those, and you won't receive those. Okay, so that's kind of just the big differences that I see for provisional standards. So a committee has been appointed back in December of 2024. The scope was approved in that same 2024 meeting. The kickoff meeting just happened this past May, early May. The committee then is going to develop the draft document. That draft document is then going to be reviewed by the standards, or not reviewed, but the Standards Council is going to assign a revision cycle, and the draft document is going to be open for public input. So it's going to be published so that people can submit public inputs on them. There are some more dates that I don't have up on the screen here that are very important. I believe it's August 11th and 12th. There's going to be a virtual meeting. This is a pre-first draft meeting. So this is going to be, for the most part, a formation of task groups. That's a great way to get involved with the technical committee if you are not on the technical committee. And I recommend being a part of those conversations, even if it's something that you say, yeah, I have some expertise in, but I want to participate to, learn more about X, Y, or Z. I always encourage it because they're going to say something and you're going to think, hey, I have some sort of comment on that. I have some more information I can provide. The more people in these task groups, typically, the better they can work. And then we also have, I believe it's October 21st to 23rd in Quincy, Massachusetts, another pre-first draft meeting in person, where I believe it's the intent for a lot of those task groups to report out and to develop that initial draft that will then be published for public inputs. All right, so I know I kind of went through a lot of the processes, but I was told to keep it short. So I think that's it for me. I think I have any more slides. Nope. And I'll hand it off for some discussion, hopefully some good questions. Appreciate it.
Okay, so now we get to the real crux of things. What questions do you have? So if you scan this, you can ask a question, and they will put the questions up here for us. So we will have that. So we'll give you a second for that. You bringing up the questions? Perfect. Thank you so much. Okay, so our first question here, are built-in fire suppression systems mandatory? Who wants to take that one on? Paul, I think you wanted to.
How could you tell? No, they're not. Actually, we removed them because of the concept of let it burn, that strategy, and we can use a more palatable term, observe and contain. It appears to be a little bit more active, but the bottom line, the unfortunate thing with batteries, if you address the fire hazard, the explosion hazard gets worse. If you address the explosion hazard, the fire hazard gets worse. So why put out a fire that creates an explosion condition that ultimately, if it's burning, what burns doesn't explode? So fundamentally, suppression is out of 855. There's no reason for it to be there except for exposures or buildings. So not for the batteries.
Did you want to add anything?
Yeah, I would just add, except when it's like in a building and you don't want that fire to spread. So yeah, for outdoor installations, again, we want to see them on concrete pads, kind of out in the middle there. They don't necessarily need a sprinkler system or anything like that if they're kind of away from exposures.
Okay, great. Next question, are there any IFC, CFC regulatory listing requirements for BESS below 20 kilowatt hours? And is there any data on NMC versus LFP incident rates? Crystal, you want to start on the listing requirements?
So the below 20. So yes, I mean, UL 9540 is the pinnacle listing standard. The codes do trigger that 20, is kind of like that trigger mark for that listing. Below that, it is highly encouraged, even though it is silent in the code.
Yeah, and just from the UL perspective, one of the things that I would add to that is there are sub listings, and I think Mike actually brought this up. There are sub listings that have to happen, right? So if you have an inverter, for example, that has to be listed. The batteries themselves have to be listed. So even though something isn't listed necessarily to 9540, there are other listing standards that may apply. So that's just something there to keep in mind. Our next question is a key concern. Actually, back on the previous question, LFP versus NMC. Any data on that?
So I don't know that there's real good data out there. The NMC tends to catch fire very quickly and very easily. The LFP produces a little bit more gas. So fundamentally, we still end up in the same place. Some of the history of the events is a lot of the older systems that we've seen even in California. But I would say a lot of the outside buildings, we can set buildings aside. Outside of buildings, even the container fires that we've had, even with older technology, haven't propagated. So we've seen some good things with containers. And I think Mike alluded to it a little bit earlier too. We are seeing small level events, which I think is a good thing, that they do not go beyond a single cell. So those are more prevalent than you may realize that exist in the industry, but they fail single battery, they replace the module and they move on. I think that's a good one. I've also seen a number of fires that haven't made the news, older technology, they burned. Fire department showed up, said, hey, yep, it's on fire, thank you. Let me know if you need anything else, and left. And they were over in 8 hours. And so that's a good thing, that we're not necessarily seeing the public response, the newspapers outside of buildings that are picking these things up. So I think it's going to die down a little bit. I hope as we move forward that it becomes a little bit more of an accepted, and we have some successful failures. We just may not hear about them. So I think that's a good thing where the industry is going right now, but that's fundamentally the NMC. A lot of the things that we're burning and we saw earlier wouldn't have happened with the current codes right now. So I think there's been a big improvement on that overall.
Yeah, and I think it's worth noting too that a lot of the incidents that you have seen have occurred in things that were pre-regulation, right? So you're not seeing a lot that once you have something that's listed, once you have something that's installed per code, you're not seeing a lot of failures in those particular instances. A lot of it is not in that particular thing. So great answer. Okay, next one. A key concern is public education. What easy to understand materials will be provided to the public to help people stay as informed as possible as standards improved? Want to take that on, Brian?
I can at least mention that I believe Chief O'Brien mentioned this earlier. The theme for this year's Fire Prevention Week is battery safety. And so we'll be publishing a lot of helpful information and infographics and things like that to share with your communities to help communicate this, because I do find that the easier something is to transport, the more difficult it is to regulate. And I think so public education is going to play a huge role in fire safety in general for these batteries. And yeah, it's tough. It's easy when something's bolted to concrete to say, all right, let's make sure there's regulations on this. But it's another thing if something just constantly moves. We see these e-bikes, these scooters, these larger, maybe not necessarily BMS safety things.
And Crystal, I think you wanted to say something too.
Yes, as mentioned earlier by State Fire Marshal Chief Berlant, the State Fire Marshal website does have an energy storage page, a web page that is a hub of information. We did a webinar that was very high level, public oriented. And so that is really our public outreach for that training. Could be used for fire service, could be used for general public as well.
And Christine, does ICC have anything?
Yeah, so ICC is currently under development for a microsite on our website specific to battery and ESS information. And this is information, education, research and data collection, or support for an end user to come to and get as much information as possible. This could be for a code official, this could be for a member of the public. We're hoping that if someone was to Google battery or ESS safety, we would come up on the results go to this microsite, that we can put informational documents that our plan is to create resource materials that a code official could use for the public. So if your agency may not have the resources or the staffing to draft or create documents, we would be there to create those documents for you to use to pass on. So we're really excited about the development. It is on a fast track. So we're trying to collect as much information as possible and get it out to all of you as well as the public.
So real quick, a couple of other options out there. There's some trade organizations. ACP has some specific battery sites. CISA, California Energy Storage Association. Obviously, go to some of the manufacturer sites. They've done a real good job of producing data. It would be wonderful if all this was like in a nice cohesive package, but it doesn't really exist right now. But share the data, always.
Yeah, and as Chief O'Brien pointed out as well, the IAFC has a lot of resources as well. So you can use all of these things to do it. And the great thing about it is that all of these sites are updating constantly as the technology changes. So it definitely is something to keep an eye on and keep going back. That actually kind of leads into our next question when we're talking about resources. Is anybody aware of any ordinances for decommissioning a grid scale BESS?
Okay, just tell me to shut up if I need to here in a minute, but I haven't seen the ordinances, but a lot of times it's required from land use planning that it gets early on to ask for that, no matter where you are in the country. That tends to be a upfront requirement to sign off on. So there are a number of people, again, some of the experts out there that have created these. So they are available. I don't know that there's a good collection point either, but it's almost a sign off on the property. You got to have that decommissioning plan in place early on.
Yeah, Brian.
And I could just add, I also, the EPA has some information on the end of life for these battery systems, on what needs to be done as far as the environment goes. So that's something at least to lean on. But yeah, I think that's all I'm aware of.
Yeah, and keep in mind when you're looking at those kinds of things are going to be very site specific. So having somebody else's ordinance might give you an idea of where to start, but you really need to have something that is very specific to your jurisdiction when you're doing this. This is not the kind of a thing that lends itself to a one-size-fits-all kind of approach. So just keep that in mind. Next question is, elaborate on CFC 1207.3.2 that states ES management systems shall be part of the UL 9540 listing or be listed separately. What does it mean by listed separately? Paul, this is probably a good one for you. Yeah, so CFC 1207.3.2 states that ES management systems shall be part of the UL 9540 listing or be listed separately. What is meant by listed separately?
Well, part of what we try to do with these codes is realize that it's an international standards. And sometimes the code may apply differently in different countries versus that UL listing. So my belief on that is it's really meant to incorporate other areas of the world. But I would say for our purposes in the US, we should be tying back to that UL standard. Because I think you'll see the same type of thing in 855, listed or equivalent. But that's really what that's for.
Yeah, as a UL guy, I appreciate you towing the party line on that. Thanks. Yeah. Yeah, and Paul's exactly right. You have to remember that these are international codes. So Canada may have different standards. Europe certainly has different standards. Asia has different standards as well. So where those apply, that's the intent of that. So, okay, next question is about mobile ESS. For mobile ESS above 20 kilowatt hours, what are the requirements for suppression systems or supervision during charging? That's a great question. Paul is getting a lot of
Yeah.
exercise.
Yes, wherever they are established as their home base has to effectively operate as if it was a permanent location. So the requirements would still be there. You can deal with some short-term interconnect issues, maybe still NFPA 70 requirements for connection. Again, no suppression. We really don't want suppression on any of these batteries. I mean, if we've got water, it's basically for exposures only. But effectively, you can have temporary connections, but it does need to be treated as a permanent ESS at its home base. And then the mobile requirement applies to 30 days. So effectively, if it's at a site someplace beyond 30 days, it should be considered a permanent location, and what can happen there.
Yeah, it wouldn't be out of the ordinary for somebody to put something on wheels and say, hey, the codes don't apply, right? So that's why this was developed the way that it was, because we realized that somebody might do that. They might say, well, no, you can't regulate this now because of the wheels or whatever. So, okay. An earlier slide indicated that the new edition of UL 9540 will evaluate the effectiveness of the fire extinguishing system. Will the extinguishing system be tested during thermal runaway? And the answer to that, I believe, is yes, right, Alex? Yeah. So that's Alex Schraber over here with UL. She's been very instrumental in helping with a lot of the stuff regarding UL 9540, and you're going to hear from her later. But yes, that's absolutely the intent, is that does the system work during thermal runaway events? Not, it doesn't do any good if you have a system that activates and that it doesn't actually do anything to the fire. Anybody on the panel want to add anything to that? Paul is like, no, I've been talking too much. But great question. NFPA 855's HMA and NXD let AHJs waive requirements if an ESS doesn't pose lithium-related risks. Is this a pathway being used to support safer, non-liquid chemical alternatives?
Yeah, absolutely. And unfortunately, a lot of the codes get written because lithium ion, we tend to be focused on that. So we try to back ourselves back down every once in a while and go, wait a minute, what about other technologies? Can we prove it? Again, Mike kind of mentioned new technologies. Do we have the data? So we tend to err on the conservative side and say, give us more requirements under the code. But things like lead acid batteries, aqueous solution batteries and so forth should be excluded from the requirements of large scale testing and those type of requirements in the code.
Yeah, and I believe 800 is going to kind of address the same things, right, Brian?
Yes. Oh, right. Yes, the initial edition, for the most part, should address lithium ion batteries because that's just per volume what we're seeing the most today. But you're right, it shouldn't be blanketly applied to all battery technologies because there needs to be some sort of leniency for those if they are safer, they don't have the same sort of unique hazards these lithium ion batteries present. We don't want to protect them the same way.
Yeah, and there are a lot of groups in the Bay Area in particular, I would imagine all over, who are looking for the next type of battery, looking for the next type of solutions, the next type of batteries that may not have the same characteristics. But anytime you have that sort of thing, you're going to trade one problem for another. And so it's really looking at, what are you going to have? Is it going to be fewer charging cycles? Is it going to be less energy density? Is it going to be different gases produced? So, the codes are trying to address those new things so that, as Paul mentioned in his thing, the codes are always going to be behind. But how do we make the code such that we can still do some of the things that we need for safety with the new technologies, even though the code doesn't actually address the new technology directly? So that was a great question. How is the current federal administration going to affect the enforcement of these codes, especially with its current perception of environmental codes being limiting and not enforced? Who wants to take this on? Yeah. So I'll take the first stab at it, and then Crystal apparently wants to jump in. And Daniel is over there. He's like, I'm leaving the room now. Yeah, exactly. So ultimately, it's probably not going to matter. The batteries aren't going away. The safety involved in these systems is paramount, and I think everybody is going to go do that. Is going to use those. Now, whether or not the proliferation of the batteries is going to go, that's where I think the current administration might have an effect when they take away tax breaks and those kinds of things. But I can tell you, I've literally traveled all over the world in support of battery operations. I just got back from China a couple weeks ago, and the amount of battery infrastructure that they have is astounding. Everybody in the United States thinks that California has a lot of it. China has unbelievable amounts of energy storage, unbelievable amounts of battery energy vehicles and battery energy everything. You can't escape it there. So ultimately, again, I don't think it's going to matter. It's really how quickly things like energy storage products are going to get developed. The enforcement of the regulations, though, that ultimately becomes a local jurisdiction issue. And so, you know, I personally don't think it's going to affect it that much. Crystal, did you want to try something?
Yeah, I just wanted to say, you know, we're here for a reason, and we have over 1,000 participants, and you know, this topic is a hot topic. And as of today, you know, the state fire marshal and all of us up here are driven for that fire safety element of battery energy storage systems. So the topic, the technology, the manufacturing, none of that is going to go away. And I think, you know, if we stick to our mission, which is, you know, what we need to do to protect not only our firefighters, but our communities, the conversation will continue.
Did the governor text you? Okay. All right. Good. Good job, Crystal. Daniel's taking his badge off and I'm out. Okay. Next question is a good one. This one's most likely for me. Can anyone explain the differences between UL 9540, UL 9540A, and UL 810A? A shared understanding of these certifications is essential as we work towards a safer and more future-ready energy storage. Okay, so this is a great question. So UL 9540 is a certification standard, right? So you list something, it's a listing standard. So you list something to 9540. UL 9540A is a test standard, okay? All UL 9540A does is say that when you are going to test a battery system for fire propagation, here is the procedure that you follow for it. Nothing gets listed to UL 9540A. Again, it is merely a test standard, okay? For those of you who have been involved in fire prevention for a while, this is also very similar, and I use this example when I'm teaching classes, which is UL 300, right? It's the fire test standard for chemical extinguishing systems for hood and ducts, right? But the number of people that I've heard say over the years, hey, is that system that you've installed in your restaurant certified to UL 300? The answer is no, because it's a test standard. It's not a listing standard, okay? 810A, I believe, is for UPS systems. What is it? Oh, capacitors. Thank you. I'm new to UL, so be easy on me. There again, that is a listing standard for capacitors. So when you look at the UL ecosystem, there are going to be listing standards, there are going to be testing standards, and then we've got some other things like outlines of investigation and things that are not really standards yet, but they might be on their way to being standards, or they're used to address a particular problem. Okay, but remember the key here is look at whether or not it is a listing standard or a testing standard, because that will tell you what the difference is. If it's a listing standard, that's when you pick it up up and you look at it and it has the UL mark on it that we're very protective of, you want to look at that and you want to see that that's there. And if you've got that, then you have a fair chance of understanding that, yes, it's a good piece of equipment. It's been through its paces. It's not going to just, be sitting there and explode necessarily. So that's really the difference. Very good question. You can always ask UL for training on that. We're happy to give that training, and just reach out to us and we'll coordinate that with you if you want that. This one is a really good one. I know, Paul, I know you were going to talk about this potentially a little bit in your presentation, but so this one's probably a good one for you. Is there testing on hazardous gas release? And if so, what are the most common gases released?
So really good question. It deals with toxics, and I figured the question was come up, so I really didn't put it in my presentation. Because unfortunately 855 is a little quiet on it, on what happened. And I will say this is probably one of the more divisive discussions we had within 855. Right now, the requirement for toxics is not part of 9540A. It is not part of the large scale fire test. The number of people doing the test are collecting that data. The question is, what do we do with it? And that was part of our discussion within 855. What are we seeing? What type of toxics? Because honestly, all fires are toxic. So we don't see fundamentally a big difference between a house fire and a battery fire. Most of the toxics come from the plastics that you would see in there, not so much the batteries themselves. There are off gases of the electrolyte, but there's very little electrolyte. If we move to a fire condition, those tend to burn off really quickly. The thing with like things like HF is they're very reactive. They tend to react to heat. They tend to react to metals. Even though we may see in a large scale test that we have a breach of a container, we see HF spike very quickly. It also drops off very quickly. So we don't see them at distance. And modeling is a struggle that we deal with as well, because fate and transport is so important. And honestly, there's maybe 4 people in the world that I truly trust to do modeling, that understand the failures of batteries, that fate and transport. What does it look like if you end up generating a model that says everything produced ends up out in the environment? It looks pretty bad. But the reality is that what we've seen from most of the events, we don't see exposure levels beyond the property line. So, but we also realize this is it's a political hot potato. I would have liked to have seen 855 at least take a stand on it. But again, we couldn't really come to consensus on what that stand should be. My personal opinion, it really should be up to the incident commander to make that call on site. What are you seeing? What's coming off the property? But there was some good language that NFPA wrote and we submitted. It didn't get put into the code. I've been trying to figure out how to get that into the marketplace, but because of copyright issues, I can't get it freed up to use it. So it tells you how to deal with an incident command, tells you what the requirements of doing modeling and some of the parameters and so forth to look at. I'm sure we're going to address it again. It'll come back up this cycle. So long-winded answer, in general, we don't see that big of a problem with it off-site, but it tends to be the first thing when there's a fire. The public ties on that and said toxic plumes, toxic exposures to our firefighters. And then when the real data comes out, 2 or 3 weeks, the story's already moved on. So it doesn't get any traction on that. Again, what I think is important to say is it doesn't present next to a house fire. Again, neither one of them should you be breathing. They are, wear your protective gear, but there is not anything inherently different with battery fires that you see in warehouse fires, plastic fires, other environments. So very long-winded answer, but I think it's very important that this is something that we understand and how to deal with from a public perspective. So again, any questions, reach back out, please, on this topic.
And I'll just add as well, it might be discussed later today at the research panel. But the Fire Protection Research Foundation does have a report coming out that's the environmental impacts of lithium-ion battery fires. And even from the LA fires, there's a lot of EPA data that you can look up yourself just to have more data points on air monitoring and so on and so forth with that, which I thought was really insightful.
Yeah, there are a number of first responders in this room that have dealt with those fires. So reach them out, talk to them, have a conversation.
Yeah, this is probably one of the hottest topics is the toxics, what happens with the toxics. But again, you know, as Paul mentioned, all smoke is toxic, right? So, and particularly like you get into a single family residence structure fire, you know, you've got acrylines, you've got formaldehydes, you've got acids, you've got cyanide, you've got all of these different things, and it's all toxic. And we don't do as much study on that. But ultimately, that's what needs to happen is we need to study all smoke. It's not just batteries that are the problem. So we're running out of time, so I'm going to probably skip a couple of these questions. One thing, so we've got a couple of questions here about checklists for plan reviewers to use, streamlining and that kind of thing. There is going to be a presentation, I believe, right after lunch where they're going to talk about permitting. So you'll be able to get some of your questions answered on that. One question is talking about using 9540A fire tests and best practices for streamlining the plan review. The best thing that I can tell you on that is that you may not know that 9540A has an annex in it that talks about how to read a 9540A test report. That would be a very good thing to do to take a look at that. So this will probably be our last question, but it says modules are sourced across multiple suppliers, making consistent quality nearly impossible to guarantee. How does testing address this randomness? So I'll start off with this, and then if anybody else wants to weigh in on this. But the way that you are supposed to read all of those test reports and everything is if you get a 9540A test report, you should have all of the tests. One of the things that very rarely happens in my experience as an HJ was they would give you just the unit level test and they would give you summaries of the cell and the module level test. The problem is that you don't know, particularly based on that question, you don't know what's going on with that. When you look at a unit level test, you should reference it back to the module level test and the cell level test to make sure that the module that is being used in the unit is the module that was tested. And the module that was tested should be using the cell that was tested in the cell level test. If you do not have a unit level test that has the cells that were used in the original cell level test with the modules that were used in the module level test, you do not have a good unit level test. So keep that in mind. Anybody else want to add anything to that?
Part of the question was consistency, and really that's the listing. So the 1973 listing, wherever that manufacturer decides to make the modules, whether they have 3 different facilities, the processes should all be the same. So that listing looks at those processes. It does a look back on the quality control. And that's probably one of the biggest things we run into is the quality control, looking at the listings through 9540, the listings through 1973. Are we consistently providing the same product across the whole supply chain?
Yeah, great answers. Okay, that's it. That's all the time that we have. We're getting ready to break here for lunch, so I'll bring Tim up here, but let's give a hand to our panel. Thank you guys all very much.
All right. Thank you, Robert. Thank you, everyone on the panel. Really appreciate it. We are going to break for lunch. Lunch is on your own. We have a lot of restaurants in and around the area, but we also have a cafeteria with some restaurants there. We're going to return here at 1 p.m. to continue with our state agency updates. So please join us then. If I can have you take your seats. We're going to go ahead and resume our afternoon session. Welcome back. Hopefully everyone had a good lunch. To kick off our afternoon, we're going to hear updates from several key agencies, state agencies, on battery energy storage systems. So first, please join me in welcoming LaQuinn Nguyen.
Hi, everybody. Thank you, Chief Spears. Again, my name is LaQuinn Nguyen. I'm the Deputy Secretary for Energy at the California Natural Resources Agency. So quick note, if I start to talk too fast, please somebody raise your hand and flag that for me. I was not expecting it to be so cold in here, so I may just either have teeth chattering or be talking really fast. Either way, wave your hand if it's not making sense what I'm saying. So also want to start off by saying I really appreciate this opportunity to be here to talk to all of you and share the work that the Battery Storage Collaborative is doing. And thank you again to CAL FIRE's OSFM for hosting this event. Okay. Oops, sorry, maybe I should have done my intro slide for you. Okay. So just to get started, for those of you who are not familiar with the Battery Storage Collaborative, I'll provide a brief context and overview of the background of this Battery Storage Collaborative and what we're doing. So many of you may have heard about California's ambitious climate and energy goals. On the energy side, that's achieving 100% clean energy by 2045. And actually, the breaking news from earlier this week was that in 2023, we achieved 67% clean energy. So as we continue to work towards that transition and ensure that it's safe, reliable, and affordable, battery storage will play an important part of that. And so currently we have over 15,000 megawatts of batteries installed in California, and that's almost a 2,000% increase since 2019. That is exponential growth for any technology, I think, and especially a clean energy technology that's new and still developing. And so recognizing that growth, in September of last year, Governor Newsom established the state's Battery Storage Collaborative. So this is a state agency collaborative, and it consists of the Natural Resources Agency, the Governor's Office of Business and Economic Development, the California Air Resources Board, the California Public Utilities Commission, or PUC, the California Energy Commission, or CEC, CAL FIRE's Office of the State Fire Marshal, as well as the Governor's Office of Emergency Services. So the purpose of the collaborative is to increase coordination between state agencies as we examine battery storage technologies and safety considerations and look for any opportunities to improve them. So some examples could be through best practices and increased training. So to date, our agencies have taken a number of actions with the Battery Storage Collaborative. So first, we have earlier this year, the Office of the State Fire Marshal adopted a suite of updated fire safety codes for battery storage systems. In addition, the PUC, they established new standards for the maintenance and operation of battery storage systems and increased oversight of the emergency response action plans for the facilities. Both the PUC and CEC conducted a data inventory of existing battery storage facilities in California, just to make sure that we had consistent information on each facility, such as their technology, configuration, and standards to which they were built. And then they're using that information to help organize the PUC's planned inspections of existing battery storage facilities using a risk-based methodology. The PUC also continues to analyze the impacts to energy reliability from either battery storage facilities that are offline or have a reduced state of charge. And then last but not least, GO-Biz is working with local jurisdictions to identify challenges and best practices in permitting battery storage facilities and create permitting resources. And so my colleagues on this panel who come after me and on the next panel, they'll provide additional information on each of these actions. So just a reminder though, many of these actions were already in place or started at these agencies prior to the convening of the Battery Storage Collaborative. What the Battery Storage Collaborative did was basically increase coordination among the agencies to make sure there was no redundancies, make sure that we were more efficient in our work and coordinating with each other, as well as identify gaps in our work. So we'll continue to coordinate in going forward, and some areas that we intend to coordinate on next are identifying and exploring additional risk reduction measures. So what that is, that's still TBD. We're open to suggestions. We do have a webpage where you can track our work and provide suggestions on things that you think we should be working on or collaborating on, or just areas where you have questions. And so I did have a link that I forgot to share with folks on our to get to our information. The link wouldn't work for you anyways, since you're just looking at a presentation, but you go to GO-Biz's webpage, and then under their Industries tab, and then the sub tab of Climate and Clean Energy, you can find more information on the Battery Storage Collaborative. So that was my really quick presentation. I'll look forward to any questions you may have at the end of the panel. But next, we're going to turn to my colleague from the California Energy Commission, the Executive Director, Drew Bohan.
Thank you. Oh, this is one of those mini mics that doesn't raise. Oh, well. Thank you, LaQuinn, and thank you, CAL FIRE, for putting on this event. Especially, I want to call out Kara Garrett. I've done my share of these things over the years, and I don't recall an event that was done in a more organized and conscientious manner. So kudos to Kara and the whole CAL FIRE team. In the spirit of embarrassing people, I'm also going to call on one of my bosses who is in the room, who is the lead for the California Energy Commission on the issues I want to spend a few minutes talking about, but I'm going to ask her to stand up. Commissioner Nomi Gallardo. And she's the lead on evaluating projects that come to us that seek to build large BESS projects in the state of California. So thank you, Commissioner Gallardo. I know many of you in this room are firefighters, and there's a lot of folks on the phone who are firefighters. And I just want to say humbly from the bottom of my heart, thank you. Thank you for your service. The biggest occupational hazard I have probably is riding my bicycle to work in the morning. So I'm really grateful that folks get out there and take on just incredibly difficult challenges. I listened to the keynote this morning and found it very informative, and it gave me the opportunity to reflect on what an incredibly difficult job you all have. But we're here to introduce ourselves and reach out and let you know how much we want to work with you. A little bit of background. So a decade ago, we had virtually no BESS in California, a decade ago. And no conferences like this where we're talking about BESS and how best to deal with the issues associated with BESS. Fast forward to today, and as might have been noted earlier in the presentations, we're at just about 16 gigawatts. That's about a quarter of it can serve about a quarter of all the demand in California, typically for 4 hours, maybe 8 hours, but this is an extraordinary development. And our Governor Newsom, really deserves a lot of the credit for this leadership. The Wall Street Journal published an op-ed that he wrote yesterday, and it talks about that, the fact that we've built so much BESS in California. Without it, we're not going to meet our clean energy goals. As LaQuinn pointed out, very ambitious goals by 2045. BESS is an absolutely critical part of it. If we come up with some new technology that obviates the need for BESS, wonderful, but it's not looking like that. So our primary role is to receive applications from developers who want to build reasonably large power plants, 50 megawatts or larger, or BESS facilities, same size. They come to us, and we're a one-stop shop. We do all the CEQA evaluations, looking at everything from visual to noise to all the different things a large industrial project has. The one that's gotten a lot of attention lately, naturally, is fire, and thus we're here today. We are proud to have approved our first project. We've received a number of them. In fact, we have 20 gigawatts of applications in the system, or developers that have told us they're going to file soon, and we're coordinating with them. 20 gigawatts. So this is getting to be very, very large. Over half of those 20 gigawatts are storage. The balance are solar. I think there might be one other small project with some technology, a different technology, but it's dominated by batteries. Our first project was called Darden. It's in Fresno County. I saw some San Bernardino folks, didn't notice any Fresno, but our team has worked very closely there. We're grateful for the assistance that the first responders provide and the relationships we've cultivated. If you haven't had one of these come to your community, if and when they do, we will be there, and we just want to extend an olive branch to coordinate with you, learn from you, share with you what we know. And as Chief I have to look, O'Brien, excuse me, noted earlier, they're all different. You have to look at everything. You can't just say, well, here's the concrete pad. It's going to be some batteries. Let's figure it out. So we spend lots and lots of times with our fire colleagues in the local government. So thank you. The Darden project, we included much of the stuff that's been talked about this morning, compliance with the California Fire Code, NFPA, UL Solutions, ongoing collaboration, in this case with Fresno Fire Department, with any local fire department, wherever a project is located, a dedicated command and control center outside the facility, real-time environmental monitoring of air and water quality, deflagration panels, telemetrics, including thermal cameras and all those sorts of things that can warn us about the potential for a fire before a fire even ignites, and other things. And we keep an open mind about other safety measures. I took some notes as I was listening to the keynote this morning. I noticed our staff over there will compare notes later about some of the things I'd heard that might be ones we want to consider for projects as we look at them going in the future. But it's critical for us to understand the needs of each local fire department. The Darden project had a suite of issues we dealt with. Another one that's filed with us is called the Compass Project. It's in San Juan Capistrano. Couldn't be more different. The Darden project was huge, largest. Once built, it'll be the largest on the planet. 1.15 gigs of solar, same size battery. In San Juan Capistrano, it's smaller, 250 megawatts, no solar, but it's also a lot closer to sensitive receptors. So lots of challenges there we're trying to work through. But the point, again, I'll just underscore, is we want to work with you. We want to learn from you and collaborate to try to, when projects do get built, make sure that they're built in a way that's safe for the workers that work at the facilities, the first responders, and of course, the community. This is our top priority, is safety with batteries. And we won't approve, my job is to recommend to the commissioners, of which Commissioner Gallardo is one of them. There are 5 on the California Energy Commission. My job is to recommend projects to them. We won't be recommending projects if we don't feel these are going to be safe for all parties involved. Thank you very much. And let me hand it off to my colleague Lee from the Public Utilities Committee.
All right, good afternoon. Thank you so much. My name is Lee Palmer, and I'm the Director of the Safety and Enforcement Division for the California Public Utilities Commission. I do want to echo a heartfelt thank you to all the firefighters in the room, all the first responders. I spent quite a few times, almost 2 decades in the California National Guard working with firefighters. And just thank you for everything you do. CAL FIRE, thank you for continuing to be just beyond what I consider a public safety partner to the California Public Utilities Commission. Within Safety and Enforcement Division, we work hand in hand with them on wildfire investigations, incident sites. We work hand in hand together, so thank you. The CPUC plays a key role in the emerging field of battery and energy storage systems, as it directly contributes to the goal of strengthening grid reliability while also advancing the state's clean energy targets. Additionally, the CPUC promotes the safety of existing and future BESS facilities through established compliance and enforcement programs by providing effective and timely oversight. And a lot of this is emerging as we ourselves are going through the learning process. I'll briefly go through the CPUC's ongoing initiatives and programs as it relates to BESS. I went the wrong way. Oh, there we go. Great. As stated by CPUC President Alice Reynolds, California has set ambitious clean energy goals, and utilities and community choice aggregators have stepped up to deliver clean resources to communities up and down the state. In 2024, California added approximately 7,000 megawatts of new clean energy nameplate capacity, of which roughly 3,500 megawatts were from battery storage. The CPUC plans and directs procurement of energy and capacity, including battery energy storage systems, develops policies and standards for operational maintenance and safety, and conducts boots-on-ground audits, inspections, and investigations of incidents. In response to the significant growth of energy storage systems, the legislature passed SB 1383, which required the CPUC to establish operation and maintenance standards for energy storage systems. To implement this new legislative mandate, the CPUC adopted a revised version of our General Order 167, which we call GO 167C, which governs standards for the maintenance and operations of electric generation facilities, power plants, and now energy storage systems. Updates included revisions to logbook standards, safety-related incident reporting criteria, and it added provisions to enhance safety and effectiveness of generating assets and energy storage systems operations and maintenance. And this is available on our website. Additionally, GO 167 incorporated another legislative mandate, SB 38, which requires that ESS operators produce an emergency response and an emergency action plan and coordinate with local authorities in developing those emergency action plans. So that's where you come in at the local level. They should be sharing those with you and reaching out to you to develop those plans. If you know you have a BESS facility in your neighborhood, in your area, and they're not reaching out to you, they're wrong. Finally, the CPUC Safety and Enforcement Division has the authority to conduct audits, investigations, and enforcement of regulated ESS facilities. And we have the goal of auditing each facility on a 5-year cycle, more if needed. Currently, there are 114 ESS facilities regulated by the CPUC. As part of the Tracking Energy Development Task Force, TED, which includes the California Energy Commission, the CAISO, and the Governor's Office of Business and Economic Development, the CPUC's Energy Division tracks the energy storage sector in California. The TED Task Force has identified that installed energy storage in California has been growing substantially since the end of 2020. As of May 6th, there are roughly 12,500 megawatts of storage nameplate capacity online serving the CAISO grid. Most of that storage is in the form of standalone installations shown here in purple. The orange represents the capacity of the hybrid facilities where the energy storage is directly paired with an energy source like solar. The energy storage sector is expected to almost double in the next 3 years with an additional 12,000 megawatts of nameplate capacity storage expected to come online by 2028. So I know there was a question during a previous presentation of what direction are we headed? It's not going away. It is going to continue to grow and we need to be prepared for it. The CPUC's website at the link identified on the slide will be periodically updated by Energy Division to include an updated analysis of the energy storage sector in California, along with other important information around things like permitting, interconnection tracking, and regulatory support for the timely interconnection processing. As was previously mentioned, in January of this year, CPUC staff directed BESS owners and operators to respond to a survey to obtain critical information about current and soon-to-be operational BESS facilities. This encompassed all energy storage systems 50 megawatts or larger. The survey included 114 respondents and required operators to validate critical information such as storage capacity, type of batteries on site, fire detection and suppression systems employed, and the safety standards used in the development and operation of those facilities. The pie chart on your right illustrates the type of batteries that are located at each of those facilities. And based on the 114 responses, you can see that the vast majority, 96% or about 110 of those facilities are located are containerized outdoors. Only 4 of the facilities are indoor facilities. All 114 of the ESS facilities that the CPUC regulates are lithium-ion batteries. This information has been shared with all agency partners, but it is also available publicly on our website. Additionally, we have summaries of the survey available outside at the CPUC table. Lastly, the CPUC continues to work closely with our state partners and industry experts and the local governments on both procurement and safety matters. Since the revision of GO 167C, we've conducted 2 standalone ESS audits with 12 additional audits scheduled for FY 25-26. Upon completion, each audit and all investigations are made public because we want to be transparent, not only as the regulator, but to the operator and the communities that the facility serves. To accommodate the growth of the growing fleet of the ESS fleet, the CPUC recently increased the staffing of its generation and energy storage section from 9 to 19 staff, expanding the available engineers and analysts to conduct audits and compliance activities. We have flyers as well at the CPUC table, and Ms. Banu Asimus, sitting right over there, who has been with the generation section and our battery energy storage section since its beginning, is available to answer any questions if you're interested to learn more about the opportunities about that dynamic team. Collaborating with our state and local and industry partners, we continue to expand our knowledge, and we want to ensure a safe and reliable electric storage grid for California. And thank you for your time.
So I think we have time for a question or two, right? And until I hear no, I think we do. But I'm not sure if any questions were able to came in. Actually, here's a QR code that you can scan and provide us with questions if you have any questions for this panel. Give folks a minute or two to enter your burning questions. Oops, sorry, bad pun. Very unintentional. Or maybe if you have a question, you could just raise your hand and state it. Unfortunately, this computer went to sleep, so I won't be able to tell if you have questions anyways. I see a question in the back there. Why don't you stand up and...
So folks, in terms of asking questions, the virtual audience can't hear you. So if you shake the mouse on the laptop next to you, it should come back on. So it's the
No.
other laptop on your left.
Yeah, I need to enter a password, but I can just repeat the question.
I've heard rumors of certain jurisdictions in California forcing home energy storage systems away from the garages and basements and houses, not even on the outside of the house, in the family. And so I'm just curious if you've heard from any of your jurisdictions or if there's a statewide type move towards that. So something that goes on the outside of the house or in the garage.
So I think the question is, we've heard that the person has heard that local jurisdictions are forcing home energy battery systems to be located not on the side of the garage or even located in the garage, are forcing them to be located away from the garage. I don't know what that, away from the house. I'm not sure what the distance that they're requiring. And so the question is if we have heard from local jurisdictions or others that this is going to be a more consistent requirement, or if this is just certain local jurisdictions imposing that requirement.
Appreciate the question. I looked to my colleagues and got visual confirmation. We don't know. Certainly jurisdictions where we've seen it at the California Energy Commission is jurisdictions around the state, a small number have passed ordinances with regards to the larger systems. Hadn't heard about the smaller home size or small business sized ones.
I also think so. Our colleague, Rohima Mali, will present next. And I think that might be something that could fall under the work that she is doing, is inquiring with local jurisdictions around, again, around permitting resources and consistency, trying to identify whether that's a consistent requirement, if it isn't, or is, you know, working through with stakeholders, some of the questions behind that. Okay, so we do have a question that came in. It's why doesn't the PUC and, or why doesn't the PUC and CEC regulate and license all large-scale BESS sites over a certain megawatt threshold, no different than power plants? Why is it just an opt-in process? Drew? Why is it just an opt-in process? Why isn't it? Or why is it just an opt-in process? So I think the question is asking why are BESS going through the opt-in process and not going through the normal like AFC process?
Oh, I originally heard you say PUC, so I looked at Lee, but, well, I mean, the short answer is the legislature passed legislation a few years ago that expanded the Energy Commission's jurisdiction to include wind, solar, other generating types, and battery energy storage systems. It, unlike with traditional power plants where the Energy Commission has jurisdiction regardless, in this legislation from a couple of years ago, it afforded developers an opportunity to choose to work with the local governments and get their entitlements from the local government, or to come to the Energy Commission. What we're observing is some come to the Energy Commission and select that route. Others are going straight to the local government, so it varies. But the short answer is it was a bill the legislature passed on the governor's side.
Okay, thank you, Drew. So to keep us on time, I am going to ask our colleague, Rohima Mali, to come up and present. Thank you all so much for your time. And I think there are probably a few more questions in the audience. Please feel free to submit those later, and we'll be happy to answer those later. Thank you.
Good afternoon. Rahima Mali with the Governor's Office of Business and Economic Development, Deputy Director at the Energy and Climate Unit. GO-Biz is part of the collaborative, and we were given a little bit longer to present the initiative, the permitting initiative that we have been working on related to BESS or ESS. So, let me start. All right, just quickly, an overview of the initiative. I have my consultants here, Suna and Christy, who will go over the findings that we've discovered during our interviews and surveys with local jurisdictions, developers, and community groups, and some of the tools that we are working to develop with the focus on BESS. Oops. All right, so I think LaQuinn, Drew, and Lee touched on this earlier. These are the drivers for improved efficiencies. And given that we have these huge ambitious goals to get carbon free electricity by 2045, the state has to deploy more clean energy projects from now until like the next 10 years. And SB 100 estimates that we need to deploy about 7,000 megawatts, 6,000 to 7,000 megawatts, each year to be able to get there. 6,000 to 7,000, what we've seen comes out to about maybe 100 projects per year. And at the bottom in the blue shows what the expected megawatts are for 2025. So these are expected megawatts. What Lee kind of went through are what's under contract, meaning that developers have signed a contract with the load serving entity to bring this online. So they have a date that is supposed to be on and providing power to the grid. So about 6,800 megawatts this year alone, and about another 17,000 megawatts from 2026 to 2028. So more than 20,000 megawatts total, and half or more than half of that is from battery storage. So as part of the TED, the Tracking Energy Development Task Force, we engage a lot with developers on a routine basis to understand what are the issues that they are encountering in terms of bringing those contracted projects online. And where possible, each of the agency will take on the issue and see if we can help troubleshoot it. So an issue that keeps coming up is permitting delays. So it could be, local, state, or federal review. If it's on federal land, then there's some federal permitting that they have to go through, and sometimes, that process gets bogged down, or the local permitting review. Long times to get it done. What we've noticed is that some jurisdiction are more experienced than others. Some have not permitted one at all, so they don't have the staff capacity or the know-how or the understanding to permit BESS. And so that in itself extends the permitting timeline. And then sometimes there are just staff like turnover. So that can cause a delay, which then extends the online date of this project. And sometimes it's community opposition. And I think you've heard it earlier, either real or perceived. Some of these fire incidents that have happened tend to dominate headlines. And that is what everyone gravitates to, whether and brings up a lot of issues that we should look at the same time. But then again, they provide or put like certain fears into the community that may not be warranted. So understanding that permitting is a delay in bringing these projects online. GO-Biz kickstarted last year our permitting initiative, which is to provide information, best practices, and tools for local permitting authorities to help improve their processes. And within that, a toolkit of just resources, whether they're checklists, fact sheets, that local authorities can use when they do community engagement on these projects, and model template ordinances that they can use. We noticed that some counties have issued a moratorium on BESS projects while they take the time to develop a new ordinance for this. And so some of these tools that we're developing, we're hoping will help with their process and speed up that process if they are adopting something, a new ordinance. So process and timeline, it started in December. So from December till about April, we did a lot of stakeholder engagement. We sent out some online surveys to all the local jurisdictions, 500 plus. We attended events to get people to fill out the surveys. And then for some priority counties, we reached out and did one-on-one interviews to understand what their challenges are and what opportunities that they see can be improved to help with the permitting process. And so from April to August, we've been heads down, putting some of these things together and pulling all the information that we've gathered so far. And in September, we're hoping to have a draft playbook and toolkit released for public comment with a final by the end of this year. So just some more information about the surveys that we've done. 170 out of the 500 plus, 170 or so completed the surveys. We did interviews, 50 plus interviews. And then we've conducted a couple of webinars, attended some conferences to do additional outreach, and we have planned a couple more webinars to preview the template ordinances later this summer for additional feedback and input. So on to the more interesting stuff. I'm gonna turn it over to Suna here so she can go over the findings.
The forward clicker is this one here. Nice. Hit that one. Okay. Hi, everyone. My name is Suna Temez, and I'm with GHD, and we're a company that deals with things like engineering and design on both the developers' behalf as well as the local planners. And so we're working with the GO-Biz team on how to identify barriers to the local permitting process. So we looked at, as Molly said, there's about 100 new projects coming on a year. And so part of our survey was working with local planning departments. So they're the lead agency typically. And the planners said that 45% of local planners felt equipped to handle that influx of permits. So, as we heard earlier, it's not like there's a lot of overstaffed departments. So there's some concern there about being able to handle the influx of permits. The planner has lots of different responsibilities. They're handling developer inquiries. They're dealing with interagency coordination and communication. They may or may not have a strong knowledge in the technical clean technologies such as BESS or solar or onshore wind, which are the three that we're actually looking at as part of this project. And they specifically requested assistance on BESS because BESS is, from both the planners and the developer's perspective, the most time consuming of the clean technologies to permit, and yet so much more is coming online soon. What affected their timelines to provide that first initial land use permit? Community concerns was cited as a cause. Interagency coordination was cited as a little bit of a barrier, including just getting to understand the fire department and the fire community's concerns and needs as well. And also just understanding the landscape again of the technology. We also asked developers, what do you feel are some barriers to the local permitting process? And they were quite direct. They said that 87% of them felt that there were delays that could have been avoided in the planning permitting process. So the developers are obviously coming at this from the perspective of, we want to provide something for the community. We want to minimize project risk, and we do want to make sure the cost is appropriate for that development, which can bring, great benefits to that community. They looked at the permitting process within each locality, and they typically went towards those localities that had a clear permitting process. That's where they had realized they had more chances of success. They also filed applications in multiple localities to make sure that they had a better chance of success with one of them if it was rejected or unclear in one area. From the developer's perspective, their reason for barriers or what they felt were unnecessary delays, local permitting staff shortages, process delays, restrictive zoning ordinances and moratoria. So as we heard from Molly, some localities have put a moratoria, i.e. a stop to any development of BESS until a more clear BESS specific ordinance is developed. Community opposition to local development was also cited as a barrier. The AB 205 CEC-led process was mentioned. So developers do have two pathways to be able to permit a potentially beneficial BESS project. And so, both are options. And I think the encouragement is, localities can have a clear process and help enable permitting. And so there's a benefit to going with that process, as well as that option to go with the CEC AB 205 process as well. Summarizing some of the best specific requests for tools and templates that we heard from the local planners' perspective. Information and fact sheets to help talk about health and safety, including fire risk. They wanted to understand more the codes that would impact that permit approval, affect their own ordinances around land use and planning. They stated that the best projects were the most time-consuming to permits, over utility scale solar or onshore winds, also because it is the newer of the technologies. They were looking for assistance in developing these best zoning ordinances, knowing that there's moratoria in the region. And finally, they also asked for these more, let's say, public-friendly fact sheets. If the media has an inquiry or if they have to present this plan for approval to their local board, how do you communicate in a very friendly way, in a public-friendly way, the information that's required? For our project, we focused on that first lead agency. So that's the local planners departments. And so, they have some amount of time where they're meeting with the developer, hopefully having a, pre-planning, pre-permit application meeting. and they're helping coordinate the environmental review. They're bringing in the different stakeholders. So they have, some time. That's who we're working with as part of this. But then, of course, down the road, other folks get called in. For example, the building department and the fire code folks and the fire officials. Now, surely I can just hand that over and within the next day I can get an answer, right? And a permit approval. That's what the developers think. And so I'll turn to Christy to perhaps say a few words about that process as the fire expert.
Okay, there we go. I think what we were hearing from the stakeholder meetings and what we've heard today, I think Chief O'Brien really laid the framework for this, is it's about collaboration. So land use permitters and for zoning permits, they're overworked, understaffed, same thing. Fire departments, I mean, we all know what fire prevention is like, even firefighting, we're all overworked, understaffed. So it's a collaboration process and early communication. And that's what the land use permitters are asking for. They're engaging with these community stakeholders sometimes early, before fire even maybe knows it's coming. And so what they're looking for is a streamlined process. When the community and the developers are talking about setbacks, really they need to engage with fire. And if we're having the same types of process, we all know about our pre-planning meetings, pre-development meetings, letting everybody know, being on the same page. And I think it's the same thing we're hearing here. It's just like the fire departments want a checklist. That is what the land use permitters are looking for as well.
Great, thank you. So the role of the local planner and the role of the building official or the fire official, they're not necessarily separate. There's many points of interconnection. And for the developer as well, it is useful to be able to approach a locality and have that holistic view of the different sets of codes. And so from the planner's perspective, which is the top row, they're looking at having those early meetings with the developer to outline all of the requirements for a permit application. They may be using a checklist. They will be looking at their zoning compliance and land use compatibility compared to the developer's plans. They'll be leading the CEQA process. They'll be doing an application intake and completeness check. They'll be coordinating the checks for the conditional permits. And then finally, there's that conditional approval. So I'm vastly simplifying, but the point is there's lots of different steps that can't necessarily be sequential because what someone puts into their permit application on the front ends can require significant rework if down that path there's a different set of codes that has a different set of requirements that they're not compliant with. So from the planner's perspective, this is what they're trying to address to make that permit application process a bit more accelerated. From the fire official's perspective, Christy, I'll ask you as a former fire marshal.
We know we have checklists, right? What we're looking for that application. We need a permit application for construction, operational permits. If those things can be streamlined, so when the individual, the developer is going in and meeting with their land use and getting a permit to use that land, when the land use permitters and the fire department have communicated, talked together, and they're coming up with a set of criteria that meet their community needs, that make sure that these projects are safe, can be accomplished and functional in a timely manner, everybody wins in that process. And so the land use are looking for this engagement, looking for understanding what the fire code requirements are, just like a lot of us here. That's the whole point the state fire marshal is having with this, is educating all of us. What are the requirements? How do we do this? It's not like a high rise. It's not something we may see every day. Some may never see any in their jurisdiction, but when they do come, are we prepared for that? And this collaboration is how we will get things done in a successful fashion. It's phone a friend as a fire service, right? We phone a friend. Well, our friend in this is going to be our land use permitter. And if we can work together and get those things up front, they can collect a lot of that information ahead of time, making our permitting process from the fire department so much easier.
One of the tools that the planners asked for, actually the localities asked for when there was a moratorium, is a model BESS ordinance. So the team has put in the work to develop a BESS ordinance. And we've looked at what other counties and localities are doing because there's an active amount of ordinance, of a BESS specific ordinance being created across localities. And what we've actually done is, not say it's a plug and play ordinance. This is really meant to assemble all the various pieces that we've heard from planners, from developers, from the fire community into a document for the locality to really look at specifically in your area to make sure that it conforms with what you need. And fire input is so crucial for that. So at the end, I'll show you the code to get the information to be able to look at this ordinance and see if it's something that you could sit down with the planners and discuss for your area if needed. So parts of a BESS ordinance. So where is a BESS ordinance useful? Well, it's useful to have one streamlined permitting framework so that you don't have design changes that happen after the permit's been issued and approved. It benefits localities with high developer interest. So they have a framework to go to, one common set of criteria to go to. It reduces potential conflict that might be in that planning and land use code versus fire code and brings those up front for the developer. It absolutely requires coordination in your locality, as Christy mentioned as well, between planning, fire, legal, engineering, and community so that it reflects your local needs. And it does create that alignment to have at least a framework of those discussion topics. So some of the types of parts, let's call it the table of contents of the ordinance. Some will be, let's say, lower risk of conflict and others will require more discussion. And so definitions, right? That one should be relatively easy. Although as we talked about in an earlier panel, definitions are also very important. So definitions, applicability, design standards, so location, setbacks, security, signage, noise, vegetation management, commissioning plans, decommissioning plans, visual and lighting and sound. So all of these you can see you have a role in a heavier role in some of these than others, but they're certainly interdependent between the different AHJs and planners in that locality. I'll show you an example of one type of the code. So this template can be used in the locality, and there'll be sample ordinance language that we've seen in best practice, best ordinances, and then commentary text that discusses that ordinance for the locality to then discuss and decide what should be their appropriate ordinance language. And so this one is about fire safety and equipment certification. So an upfront mention of what those, what that requirement will be for the developer to be aware of and for the land planner to be aware of as well. And Christy, I'll turn to you to just touch on the this requirement around equipment certification.
So what they're looking to do with this permitting toolkit and model ordinance is put in some of that language so that when these projects are coming in, the land use permitters can say, well, these projects, you have to meet all the applicable listing requirements. And whatever those are for the California Fire Code, which their adoption of NFPA 855. So all those listing requirements, they're collecting this data ahead of time, making these requirements come in long before the fire permit comes in. So that is going to be part of the model ordinance language that jurisdictions can pluck out and plug in to make their own model ordinance.
A potential ordinance language that might take more discussion in the locality. So again, where all the folks should be in the room to adopt for your locality, setback requirements. And so there's the planner's perspective on a setback, and then there's fire official and building official perspective on setbacks. And then there's a developer's perspective on setbacks. So as an example, this table illustrates what setbacks, what they mean as far as, let's say, developable area or buildable area for the developer using a 1 acre lot, a 5 acre lot, or a 20 acre lot. And the box shows 1 acre lot. So 1 acre lot with a 10-foot setback, which is a minimum, gives the developer 82% buildable area, but Christy will describe buildable area in a second. If you have a 50-foot setback, then the developer is looking at about a 27% buildable area. And so you start to see this, it almost becomes like a de facto moratorium to be able to build, because the incentive to bring that technology to the locality goes down with the setback. So Christy, that's setback. If you could describe, does 82% buildable really mean buildable?
Well, that, as we know, that what we're talking about when they're looking at setbacks, that's from maybe the nearest property line, what we talk about in the code. But now let's talk about each module, each unit. How far is that spaced from each other? So by the time you start to space these out, what do we need for fire department access? What kind of fire lanes? So that can really decrease the amount of usable land. So working with setbacks is a really hot topic, and the land use permitters are at the first bite of that. This is where this is first coming in. So collaboration with them and understanding what are our fire strategies and tactics for that particular site, for that particular setup, would really be helpful in making the best fit for the community.
We looked at some of the BESS ordinances that are being developed, and there's not a lot because it still is a new technology, but there are a couple of localities, both in California, also the University of Michigan was mentioned earlier, and there's other localities across the US, and they are looking at this BESS specific ordinance to help address this idea of unifying the different sets of code. So one example at 10 feet setback is Rancho Cucamonga. And they describe some of the considerations that go along with that setback. In a second, Christy, I'll have you go into these in a bit more. 30 feet is what we saw as the common default land use setback. And then there's descriptions of what would be the applicable fire code and other related code for that type of setback. Then we start getting into 50 to 100 feet setbacks. And this is what could be termed the more recent and common type of setback. Some setbacks are higher than that at 100 feet plus up to 300. I think I've also heard even 1,000. And in some cases, this really is a de facto moratorium for development in that community. The community will obviously have concerns about safety, and those are very important. And also it's important to understand the real code as opposed to, there's an idea of making up requirements, right? What are the specific requirements that need to be there to make that that development safe in that community? And so some examples of that, I'll turn to you again, Christy.
What we've seen in this process is that some communities have engaged their local fire departments and fire code officials to help establish this model ordinance language or toolkit around what is going to work for the community, what is going to work for their public environment, what is going to work for the fire department. Because it's really important to have that land use setback and that criteria for your permit for land use aligned with your permit for your site. Because just because they get a permit for land use, now they have to come to the fire department and get a permit to construct and operate this, and it needs to have an alignment. And that really streamlines the process, helps the developers and helps the communities. And communities that have engaged early with their fire departments to come up with these ordinances and have provided us feedback, I think have found more success in lowering some of the conflicts that can occur.
So with that, we are on track to produce a playbook and toolkits for primarily the planners, the lead agency within each locality. But it's vitally important that we include the feedback from fire folks, building folks, the community. And so that's where, thank you for allowing us to present, and we look forward to your feedback. Some of the recommendations we asked, what practices do you have in your locality? And localities emphasized that things worked well when they had local engagement between the developer, the planner, fire, and building officials, where zoning and local fire code criteria were aligned, where they had public information on BESS and fire safety, where they had the same types of testing that could address different parts of that permitting process, and also where they could engage with the developer on what was needed in that community as far as specialized fire training, education, equipment, and making sure there is a way to express those needs and be able to discuss them. With that, I will turn it to Molly.
Thank you for that. I know we went through that kind of quickly, so questions, although I don't have the this will give you some time to scan the code and submit your questions if you have any.
I think we've got one over here real quick.
Hi, I bring a different perspective to this. I appreciate what you're doing, trying to get a model planning and development process. I'm the lead investigator for Never Again Moss Landing. We're down in Salinas, Moss Landing area. And so we bring the experience of watching a permitting process that had some weaknesses and some interactions with the operator with the fire people. First, I want to say we're not against battery storage. We're in fact trying to encourage corrective actions. And if there's one group that you want to run this model by, contact us at Never Again Moss Landing because we've been living with the results. Here's one thing that occurred that I'd recommend. I don't know how to put it in a question. In the permitting process that you have, it does not show a requirement for the operator to discuss with the first responder organizations thermal runaway or the worst case scenario. Low probability, but it does happen. And when the permitting process occurs and has occurred as 2019 with Vistra Energy in Monterey County, the basic argument is, hey, this is a great green technology. Please permit what's going on, what we're asking for. That statement is not fully truthful. Here's what the true statement is. The storage is a great green technology when it works. The fire at Moss Landing shows that when it doesn't work, it is hugely risky to firefighters and first responders. They don't have a requirement for even drones to be given or provided to the fire people so that they could get an aerial view of what dangers are on site and off site. And where the industry is going is moving into large scales close in like Watsonville, so the fires could get more dangerous. So my question is, what are you going to do about improving the process, the model, so that it addresses the worst case scenario?
I think that I'm gonna call multiple friends here to help me with that question. You know, I think in what I've learned through this process is that there has to be improved more community engagement where these projects are being located. There has to be better communication between all the stakeholders. There are certain laws that have passed. I think the PUC and Lee kind of went through it where there have been enhanced safety standards and the PUC that is implementing, and there are some legislation I believe that is going through the process right now to assist with this. And I believe CAL FIRE, okay. But I agree, there has to be more engagement between local communities. And I think for the Moss Landing incident, from what I understand, it is an older technology. And I think that is one of the challenge in this space, is that the technology is continually changing and improving, becoming better. And that is part of the challenge, is being able to stay on top of these new and understanding and getting the education and training of these new technologies.
Well, I think that we're all working through that and we're all trying to collaborate and try to answer those questions together. And that's why we're bringing everybody here as part of this symposium. I would ask, if you do have questions, if you could scan the QR code, and then we'll try to answer those as we go. Just so that way everybody has an opportunity to ask those questions.
All right, so the questions are coming through. California AB 434, the Safe and Secure Battery Act, applies to any battery energy storage facility 200 megawatt hours or more. Does a moratorium and future standards exempt non-battery tech like supercapacitors? I can't answer that. That is super wonky. I'm not that nerdy, but if anybody here knows more about AB 434, but we can put this aside and get back to it. I didn't want to dismiss that, but I'll go on to the next question. Apologies. How is the collaboration required from SB 38 for emergency response and actions plans part of the permitting process? I'm assuming that this is, is this SB 38 the Laird bill that was passed from a couple years ago? How is the collaboration required from SB 38 for emergency response and action plans part of the permitting process? I think this is a question for a local permitting agency to understand how SB 38, is it emergency plans, are incorporated into their permitting process. Christy, I don't know if you've had experience of how they are incorporating this or not.
Well, that it is part of the permitting process. So these are things that we've even talked about in the stakeholder groups, right? So there's the permitting process for the emergency response and safety guides. So we want to make sure that this is being addressed early, that the land use permitters are aware of these, and that's what the land use permitters want to know. What kinds of things can we do early to start getting these guides and these emergency response, the training, as we have learned and heard throughout this symposium? Training is essential. Making sure that our first responders are getting training on this technology, not just doing a quick pre-fire plan, but really getting trained on this is critical. Sometimes the technology may not quite have been developed at the pre-planning phase, but there is an opportunity to start with that engagement, start engaging fire, coming up with an emergency response plan for pre-development, construction, and then of course a solidified one with the permit process for post-construction.
So just to add on to that, so SB 38 requires all battery energy storage facilities to provide emergency response plans to the counties. So I think there's a couple different aspects to the question that was asked of, one, how are we incorporating that into the permitting process? So for example, I look at CEC because they're in the room and they have a fantastic permitting process. They are requiring emergency response plans as part of the application review process. And they're requiring the applicant to make sure that they're working with the local jurisdiction or the first responders on that emergency response action plans. Like that's a requirement for their permitting process. For the local jurisdictions, I'm not sure what they are asking for specifically in terms of how they're receiving that emergency response plan, but I think that's good feedback. That is part of Molly's process, her work. That's something that we can also make sure is consistent. And then PUC, as part of their recent actions, they have increased oversight of those emergency response action plans to make sure that, again, these facilities have them.
Thanks. Next question. The keynote speaker touched on the lack of knowledge at the local level to successfully collaborate with operators. How can locals be supported with knowledge and expertise on these complex systems? Great question. I mean, it is, again, part of this initiative, and we're finding out what are the best ways for these stakeholders, for operators and planners, developers to better communicate, engage with one another to increase understanding. So that information and any recommendations will be in the guidebook and the playbook that we put out. I'm going to preface this with, I probably don't know the answer to this because it starts with Texas. Texas Chapter 303 now requires utility scale lithium storage to post verified funds or security by year 15 or full removal, recycling, and site cleanup. Will other states follow this model? I'm seeing heads shaking no. No. Yes.
I can only add a little bit. In the BESS model ordinance, which is a new development because the technology is new, part of what that framework is to outline all the various things that are important to that project, from initial approval through to construction and operations, through to decommissioning and returning of that land to previous use, if that's part of it. So the point of putting all that into our, let's say, template ordinance is to be able to have that conversation with all the right folks in the room to say, what are those requirements at that locality for the developer, for bonds, for decommissioning, for emergency response plan, so that all those topics can be thought about holistically, and it's not thought about when it's year 10 or year 20. So that is the point of having all that language in one place to be able to look at it and think about it and plan for it, because, it's not going away and that land will be there. And so some thought to what to do with it afterwards is required.
All right. Next question. Are proximity to sensitive receptors like schools and hospitals be considered when siting? Yes. And again, going back to what Suna just said, what we're pulling together is information and best practices. And those, is not a one size fits all, but each community, each local jurisdiction has to take and develop what's best for their community. So if a project is located by a school or a hospital, should it be 10 feet or 30 feet or 100 feet? That is up to the local community to come together and decide what's best for them. Okay. I think, Drew, this is going to be a question for you. Does the AB 205 CEC opt-in permitting process replace the local permit process?
Thank you. That's a good question. The short answer is yes, it does. We take over the permitting responsibility almost in its entirety. Some exceptions include certain federal rules, but for the most part, the answer is yes. I want to go back to the point that was raised a bit earlier. I think it was a good one about community involvement. We take community involvement at the CEC very seriously. We don't just do a token request for comments and just do that. We, in fact, developers apply to the Energy Commission for certification. And then they come in, and once we deem the application complete, it sometimes takes a few months of iteration. When the application is deemed complete, the statute requires that 30 days thereafter, we go into the local community and we host a public hearing in that community. We have done that now for each of the 3 projects that have made it that far in the process. And these are sometimes rollicking, robust conversations. We get a lot of people. The last one we did, I believe we started at about 9 a.m. and we left at 9 p.m. So they can go on for a long time. We also take written comments. We got over 1,000 written comments on the most recent one we did, and they're still coming in. And we read every single one of them. I personally have not read every single one, but I've read an awful lot of them to get the sense of what the community has in mind. Then we go out and meet with the community again to present whether we're recommending that the project be approved or denied. And my boss, who I referred to earlier, Commissioner Gallardo, and I and some of our staff have gone out personally to review the site, to walk around, to meet with the local elected officials and others to find out what all the concerns are. So we take all that very, very seriously. Thanks.
Thank you. I think we are on, that closes out the Q&A session. We'll move on to the next panel. We do have a table out there, so if you guys want to come talk to us more about the initiative or learn more about what the PUC is doing in terms of their survey of the battery systems in California and the safety standards and the TED task force, we're just out there. Thanks, everyone.
All right. Thank you to all the state agency representatives for participating in today's panel. We're going to now shift to our discussion on emergency response. So if I could have those panelists join me on the stage, that would be great. This session will dive into emergency response practices for BESS related incidents, featuring leaders from the fire service and related organizations. Moderating the discussion is Chief Michael O'Brien, who will introduce our panelists.
All right, good afternoon, everybody, and welcome to the most exciting panel of the day. I think we got videos of fires and it's going to be great, but we've got in front of you a really great group. They're going to start with some short presentations, but before we start their presentations, we're just going to get a quick introduction so you can see who we have. So Rex, why don't we start with you? And if we can just work the introductions this way. So Rex.
My name's Rex Pritchard. I am Second District Vice President for California Professional Firefighters and also a member of the Long Beach Firefighters Local 372.
And with our moderator, I think it's the most handsome panel of the day, but Sean DeCrane, I'm the Assistant to the General President for Health and Safety at the International Association of Firefighters. I spent my firefighting career in Cleveland, Ohio, and also a member of the UL Fire Safety Research Institute's Advisory Board.
I'm also the unit chief for Fresno Kings CAL FIRE. So I have 2 roles, but today I'm here representing Fresno County Fire.
Afternoon, everybody. Rob Resendi with San Diego Fire Rescue. I am the Regional Alternative Energy Emergency Response Coordinator for the County of San Diego, grant-funded position. And I'm also the chair of the Lithium-ion Battery Ad Hoc Subcommittee for Fire Scope.
And with that, how about a big round of applause for our panel? Chief Resendi, you're up first. Just so the panel knows who we're going, Chief Resendi, Rex, Dust, Chief Hall, Chief DeCrane.
Perfect, thank you. Is there a clicker? I don't like podiums. They scare me. So I already did my introduction. So what I wanted to discuss today, I only have like 7 minutes, I think. At least I'll try to keep it to that. And each one of these scenarios or these events that occurred would take about an hour to go over. And that would be kind of a short hour to go over everything that was happened and everything that occurred and everything that we did. So each one of these scenarios, I was involved in some capacity. Either I was physically present or I was on the phone with the incident commander. So I felt like I have some comfort in discussing those incidents. So what I'd like to really focus on is the interesting or unique lessons learned that we pulled out of these scenarios or these incidents. It's not every lesson learned, but it's some of the ones that were a little bit more unique. And those are the ones I'd like to cover. So the first one is the Camino incident. A lot of you have heard of it. Some of you call it the Otay incident. It was technically Camino IC. So that was the Camino incident in San Diego County. As you can see, we had a significant large warehouse. Earlier, I think it was Paul Hayes was talking about how, letting it burn is the best option. And absolutely, if that's an option, it is the best option. But for all the firefighters in the room, how often have you responded to an incident and what you saw on the CAD is what exactly was what was presented to you? Almost never, right? Like how many times you show up to a chest pain and you got a guy with a machete in the chest? Right? It happened. It's happened. Right? So the same thing, the same situation here, right? You want to let it burn. You want to know, you got an energy storage system. I've got a plan. I know how I'm going to act on that plan. I want to do a certain thing. I want certain things to occur. And of course, everything that was supposed to occur did not occur, and the opposite occurred on this incident. Large warehouse, about 5 Costco sizes put together into one. Buildings 1 through 5, and which building was on fire? The middle one, right? And so the middle one's on fire. We don't necessarily always want to put water on these things because they make the batteries go worse, and that's what happened. And then we couldn't stop the water easily, and things just progressed. I'm not going to go over the whole incident, but I am going to go over some of the lessons learned. Sorry, it's a little dark. So some of the lessons learned, pre-planning. Some of the other panelists have talked about interacting with the fire service and the industry is so important to pre-plan. This facility had other incidents and other pre-planning events, so the firefighters that responded were very familiar with it. Large lithium-ion battery fires should be treated as a hazardous materials incident. And so not every department has the luxury of having a hazardous materials team, but on these types of incidents where you know you're going to be there for multiple operational periods, beginning the request for a hazmat team early is going to significantly help you. Not only are you bringing folks that are experts in atmospheric monitoring, most of our hazmat teams have been trained on lithium-ion batteries. They deal with them a lot. And so they're going to be able to bring in a lot of expertise. A lot of this is going to be dependent on sometimes the proximity to the population. So for example, if you've got an energy storage system that's remote, it's out in the desert, there's no population, there's no life hazard, and the design of the system is be able to handle the incident by itself. You've heard that sometimes a fire engine shows up, yep, it's on fire, call us if you need us and drive away, right? That's appropriate if there's no life hazard. But when you're looking at something like in an area like San Diego where we do have high population density, you want to make sure you have a robust response. I think Chief O'Brien mentioned the large response that we had down in San Diego. We had about 30 firefighters on scene 24 hours a day for about 17 days. And we're currently, there's still a fire watch there, right? So this happened in May of 2024, and there's still a fire watch there. Dedicated use buildings for battery energy storage systems design is extremely challenging to the fire department, right? So when we're talking about compartmentalized or containerized systems versus dedicated use, it really makes it really difficult for us. It limits our ability to go offensive in any capacity because that would require us entering a building that's actively on fire, actively releasing some potential flammable and explosive gases. And then building collapse inevitably becomes a problem. If the building burns or you have impact to the structure, you start having to assess the potential for building collapse. The battery energy storage project approved was prior to 2020. I think the 2020 mark for us, at least that's how I typically look at it. Anything that was approved prior to 2020, it's a red flag. It's it's the 1960s vehicle with no airbag and no seatbelt versus what we currently have today. Modern cars with assisted protective defensive measures. You got seatbelts, you got airbags, kind of apples and oranges comparison. So anything prior to 2020, If you're a firefighter and you're responding, that should be a kind of a red flag as far as what safety mechanisms are in place. The application of water not only prolonged our incident, but it also caused additional damage to other batteries, which led to more arcing, which led to more thermal events to areas of the building that were not even close to where the fire actually occurred and where the thermal runaway event occurred. So that's something to consider. It's also important that these incidents be planned for multiple operational periods. You respond to this incident and you think you have it under control in an hour, don't leave. You're gonna come back, right? So plan on staying there for a little while, especially those large ones, you're gonna be there for multiple operational periods. Something to think about is how much water application are you going to have? If you have to use water, you're going to use a lot of it. And if you're going to use a lot of it, is your water system, your hydrant system able to support the utilization of that water? We used about 5,000 gallons per minute for 20 hours. It was at least 6 million gallons of water used on the incident. Can your water system support that type of application? Something to think about working with your water systems. Access to robots and drones was really, really incredibly important for us. Nobody made entry until the robots made entry and took some atmospheric readings for us. And that capability is, I know it's not readily available to everybody, but again, starting the request for those resources early will get you the ability to do that, which will protect firefighter safety. The environmental protection should be considered early in the incident, right? So water and air monitoring kind of goes back to all these things that you need to think about early on. And often when we're kind of running and gunning, we tend to not think about these things. But the earlier you start requesting these resources, the sooner they're going to arrive and the better your incident's going to be managed and planned. And also an early notification to EPA. EPA is heavily involved in lithium-ion battery space, right? They were heavily involved in Malibu and Palisades and Eaton. They were active in this Otay Mesa incident, and they're a very great asset to bring to the table. They allow you to do a lot of things during the recovery phase that you typically would not be able to do. So currently the incident is still under unified command with the EPA, the owner-operator, our county environmental health, and CAL FIRE as the unified command down in San Diego. It's still ongoing. This is over a year later. They're still dealing with the batteries, de-energizing, shredding, tearing them apart, shipping them. And one of the things that was something I didn't consider is the offsite transportation of these sites. You're putting a bunch of damaged batteries in the back of a container of our truck, and you're transporting it up to 15 through California across state lines into Nevada, or perhaps Utah or wherever else you're taking them. So the fact that that hazard is being transported across multiple jurisdictions is something to consider. We've let the team down there has let the folks know that these types of hazards are coming through their neighborhood. Let's talk about another incident, the I-15 incident. This one, of course, as I mentioned, the machete in the chest, you get a battery energy storage system. Of course, it flipped over on the 15 on the way to Los Angeles in the middle of the summer on a Friday morning at 117 degrees, right? Of course, that's when it happened. And of course, it caught fire. And of course, it exploded. A few things to consider that we learned. UN 3536 does not differentiate between lithium-ion batteries and lithium metal batteries, and it does not tell you it's an energy storage system. So that was step one. The backseat firefighter looking at the ERG goes, I don't really know what this is. So that definitely starts to impact your offensive actions. The operations in a hazardous materials environment require specialized training. This is really important. When you are working on these types of incidents, this is a hazardous materials incident that involves hazardous materials and a hazardous atmosphere. According to OSHA, you can't just send the tow truck guy down the road with no SCBA, no training, no PPE to go operate in this environment. If that person gets hurt under your command, that's on you. It's a big deal. So you have to have technician or hazmat trained personnel with the right PPE, the right respiratory protection, that they have either their for example, for industry, they have their HAZWOPER, they're up to date. For firefighters, making sure we're a FRO trained or tech and spec, understanding the limitations of our capabilities. So that was a conversation that had to be had. Initially, the plan was we didn't have a hazmat responder that could actually do the work. And then when we had that conversation, we had to pause and bring in some people that were trained to that level to do that work. Containers weigh 79,000, some weigh more than that. So when you're thinking about we're just going to shove this thing with a dozer, it does not work very well. You need a lot more than that. And so that was another thing that delayed the incident. Some of the other things that we had to consider, we had to move the container. The plan was to move it to the desert. Well, what are you moving it through and who has to get notified, right? So the people that were involved right off the side of the highway, which is Caltrans property, was BLM property. And then outside of BLM was the DOD. And in the BLM property, you see the little turtle there. It was a desert tortoise habitat. So again, just one other layer that needs to be considered, things that you would never think about, just get the box and move it out of the freeway. What are you guys doing? It's like, well, there's a lot of things that need to happen before we can just move a burning box into a desert tortoise habitat to a property that doesn't belong to us, right? So a lot of people needed to be contacted. The EPA had a huge influence in talking through those federal partners. So once again, shout out to them. The other significant life hazards on the freeway, 117 degrees Fahrenheit, 12 miles of traffic in all directions. What are we doing there? How are we treating that challenge? Major impact to commerce. Major impact to commerce. And then the recovery, the container was not removed until October 1st. This incident occurred in July. So it got moved to the desert and then it sat in the desert until October. So understanding these incidents, and especially the recovery phase after we leave, there's significantly more work happening. Another incident happened in San Diego. This is Escondido. This was in September. So a low state of charge does not equal no fire potential. This was in a low state of charge. So just because it's in a low state of charge doesn't mean it's not going to catch fire, because that's case in point, not the case. Unified command with the site operators is critical. I think we talked about unified command earlier. Get that unified command established early. You're going to need their resources. Super important to get that early public safety messaging to both the public and elected officials. Let them know what's going on. Let them know that you have a plan. Let them know that you're doing atmospheric monitoring, that you're keeping the off-site considerations in place. And then the recovery of the container is currently wrapped up, sitting on site, still awaiting removal almost a year later. So getting the gist of the story that these things take a long time. And then I think the last one I'll talk about is the Seaside incident, which was in the Port of Los Angeles. Another significant incident that made significant impact. Drone usage, again, came into, was a huge benefit. If you haven't seen the video, look it up on YouTube. It's a really interesting video. But allowed the firefighters to stay back and send a non-human to go do a little site recon. This incident to me was a huge learning curve from the San Bernardino incident to the Los Angeles incident. It shows us that we can operate in an offensive capacity on these incidents. These incidents don't all have to be back away and let it burn. We can do it with the right trained people, with the right risk assessment, and with the right tools and PPE. We can be offensive in these incidents. And that to me is I hate to use the word game changer, but it's a game changer for the fire service to know that we can have positive success on these incidents. Firefighters and hazmat technicians and specialists are well suited to operate in this environment. They know how to do the risk assessment and hazard assessment. They utilizing fire department resources will expedite the removal of these situations. I think waiting for a properly certified contractor to come do that work is really not a realistic, timely thing. It's going to happen. If you need it to happen fast, the fire department needs to be prepared to do it. The impact to commerce must be considered in all these types of incidents. I kind of equate it into, we have our priorities of life, property, and the environment, and then we have to have impact to commerce as part of that priority. Because multiple millions of dollars an hour is just not something that we can allow to just burn without having an offensive pressure to do something about it. And again, the recovery phase took a long time. This occurred in September, and the box was considered de-energized in October 10th. So that's the end of my presentation.
Afternoon, Rex Pritchard, California Professional Firefighter, Second District Vice President. I want to thank the State Fire Marshal's Office for putting this together. Heard a lot of talk about collaboration and bringing people together and all the parties who are involved in this stuff, and they're leading by example. This is a much needed conversation to have with everybody. A lot of great presenters, and so you always hear about it. Used to be a school teacher before I did this. You want to differentiate yourself, so I'm probably the only presenter that doesn't have a PowerPoint, so you're welcome. Real quick question, looking in the audience, how many people in the audience are sworn firefighters? Okay, for those online, thank you for raising your hand, even though we cannot see you. But I am so happy you are here. These issues are humongous. Of those people who are in the audience, how many of you have an operational guideline or policy on how to respond to ESS incidents? A lot fewer hands for those of you who can't see. For those of you who did raise your hands, or even if you didn't, how many of you have a policy or guideline on post-incident ESS incidents? Even fewer hands. And that's where I am thankful for the State Fire Marshal's Office, for President Brian Rice, our CPF president, for elevating this conversation. We've heard before, fire prevention is overworked. Operations is overworked. The line firefighters on the ground responding to incidents every day, overworked. There is so much going on. There are so many things happening. I work in City of Long Beach. We have a port. We're a very busy department. We are understaffed. Our fire management is understaffed. Our fire prevention is understaffed. And we have stuff moving through the port like crazy. And we tend to be, just because of the nature of being overworked, all of us, reactive to incidents. So for those of you who raised your hands, God bless you and your department for being proactive. For those of you who don't have anything, now's the time to engage with your fire management. If you're fire management, now is the time to engage with your local union to start developing these processes, these guidance. How are we going to respond to these items? Because this stuff is dangerous. We have an Orange County captain went on an incident, and within 3 days went into kidney failure, and now is medically retired before the age of 50. Sean can talk about incidents across the nation where firefighters have been injured and nearly killed, and I'm sure he'll talk about an incident in Arizona where a firefighter and his crew blown 80 feet through a chain link fence from an incident that sat there and blew up on them. Trying to figure this out on the fly in the field is not a good thing. And what concerns me the most, and why I'm glad you're here in person or if you're watching online, is the conversations are going to begin. We're talking about the incident that happened on the TI freeway. What scares me the most, what ends up happening, and we can talk about all the great planning, and a lot of the conversation is about what's going to happen in the development of this project. But when these incidents go bad, and they will go bad, it's not a matter of if, it's when it goes bad. If we aren't prepared, if everybody, and when I say everybody, I'm talking about fire department, I'm talking about elected officials, everybody needs to understand how we're going to respond. Because what is so important and what scares me is you show up to the incident on the TI freeway. Tanner falls over. Fire department, what are we going to come in depending on winds? You know, we're going to protect the community, the workers. We're going to shut down part of the port. In that incident, I think it was within hours, the White House calls, hey, what kind of impact is this going to have on the economy? And all of a sudden, if everybody doesn't know ahead of time that we have something that's going into your community, that, okay, it lights fire, I think the phrase was successful failure, we're going to let it burn for 36 hours. And let's say in the Port of Long Beach, we're going to shut it down for 36 hours. What do you think is going to happen? Or if it's near a residential community and maybe we have to evacuate part of a community, we're doing what was in part of the plan, just let it burn. But what's going to happen? Residents, businesses, they're gonna start making phone calls. What are you doing to mitigate this? What are you doing to stop it? And I'm always concerned about the pressure that would go on an incident commander to do something. To sit there and be like, hey, you've got to do something. We have to do something. We're firefighters. That's what we do. Very difficult. I'd hate to be an incident commander on an incident like this, trying to hold back a bunch of firefighters who want to go in there and put this out. But it's something that you have to go in. And when we talked about earlier, the importance of the emergency response plan and the development of these, that is super important. Super important. And I'm sure your experience is a lot like mine. Fire prevention does not always talk with fire operations. And that's why I think it's important it was highlighted that a emergency fire operations plan is in place. Because at the end of the day, when this stuff goes bad, it's the line firefighters responding to this incident. And right now, a lot of hands didn't go up. Something could happen. Of the hands that went up who are firefighters, how many people are here because you have a BESS system going into your jurisdiction? Okay. If your hand isn't going up or if you're watching, just because you may not have a BESS system going into your jurisdiction, this is something you still need to have a plan for, because they be going through the freeway in your jurisdiction, down your highways in your jurisdiction, just because you don't have something going on. And that is one thing that I didn't hear a lot of discussion about today, was the transportation of these items. Because again, talking about the I-15 major corridor, I guarantee you, I don't know the specifics on that one. People were calling because of the interruption into people wanting to go gamble in Vegas or commerce. So super, super important. Real quick, of the people in the room who's in the industry or trying to develop a BESS system? Okay. To you, the thing I hope you take from this, and I think is super important, is collaboration. I hear it, and when you hear collaborate with your fire agency, it's just not the fire department. Collaborate with the local union. And again, the fire administration, fire prevention bureau, they're gonna be busy. They may not let the union know that's going on. I promise you, the firefighter union in the jurisdiction that you're operating in is gonna be more than willing to sit down and have a discussion. It's a collaborative effort. So when you hear engage with fire, it's fire administration and the local fire union. Super, super important, because what ends up happening, and I give a lot of credit to President Rice in this symposium as well, because I know he has engaged the State Fire Marshal's office on this topic, because we hear from the line firefighters the issues that are going on. And through that collaboration, we've elevated a few things, I think, to this level to begin this conversation. With that, I'm gonna finish up with one thing, which I probably should have had a PowerPoint for this. I'm gonna put a couple bills that California professional firefighters are sponsoring or co-sponsoring, and something that's, watch and keep an eye out. Super easy to go online and track bills, and you can see where they're going through committee and appropriations. But California professional firefighters have listened to our members. President Brian Rice has listened to his members. Also GST Frank Lima, 10th District Vice President Steve Gilman have been big in moving this subject to the forefront of what we are. But keep an eye on SB 283. Just real briefly, this would require that, will require all facilities meet NFPA 855 requirement that projects applicants meet and confer with fire agencies, and require fire inspections be part of the proposed project. AB 841, this has to do with the health and safety of firefighters. And, after an incident, are we wearing the appropriate PPE? How do you clean it? How do you determine if it is clean? So there's a lot of issues there in the post-incident. And then also AB 1285. A lot of this puts onus of more work on the State Fire Marshal's office, but you guys do a great job and we have a lot of confidence in you. But with that, I'm gonna go a little bit too long and thank you for your time.
All right, let's try this again. So you guys already heard that Fresno County is going to be a mecca for the increased growth. And so I'm going to go as fast as I can, but I'm so glad that the speakers before me already set the stage on the incidents. We haven't had a ton of these major incidents yet. However, all this is coming. So as the Fresno County Fire Chief, I'm responsible for 4,200 acres, or I'm sorry, square miles, and the cities above. Our property tax is property values on the west side of Fresno County are low. It's all agriculture. And our property tax rate is 0.00078 of the 1%. So that means if you have $1 million asset, you get $780 for that property. That doesn't pay for a firefighter's salary of 1 day of overtime. And so when these are being built, one of the things that we're trying to do in our county is build fire service agreements. We want to build partnerships. They're not impact fees. They're not mitigation fees. They're agreements to provide fire protection for these facilities. Some of our issues that we have in Fresno County that we've already talked about today was the Williamson Act. The suppression of property taxes make it very difficult to collect. 62% of our property value is under Williamson Act, so we don't get the funding that we should. 9% is tax exempt. They don't pay any taxes at all. And conveniently, the BESS and solar developments in Western Fresno County are on all of this property. So you can see by the different colors, the light blue is Williamson Act, the pink is tax exempt. And so as we look at how do we provide fire protection to these areas, you'll see the 4 red circles. Those are the 4 fire stations that provide fire protection to that side of the county. We have 2 firefighters on each engine. And as you can tell, our other resources are coming from Eastern Fresno County. It's a little farther away. So as we are going through this process, starting in December, we were contacted by the CEC looking at different opportunities for some of these opt-in projects, Darden being one of them. So what we started doing is basically do an internal master plan study of how do we protect our residents, the new developers, from the incidents that you saw from my partner from San Diego. So we looked at the general plan of the county, and basically any fire stations, any new ones need to be located to achieve service levels that are correspondent response times. Response times in Western Fresno County are upwards of 20 minutes. And it also states that any new development should not take away services from other developments, so they got to pay their fair share. And so, like I said, most of that area is 20 minutes. So this is our current matrix in response times. The dark red are 20 minutes, and the one on the left, you can see the yellow in that other little diagram that's inside of that boundary. We have 130,000 acres of BESS and solar voltaic coming to Fresno County through the next several years. So how do I protect that? How do I protect that area with those 4 stations when you saw that it takes several engine companies, truck companies, hazmat companies, several days? So the internal assessment followed. And we have land use agencies you guys talked about earlier. So we deal with the Fresno County. Work hand in hand with them, the Energy Commission now, and then also Westland's Water District is a new one that's been added that allows them to do the permitting process. All these facilities have the same issues that we do on a daily basis as an all-risk fire department. And so as we look at Western Fresno County, just on simple conditions, we look at the west side. It gets hot, it's dry, it's predominantly grass because it's all farmland that is now dormant, and the fuel loading is there because there's nothing to take care of the mitigation of fuel. So you can see the fire progressions, 15 minutes, 30, 45. And so I just want to focus on the 15-minute one. You'll see that it's approximately 24 acres unaided. Well, our response times are 20 minutes, so you can kind of see how big the grass crop is and the fires. This is a low fuel load, 6 to 8 inches. So now we go to 12 inches and you see the dramatic increase in size. So it's 15 minutes. 450 acres almost in that same time frame with the same amount of wind that we normally get. So this one shows gusts 25 to 35. That's oftentimes, if you've never been on Western Fresno County, it's a normal thing. So this particular incident or place, this is Scarlet, pre-2020, like you guys have discussed. All of their area is that purple, which means tax exempt. I don't get $1 to protect their services. However, we sent apparatus 60 times in the last 4 months for incidents. And as we go to the next thing, you'll see a little grass fire that we had there. So this is a little plug for Tablet Command. This is how we run our incidents. But you can see the squareness of the plot. On the western side of Fresno County, our tactics would normally be, we would backfire, go to the next road, fire it off, and burn off 60 acres, and we're home by dinner. Not a lot of risk and not a lot of gain. It's usually abandoned orchards. But they put all the solar on there, so it changes our tactics. So we had to add more resources because the way that their fuel loading is, and we all know that the best laid out vegetation management plan is going to be followed, right? You know, we all do our LE 100s. We make sure that our clearances are met. That's why kind of like we have a job. But look how low the grass is. But you can see just in this diagram what that does. This was in May, not even full-fledged fire season of the fire year now. So very limited access for firefighter type 1 engines is what we have on the western side of the county. And so we can't just go and mobile attack. We can't do a hose lay because we're going in and around. And so sometimes we're crawling underneath the solar voltaic just to get in and around. And so what that does, it creates a tremendous workload for the firefighters. So we got to bring in more resources. We have to have another shift or R&R, because as it gets hot on the west side, you know, just as my partners have talked about, it takes a lot of bodies. A little bit of a video, and you can see it's not high intensity, but look at the spacing. And that's wide enough for a pickup to go through, not an engine. And so, again, it requires more effort. And so as the codes continue to move forward, we're looking forward to that. But having adequate tools, whether they're type 3 engines, patrols, you have to have the right tool for the right job. And that's what we're trying to get to. And so where does this all come from? Is basically, you guys have talked about how do we do this? Well, if our property tax doesn't cover this and we have all this new growth, somebody's got to help us get there, right? And so what we have been doing is we did basically a master plan on the west side. How do we meet the needs to cover 130,000 acres, a combination of BESS and solar? So we added 4 new stations, 3 people at each engine company, and we added water tenders at every station, because on the west side, the reason that it's dormant, there's not that great of water. And so, like they talked about, you're going to need lots of water depending on the thermal runaway. The goal is not to use the water, but you saw that they were flowing master streams for several hours. So when we don't have any hydrants, because we don't have the city, we don't have fire stations readily available like Southern California does. When they want to build in an area like ours, we have to come up with a way to protect it. So we went through line by line our budget. We came out, what do we need? We had a third party evaluate our methodology. We came up with a formula for initial impacts and cumulative impacts. And so as we continue to move forward, our goal was to, 1, add those 4 stations with apparatus. You can dramatically see the difference in coverage now, all that stuff in green. Now we can actually protect within 20 minutes of those areas for the solar. So we did that methodology. And so one of the things that I'm really trying to do is find a way that it's equal to firefighters and fire departments. It doesn't matter where you are. It's just a math problem at the end of the day. And so we came up with a dollar figure per megawatt hour for solar and BESS. There's year one costs for the infrastructure, fire apparatus, personnel. And then year two goes down significantly because of all you're looking for is the personnel and the maintenance costs for down the road for the replacement cost of apparatus. So the methodology can be scalable based off of need. If it's in the city of San Diego where they have fire stations a lot more prevalent, they may not need as much as we do, but we don't have anything to protect that area. And so what we do have is going to take a significant strain from the residents in eastern Fresno County. And so when we came up with the formula, it makes it fair based off your size of your project, so that not one project is taking the lion's share of the burden. Everybody has a piece of the pie. And so we just went through the whole thing and came up with what our needs are and came up with a dollar figure. This was presented to the CEC, the Board of Supervisors, and they're on board. Some of the solar and development companies are not on board, obviously, but that's why we're here. You know, you guys all know the potential that's out there. I don't have the ability to protect that area. And so if I'm being asked to sign off on these permits, we have to have a way to do that. So as we continue to go through this process, we have an ordinance in place that validates our formula. And the formula, like I said, is for initial impact and for cumulative, so it's ongoing. And we have it in the ordinance that it goes until the project is decommissioned and goes back to the original soil site. And so that allows us to provide the adequate protection. So we currently have two agreements that are signed. As the process goes, and you guys are talking about the land use and the permitting, we are working hand in hand with our county staff. And what we're trying to do is, as they're asking for comments during their initial EIR, is we put it in there as one of the conditions is a fire service agreement with Fresno County Fire Protection District. It's not a mitigation fee. It's not an impact fee. It's a partnership is the way that we look at it. It's no different than the partnerships that I have with the tribes in Fresno County that we provide fire protection for. It's that hand-in-hand partnership that we can provide services to them. So basically, in conclusion, I'm super thankful to be invited here. It's great to see so many people in the room and online that are taking part of this. But my hope is that we can work collaboratively with the CEC, the county public works, the agencies that are doing these permittings, so that the local agencies, when they do bring up an issue, that it is brought up ahead of time. It is in the permitting process, so there's no hidden fees, any agendas. It's upfront what it costs, and you guys know how expensive for the firefighters. It's no different with everybody else, whether it's a public. So the goal is that working with the unions, the state fire marshal, come up with a process, because every place is different, everybody's needs are different, and if we can find a balance, the math usually works out. And so I appreciate everybody's time. Thank you very much.
Thank you. Sean DeCrane with the IFF, as we talked about earlier. So thank my colleagues for kind of setting the table here. And I think we start to understand some of the risks that new technology comes to the marketplace, but we've seen that before. Anytime new technologies come into the marketplace, it's a challenge for the fire service. A lot of smart people go into developing new methodologies, new construction practices, new technologies, but very few times do those folks start to consider the impact of fire. This is a facility that was built in Arizona. Rex hit it on the head. I have to bring it up, right? A lot of smart people went into the development of this facility, to the implementation of this facility. The community needed this for peak demand. What they hadn't anticipated, and I was part of the investigation team that went out and did the incident planning, and they admitted, we never thought this could happen. And what was that? That was the failure of the ESS system and the fire department response. And we talk about collaboration. We talk about the pressure from the community, as presenters have already mentioned, there was pressure on the fire incident commander at this scene. When can we have our building back? When can we take possession of it again? When can we start moving forward? The fire department took a very conservative approach to this. They waited over 2 hours after they were on scene, over 3 hours from the failure of the battery, where no smoke, no byproduct was visually apparent to them before they even made an attempt. And simply opening that door caused the deflagration, the explosion, the ignition, however you want to define it. If you look at this picture right there, real quick, up in the top left, when the firefighters came around the corner, they initially only found 2 firefighters down unconscious inside that fenced-in area. They could not locate the other 2 firefighters. They shortly identified 1 additional firefighter and declared that he was deceased. That was the Captain Hunter Clare that was in that burning bush right there. You can see some of his equipment. They started to attend to the 3rd firefighter, or I should say the 4th firefighter, over in the other burned area, which was the engineer, who was projected approximately 35 feet out into the desert, when a firefighter noticed that Hunter Clare was moving. He was life flighted. He coded 4 times on the way to the hospital. You see, that is his equipment and the engineer's equipment that was pulled off their bodies as they went through the fence. That green object is actually a steel frame door that was blown off the building. And if you look at that building that was nice and square, or I should say rectangular, is bowed out like a pear. So the point is that things happen, things fail. What we need to understand from the fire service is, what does failure look like, so that we can prepare for that response, so we know how to respond and develop our guidelines, our SOPs, so we can operate and bring this event to a successful and responsible conclusion. What that takes is collaboration. And that's kind of what I want to talk about moving forward. I don't want to be on the dark and gloomy side and the sky is falling, because what we've done from a fire service perspective, remember at the IFF, our #1 priority is the health and safety of our 357,000 firefighters across the US and Canada. Our General President, Ed Kelly, is an active Boston firefighter. Rex mentioned him. Our General Secretary Treasurer is an active Los Angeles City firefighter. And his daughter just got on the job. So this is personal for us, but we can't accomplish it alone. So we reach out to our partnership, and we reached out to UL Solutions. I think Alex Schreiber is going to talk about this later, and UL Fire Safety Research Institute. Starting to look at that incident in Surprise. What are the lessons that we learned? So we started to look at, and it was funded by Steve Kerber at UL FSRI. We started to look at the 3 scenarios. 1, unprotected, protected with a clean agent, protected with the sprinkler system. Even using a conservative approach, 0.5 gallons per minute, during the sprinkler system, while it was actively flowing, we still realized a deflagration that failed a deflagration panel. Does that mean it's a failure of the system? Absolutely not. The challenge that we have with batteries, what we try to do in the fire service to extinguish any fire, whether it's a house fire, a building fire, get water on the burning surfaces. But we have to protect the battery cells themselves from the 3 leading causes of fire in the US. Men, women, and children. I know some of you have heard that, right? Because they're susceptible to damage. They're susceptible to outside influences. So rightfully, industry packs those in containers and in modules and cabinets. That also protects those battery cells that have failed from the application of water. So we still have an accumulation of gases. We still have the ignition source, which is the battery, right? So what we have to do is understand those challenges and develop response tactics to meet that. So UL again partnered with our friends at UL Solutions and FSRI. We worked with the contract with the US Department of Energy really to look at residential ESS, because there is a lack of information on the failure of residential ESS and the fire service response to it. We worked with our friends in California. What's the most popular application? We looked at the code requirements. So we picked a 2.5 car attached garage. We actually had to reinforce it there. So unfortunately, Joe Treadway didn't want us to damage the laboratory for some reason. He had other use for it, but so we had to protect that. I'll show a quick video. You've seen battery failures before. We call it fire porn. We have to show some type of video. You see the rapid buildup of gases, right? But what's the consequence of that? Because we know the battery is going to provide that ignition source. And you see, when we start to look at what's this weak point of that of that structure. What's the deflagration panel in that structure? It's that overhead door, that garage door. Why is that important? Because if you look at this incident, where is the incident commander? Right on the side A, right in that driveway. And that is just prior, and I'll show you a video here, of a failure in Erie County, Colorado. But if you look at to the right, that's actually a video. And that's from test 4 of our DOE project. And that is before we open the side access door. But it's hard to see, but that door is actually moving. We are actually realizing a deflagration inside that garage with no visible indicator that there's any fire or battery failure. And that's exactly what happened in Erie County. When we started conducting this research, we took the inside research that we did with the DOE. Steve Kerber funded the outdoor. We wanted to take it. Can we size this up? You know, what is the explosion hazard? What degree of battery gas creates the explosion hazard? What does that look like? So we had to go with Alex Schraber here. She's going to talk more about it. Had to go to a bomb range in Indiana to conduct this. We were surrounded by cornfields and AR-15 flags. That's how remote we were. But when we first started doing this, industry said, these are scared tactics. You're going too far. You're trying to put the fear of God and firefighters on batteries. And the answer is, no, we're not. We're not trying to scare anybody. We're trying to educate. Don't be fearful of the process. Let's work together through the process so we can educate our firefighters. And then when this incident happened in April, first of all, we were like, is anybody injured? Thankfully, no. There were firefighters inside this garage when this ignited, and you'll see the consequence. But thankfully, no one was seriously injured. And then we started going, holy crap, because it looks just like the research. And this is the incident on the right. This is actually the body cam of a cop watching his heroes at work. So, yeah. And then on the left is the research project, and you can start to see the similarities. So we're starting to go, okay, we're on to something. We can start to develop some tactical considerations. And that's exactly what we did. So this is actually a QR code. This takes you to the report that was put together in partnership with UL Solutions, UL FSRI. It's on the IFF website, on the health and safety page. If you take that QR code, you can get to it. It's a very comprehensive report. We also put out a safety alert. It's one of the things we do at the IFF, and we start to get these topics. I'm trying to do more of it in our health and safety. We took the tactical considerations and the explanation, and we put it into a safety alert and put it out to our members. That takes you right to it as well. That's available to all, not just IFF members. And then we also worked with the project with the AFG program, and we had 2 of our members, Chris Green retired from Seattle, Chris Towski from Cambridge. And one of the things we recognize in the fire service is our training has come from the local utility, usually by a representative with no fire experience. This is no disrespect to them at all. They are trying to provide training to our firefighters. What we needed was actually a comprehensive guide, very similar to an ERG when responding to hazmat, to respond to energized incidents. So we break it down. You see all the topics: switchgear, transportation, substation, underground, renewables, overhead, batteries, and also vault and manholes. We have over 50 videos in there. We talked about how to recognize that energy is involved. We talk about strategic considerations, tactical considerations. This is available to anybody. How do you get it? Right there. This is open to anybody. That you can download a PDF version, but it's also accessible and searchable. So you can use it as a training guide, or section by section. During a response, you can actually go to this site and start to look at it, look at your PPE considerations, look at your tactical considerations. We talk about incidents where firefighters have been injured. Unfortunately, we talk about incidents where firefighters have been killed in energized incidents. The indicators were there, they just didn't see them. And then, yep, there's the energy hazard guide. And I'd be remiss if I didn't put up our safety alert on the deployment of the fire blanket in the electrical vehicle incident. So again, that's available and free for everybody. This was an issue that we saw that we really needed to notify our members, because we do not have an industry standard test for these products, and they are in the marketplace, and the deployment comes with risk. We need to understand that. With that, Michael, I'll turn it over to you so we can get into the discussion.
All right, so just like we've been doing all morning, we're gonna have some questions, so please scan that QR code. It's the same one that's on your phone. You don't have to rescan it, just hit refresh. And we'll start working through some of the questions and the like. A speaker mentioned remote data collection via drones. Has that been a sampling of smoke material or just a presence or absence of certain substances? Rob, I don't know, Chief?
Yeah, but maybe I misspoke. It was not data collection via drones. It was utilization of drones to do site survey and usually just using infrared for heat detection. We did not use any atmospheric monitoring drones.
And obviously to the panel members, if you want to add in, please feel free. Integration with local emergency management organizations for the operational area is critical. What are the best practices for clarifying roles that the panel's seen? Rex, you want to try?
I think I'm understanding the question with regards to bringing everyone together. Is that kind of, yeah, so super important, just the initial conversations. I've had experiences in Long Beach with BESS systems, and the first time it went didn't go very good. Second time we're doing better, and it's bringing everybody to the table. And I talked to the developers out there. Bringing the firefighter unions in is super important because in the development of the emergency response guideline, department should be developing what the response plan is going to be. When that department develops that, they have to meet and confer with their local union. So bring them in early. If you're a fire chief, bring them in early because you want this collaboration to happen throughout versus you come up with a final product. This is what we're going to do. You throw it to the union and the union's like, this is no, we absolutely do not agree. So the collaboration is huge with the fire chief, with the developer, with the local firefighters, and that emergency response, I think, is super important. There's so much focus I even heard today on the development, how you get it there following 855, but the emergency response plan, that is vitally important. So when that incident goes south, whether it's the elected officials as it gets approved through the permitting process, everybody knows when this goes south, this is where and how we are handling it. So nobody's surprised.
Yeah, Mike, I'll just build on that. I think Rob mentioned it and Dustin mentioned the importance of that pre-engagement. When we went and myself, Dr. Steve Kerber, Dr. Mark McKinnon started doing the after action report in Surprise, Arizona, it was very evident, one, the developers and the local powers utility had no idea this could have happened. And they had no plan. And so one of the recommendations in that report, and that's free on the UL FSRI website, fsri.org, was that in the development of the emergency response plan, the local fire department has to be involved in that development, and it has to be specific to that installation because the resources and capabilities in every jurisdiction is a little bit different. Not everybody can be FDNY and have 58 firefighters on scene in 10 minutes. You know, we know, like Shane Ray, I'm just trying to get 8 firefighters there today, right? But it's critically important that fire department knows when they need to initiate mutual aid and who that mutual aid is going to be. And that has to be done ahead of time. It can't be sitting at the command table and starting to scratch, hey, Rob, who do we have available? Who should we call? You know, it's got to be planned out ahead of time. And it has to be that engagement way ahead of time.
If I can just add on that from a local level, I think it's really important to know who you're sending to these meetings and who is standing in front of city council, board of supervisors, and who's having those conversations. And so if your agency or your county or maybe the state region doesn't have an identified subject matter expert, get one, make one, build one, make it happen so that that person can be grabbed. So when a city official has a question, technical question, you have a firefighter that knows the technical answer or knows how to get that technical answer back to that person. Because if you put the wrong person in the room, you get some squirrely answers.
We've got a couple questions about EV response, so just to frame your head up on around this. The first one talks about separation distances
from vehicles that were involved in fire. I think we know that most manufacturers and everybody's saying don't use submersion. What are you using in your community for those towing practices where they go sit in that high peak period? How are you keeping 50 and 60-foot separation? Are you using walls, separation?
Go ahead, Dustin.
We've had a handful of Tesla vehicle accidents, and luckily we were able to get a tow chain and we were able to take them out into an orchard. So they were basically at 100-foot clearance all the way around them in the orchard. But it's another thing that brought another realization to me was the amount of decon that we needed, because when we get there, there was two victims. So the firefighters go into rescue mode and they're packed up, but now all their stuff's contaminated. And so all the smoke, everything had to be deconned and let the engine be deconned for 24 hours. But we also found that the tow trucks don't heed our warnings. So it goes back to that collaborative effort with all the responders, getting them to realize if you don't need to be in the smoke, don't go into the smoke. But for that one in particular, we had the luxury of being in an orchard where we could tow it offsite.
Yeah, a direct answer to your question, yes to all the things you said. Some have put into place walls, 3-sided walls. Some are able to do the 50-foot clearance. Some don't follow those recommendations. And as far as the bigger picture is that we really need to engage and do a better job of engaging with our second responders and try to get them to get on board with some of the things that we need to do to prevent the bigger incidents. Usually it takes a big incident for them to kind of wake up and realize that they need to engage with us, but engaging the second responders is really important. And I think something that's we're starting to see some challenges in is towing companies refusing to tow. And that's something that I think as we start getting the volume of vehicles to be 50, 60, 70% of the vehicles on the road, you're going to start seeing some tow companies basically kind of step away from that responsibility.
I just want to add one thing when we talk about vehicles. Wear your SCBA. I don't care if it's an EV. I don't care if it's an internal combustion engine. We have a lot of elements in the engines of internal combustion engines, magnesium. It's all plastic now and components. And I see way too often firefighters responding to ICE vehicles or EVs not wearing an SCBA. So if I can just add that, respiratory protection, please.
And maybe for Rex and Rob, any policies or procedures in your jurisdictions for EV fires in parking decks in removal? Anything changed in your world on that?
For us in Long Beach, we were one of the reactive departments. So we had, lack of a better word, a chop shop, of which there were lots of battery packs, Tesla battery packs. And we responded to it, and lo and behold, you're going in and good Lord, look at all this. It took the union stepping in because we've been involved in this discussion for a while. We collaborated with the fire chief and operations, and on the fly developed a plan by calling Orange County, who already went through it, and calling other neighboring jurisdictions. So we were one of the reactive departments, and we're still learning. But we have developed a policy, and I'm sure with those in the hands that didn't go up, reach out to your neighbors, reach out to your local, let your union president interact with the IFF, with CPF, and help build it. I promise you, DVP Gilman, myself, President Brian Rice, we're there to help. This is a big deal to us because it's the health and safety of our members.
Yeah, to your question specifically, removing vehicles from underground structures. My technical rescue team and I have come up with a plan. We don't have an SOP. And part of the reason is because a lot of the required tools require money, right? You can't just wing it and decide how to move a vehicle without tools. And that's always a challenge for us. But we have some ideas of certain circumstances. You have different conditions, whether it's moving a vehicle that's actively off-gassing or on fire, or moving a vehicle post-stabilization. Those are two different tasks. You're not going to get a tow company to buy off into going into a smoke-filled or gas-filled environment to go tow a vehicle when they have no PPE, and you can't send them down there legally. So your fire department needs to figure that part out, but the short answer is no on the SOPs.
One of my favorite videos is Rosemont, Illinois. They had an EV fire and the firefighters drove the tow truck and you just hear the vehicle squealing all the way through as they're working to get it out. But this is a good question from a sense of codes meeting ops. There has been major changes in codes to really in all parking decks to get sprinkler protection, and both the NFPA Research Foundation and the changes in NFPA 13 to get a higher density sprinkler system. The fire code and building code have tightened up their square footage requirements. And it's not just an EV thing. It's, as Sean was saying, it's a combustion vehicle in these vehicles and how they're burning. Rob, did you guys, I know you demoed the cold cut Cobra. Did San Diego make a purchase on that, or?
It's in a grant that we were able to procure. It should be getting purchased right after this October. I know that Orange County Fire Authority has purchased 2. And so they have more experience, although I don't think it's been put into play just yet. But they purchased, they got the training, they got the trainer.
And Sean, maybe you can just clean up what I say, but one of the things that's come up a couple times here today is cleaning a firefighter turnout gear post battery exposure. I know that our organization, when we have heat and really direct exposure to a battery fire, that gear is getting field deconned and then packaged. We ship ours to a company called ET Decon, who does carbon dioxide gear cleaning. And from a fire chief standpoint, I love that I get a report back that it shows it's clean. We learned from some inside battery fires, EV fires, that burnt juicy fruit smell after multiple extractions wasn't coming out. And I'm not a scientist, but if it still smells like that, I'm guessing it's not clean. So is the IFF working on anything as it relates to like health and wellness and cleaning a turnout gear both? Is there any other ideas besides the carbon dioxide cleaning?
Okay. There actually are a number of studies going on right now. TEACS just published their study last fall looking at the effectiveness of cleaning PPE following exposure to lithium-ion batteries. And in the TEACS report, again, this is the first report, they found a high efficiency of cleaning of the gear of the heavy metals. So a lot of the time, what they found also in their report is that the outer layer of the PPE was actually stopping the vast. I think it was 97%. Don't quote my math, but I think it was 97% of the heavy metals were stopped at the outer shell.
Cleveland Public Schools?
Yeah.
Math?
Don't
Okay.
throw a bunch of toothpicks on the ground and ask me to count them. But so that was encouraging, right? It's encouraging that the outer shells containing the heavy metals and reducing the exposure to the members. It's encouraging that the cleaning seems to be effective. The carbon dioxide cleaning seems to be effective also for many of the VOCs and other contaminants. Right now, it's pretty expensive. What we're hoping is that as it becomes more available, those costs come down. But we've also seen changes in NFPA 1584 to try to increase the cleaning efficiency. Right now, to meet that standard, you only have to remove 50% of the contaminants. Now, how do we improve that? And the standard is working on improving that right now, and also introduced higher temperatures into the cleaning process, which has been demonstrated to be more effective at cleaning the gear. And little known fact, NIST did publish a report that non-PFAS gear was actually more effective in getting cleaned. I don't know if I said that correctly, but your cleaning methods were more effective in non-PFAS gear than it was in PFAS-laden gear. So a lot of work is still going on. I know the University of Miami is working on one. Dr. Jeff Burgess, along with LA County, is also working on another project with exposures to lithium ion and PPE cleansing effectiveness. And the FSRI project is also doing that.
Yeah, I think we're going to see a lot of details on that. Chief Hale, one of the questions is, some people would like some more information on the county project. Should they reach out to your office, or is there a certain person?
If you go to FresnoCountyFire.org, you can get information to our office, and you can just ask for me or Chief Cosentino. But website has our contact information.
And I'm not sure who might want to take this one, but as we start to think about hazmat response, why in BESS incidents are your departments requesting hazmat response?
So I was a hazmat program manager. I think I can speak a little bit to our response protocol. So we're lucky in the city and county of San Diego that we have a joint powers agreement with the county environmental health. Together, we make up the county hazmat response. So two reasons why we do it. One, battery energy storage systems have a high visibility and require, if you have available, a timely atmospheric monitoring, constant atmospheric monitoring, the ability to measure what's coming out, making sure that we're not exposing the community to unknowns, making sure that we're tracking down any concerns or complaints or questions, making sure that we're tracking water quality, water testing, atmospheric monitoring, all the different things that we do, and also the ability of our teams to really look through an SDS sheet and be able to really get down to the information that's accurate. The second reason is because our team is right there. You know, we're about 30-minute response time to pretty much regionally anywhere other than the far reaches of the county, which is a little further drive. But that's the other reason, access. I know that there's a lot of agencies out there where their closest hazmat team is like 6 hours away. And obviously that's not a realistic response time to some of these incidents. But if it's going to be a multi-operational period, just start rolling a hazmat team to your location. They're only going to add to your situational awareness.
You know, Mike, that's such a good point because, Rob, I respect that you guys have that, but the vast majority of fire departments in the US don't have hazmat response capability. And this is a personal belief, I don't think every incident has to be a hazmat response. In fact, we have to get to a place where it's not a hazmat response. FDNY, they have multiple hazmat teams and they can respond, you know, and this is no disrespect, but a child's toy fails, hazmat response, right? We can't do that. And so that requires us to train our firefighters to have the knowledge to respond to these incidents so that they can start the mitigation efforts. It also requires us to work with researchers and industry to understand what are the hazards, what are the risks, what are the exposures to the community. Is it more hazardous to put water on it and create a runoff with heavy metals, or is it more hazardous to allow it to burn? We don't have all those answers yet. We're working to get those answers. And I think that's going to help us guide with those responses. Again, I respect the fact that the hazmat teams can and have those capabilities and get there and help mitigate it. But I think the bigger challenge for us is to start to prepare the majority of firefighters to get there.
If I can just add to that, I 100% agree. We're have the luxury of having that in California, especially in some of the larger cities. I think for the folks online or folks that are not, don't have that regional capability, that's where that relationship building goes back to, not just with the industry, but looking at your environmental health, your local EPA responders, your regional EPA, Fed EPA, and having those conversations, having those phone numbers, having it's not who you are, is how are you, right? So having that quick response, because again, if you're looking at a multiple operational period, and I'm not talking about micromobility, that kind of stuff I think can be handled without hazmat, but talking about the big stuff, the EPA is going to come out and show up and help you within 12 hours or less, right? So having those relationships, knowing who to call and getting those people rolling will help.
I was going to be a political satirist and say if the EPA is still around, but.
Good point.
All right, so we're going to wrap up with and you guys hit a couple questions that were in the list, so I appreciate that. Rex, starting with you, what's one thing that you hope people turn into action tomorrow? They go back to the office, they go back to shift. What's one thing that you hope that turns into action?
The conversation. So whether you're a local president or a fire chief, that if you haven't had a conversation about the response, you meet up and you have one. If you're on the floor and you're a firefighter, you sit down with your crews and you have a conversation. Hey, what are we going to do? How are we going to respond to this? If there is no direction from the top down, create it from the bottom up.
Chief Rezendi?
I think the biggest thing to take away is where your SCBA, and that's the number one thing that we should be looking at. I think every detrimental impact to our personnel that I've been aware of has all been because we were not wearing respiratory protection. And so could not emphasize that more, not just during the actual active incident, but during overhaul. And if you think the incident is over, it's probably not over. So if you don't have to be exposed to stuff and you want to take your SCBA off, then go away from the potential contaminated area. But if you're going to be working inside the area, even if you're just doing basic cleanup, wear your SCBA.
Chief Ale?
I think for me is to keep being a lifelong learner. As we keep progressing, we're learning every day. And I learned more today about BESS. And so, but being able to make sure that the fire departments are funded appropriately to be able to handle these situations.
Well said. Sean?
Oh, thanks.
Last but not least.
Thank you, Michael. Preparation, be prepared. Individual firefighters, prepare yourself. There's online education, FSRI, UL, IFF, other sources. So prepare yourself. Don't just wait for the department to do it, but from a department perspective, prepare yourself. Be engaged, understand what's going into your community, get engaged to pre-plan these sites and develop policies, understand what your options are, what your capabilities are, and when you need help. Being prepared ahead of time is going to make these incidents a heck of a lot smoother.
I want to take a quick second to thank this panel. They are absolute resource. Hopefully you captured their information. And I know just about everybody up here is willing to share their information. I know we're going to go to a break and then hit the second best panel of the day. Please be back. I'm going to say it for Tim. Please be back at 3:40 promptly. Thank you all.
Okay, so welcome back, everyone. It is now 3:42. We're trying to stay on schedule as much as we can. So hopefully you can avoid a little bit of traffic on your way home. We are now up to our final panel. Our final panel will cover the latest research and technological advances shaping battery energy storage safety. Moderating this panel is Greg Rogers from NFPA. Greg, the floor is yours.
Thank you, Tim. I want to give Chief Spears here a round of applause. He's done a fantastic job today. Let's give him a round of applause. I got to say, there's a couple of things that I've learned up here, and while I've been here throughout the day, and I got to say, one of the most entertaining things that I've seen is the young gentleman over here that was doing signing when they were talking about the hatchet in the chest. I thought I was going to roll in the floor of having them demonstrate how that happened. So from San Diego, you did a fantastic job, but you should have been watching over there when you were taking the conversation. Just to introduce myself and just to go over, my name is Greg Rogers. I'm a regional director with NFPA. I've been in the fire service for 30 years, retired, and then went to work for NFPA. I got to say, there's a couple of key highlights that I just want to go over real quick that I've kind of noticed a theme in regards to conversations and discussions that have occurred. But some of the key components that I've heard throughout the whole thing, and I hope everybody up here would agree with me, is a couple of the key takeaways that I've heard is number one, collaboration. And again, this conference is a perfect example of that. And I think taking this to the local level, I think there's a couple of other key features that I've heard Chief O'Brien talked about. I've heard several, Chief DeCrane talk about when he was up here, and several of the other individuals, is having the conversation before the event occurs. Whether you talk about that hazmat team with the hazmat response, and I've heard Chief O'Brien talk about this in many other presentations that he's given, but it's have the conversation at the station level, have the conversation in your department, have this conversation with your elected officials, have your conversation with the tow companies, have the conversation about recycling, have the conversation today, have it now, have it before you start having an incident. And I guarantee you, all of you have had an incident. Like Chief O'Brien says, you just don't know it or you're not paying close enough attention to it. I think the other thing that Chief O'Brien went over that I want to cover real quick is in regards to our theme for Fire Prevention Week. One of the biggest issues that you need to address at your local level is that recycling message. What is that recycling message going to be? Because it's a different message for different folks in different communities. So get together with your waste management, get together with those people, figure out what that message is going to be and figure out what you need to do and figure out who that contact person should be. In Fire Prevention Week, we did a similar message, and that message was just a general message of what we thought the highest percentage of communities would be using and the outfit and company that would be used or utilized throughout the country. I don't want to take any more time because I want to turn it over to these folks from research and technology, because I know we're going to talk about kind of the wave of the future. They're going to talk about some of the stuff. The interesting thing is the last panel that talked, they got to show all the fires. Chief DeCrane kind of stole Alex's thunder a little bit with Fire Research Institute. But I also want to emphasize in regards to Research and Institute that the National Fire Protection Association Research Foundation, along with UL Fire Safety Research Institute, is going to be coming out with a lot of good information even before the end of this year in regards to a lot of key topics that's been talked about. So I'll turn it over to Alex first, and we'll go down the row here and we'll let everybody introduce themselves.
So I'm Alex Schraber with UL Solutions. My background is in mechanical and fire protection engineering, and I'm with our fire research and development group. So our role within the organization is to develop new test methods, new services, keep up with emerging technologies, and just keep an eye on things and where new tests are needed, and keep involved in the codes and standards for all of these topics that we've talked about today. My intro, I'm going to try and keep it efficient here, but there's a few things I want to touch on that we'll talk about. The first is incident tracking. So this came up earlier today, but how we keep an eye on where the incidents are happening, what types of incidents there are. So when there's an emerging hazard or a new context for these hazards, we can be aware of that and start preparing accordingly. We do a lot of research and testing also collaboratively with the fire service to help inform fire department response. We're always working on fire and explosion testing, particularly at the large scale right now for battery energy storage systems. We're looking at construction and materials as well, the role of simulations and how to best use them. And we're looking into the future also for new chemistries and reuse. So one of the resources I want to share for you all is a battery incident database. Dr. Kimmerly with UL Solutions started this database, and it's an ongoing effort to maintain, where we track incidents, not only energy storage systems, but electric vehicles, e-mobility, and consumer products. You can see in this chart on the bottom right the ratio of the different incidents that we're tracking. Energy storage systems and electric vehicles make up a pretty small percentage of these incidents. The vast majority are consumer products and e-mobility, things with a lot less enforcement mechanisms, a lot less codes and standards, and a lot higher quantity. But when we think about energy storage, while the frequency of events is low due to the engineering and oversight of these systems, the consequences are potentially quite high. I think the fire service panel we just had emphasized that really well. Chief DeCrane did a great job of talking about the fire service collaborative research we've been doing on battery energy storage systems. It's actually really helpful, so I can keep my time down to like 10 minutes now, because he gave a great introduction here. So we did 3 major projects I'll just mention. They all have publicly available reports. So while Chief DeCrane and I are going to give you like the 2-3 minute overview, there's about 200 pages behind each of these. So we did one looking at containerized systems. There was a twofold objective here. One of them was to demonstrate what installation level or containerized unit level 9548 testing looks like for training. So I can't take any customer's report and show it to all of you. So we took the initiative to fund this within the UL enterprise so that we could develop training content and bring it to venues like this, because one of the themes today is definitely that education is so important. So we did that project in 2020. This next project, funded by the Department of Energy through the International Association of Firefighters, Sean mentioned this one, focused more on residential response. So taking what we learned from the commercial setting and translating that into the residential context, we focused on a 2-car garage as a common US construction, but a lot of the lessons learned are transferable. So we looked at how battery gas can affect fire dynamics and developed some size up and tactical considerations there. One of the things we saw in that test series was the explosion hazard. When we do these tests indoors in our lab, there's a limit on what explosion hazard we can develop. So we took this to an outdoor test site, built a representative residential garage, and iterated through 22 different explosion scenarios. So separating that fire evaluation from the explosion evaluation to really optimize for each of them. And there's videos and reports out for this one as well on the UL FSRI website. So that's our nonprofit public-facing research function. The next thing I want to mention as a big effort is the the current revisions that we're working through for UL 9540A, specifically around the large-scale fire test. So this came up earlier in the codes and standards discussion and in Chief O'Brien's introduction. Just keep an eye out for this. It's open for ballot right now. So as we talk about this ongoing codes and standards process throughout today, this one is very much active in progress right now. Our most recent technical committee was 2 days ago, and we've got a couple more weeks open on the voting process here. But this was to maintain our test methods alignment with NFPA 855 and make sure we're getting the full-scale fire test data to support these safe installations. I want to thank many of the people in the room today for participating in this. Some of us, I know Noah would probably rather not tally the number of hours that have been put towards this, but this has been a really big cross-industry effort. So I want to thank those of you who've been able to participate in it so far, and I do want to also acknowledge that the fire prevention AHJ voice is generally speaking underrepresented in this code development process. So if you're looking to get more involved, this is a great place to do it. That perspective is always needed for us. Another test I just want to mention, the report is not yet public on this one yet, but we're working on it. This was some testing we did with Sandia National Labs, a bit different from what we'll hear about in a moment. But we worked on some explosion testing there. So we were focused more on the measurement side than the initial scenario side, but we were looking at some different strategies for pressure measurement, high-speed analysis, projectile analysis. So we said, hey, we don't have all this expertise ourselves, so let's partner with another organization who has a great depth of experience here to understand the pressures that are developing, where the right places are for sensor placement. We're pretty excited about this. And I also know it's late in the day and want to show some videos to keep it light for everybody. Another thing we're working on, and I know a number of others here are working on too, is the role of simulations. So where are computer simulations really effective? What are their limitations? Many of these tools are really well established for computational fluid dynamics, but haven't all been validated specifically for battery energy storage systems and some of the unique geometry or fuel complexities here. So that's something we're working on too. Mostly we use simulation, or most frequently we use it as a test development tool, because as a third-party testing company, that's where we find the most use for us, right, in developing different methods and streamlining our test series. But it's something we're working on. The last two things I want to mention as far as relatively new test methods that are out there that show some of the other places where we're thinking about the big picture of safety here. This one on the left, the standard is UL 2596. It's working through the consensus process right now. This is a materials screening test. We had a number of manufacturers from the automotive industry come to us and say, hey, we'd like some comparative screening tools to reduce the amount of full-scale testing we need to do. So I don't want to have to test the fully constructed pack to understand material performance. So can we do that at the bench scale to assist in the development process? So there's a couple test methods within this standard. So we look kind of at that level. And the other one that I want to share, because I think it is a great tool, particularly for the fire prevention folks here, is a very recently published standard, UL 1487. So it's not for battery energy storage systems, but I would say it's a storage system for batteries. So these are battery containment enclosures. They're analogous to flammable liquids cabinets, so a dedicated safe place for storage and charging of batteries, more so batteries at like the e-mobility scale. But this is an important development. I'll show a video in a second of what a non-compliant test would look like. When we were doing development work, we procured the next closest thing out there as a sort of generic demonstration tool, which was a flammable liquids cabinet. The disclaimer, this cabinet has no claims of being able to contain a battery thermal runaway event. So it's not successful, but it doesn't claim to be either. So I think the video's playing. There you go. So you can start to see the smoke release, flames coming out of the cabinet. Understandably, this is what a non-compliant result would look like. Our hope is as more products get certified to this standard and get adopted in the wider like building code infrastructure for e-bike shops or charging in residential buildings, that they will be a really effective tool to limit fire spread. So this was an interesting development effort for us because it was jointly motivated. Some manufacturers came to us and said, I want to have third-party testing, but I don't have a standard to test to. And we also had some AHJs, in particular the Fire Department of New York, said, hey, we need this product, we need a standard for it. So we convened the technical committee to develop that, and really excited about it. It just got published in January or February. So there's some high level on what we're working on. I want to thank you all for coming today and for CAL FIRE for putting this together, because while I appreciate the opportunity to present, I am also really appreciated the opportunity to learn from everybody else today. So thank you.
All right. Good afternoon, everybody. Thanks for sticking around. I'll try and keep this relatively short and sweet. Hopefully, everybody's presentations will look really, really good in comparison to mine as well. I took a slight change of tact here, and I don't think I have a single video, which is pretty atypical. Hoping that there'll be some good questions at the end. But I'm Noah Ryder. I serve as the Chief Operating Officer for Fire Risk Alliance. I'm not going to spend a whole lot of time here on this, but basically I come out of the fire science background. I have never been a member of the fire service. I work with a lot of folks in the fire service, but haven't had that privilege. So most of my perspective and what I talk about today is coming at it more from the scientific perspective, looking at it as an engineering practitioner. Obviously work with groups like UL and Alex on developing codes and standards, but a lot of our focus is on understanding risk, looking at specifics of facilities, helping OEMs optimize and develop safe products and things like that. So that's more the perspective that I'm coming from as we talk about kind of the research and technology aspects of things. And I will make one correction. I think the very first slide said that I was from SFPE. I'm actually from Fire Risk Alliance. I do serve on roles at SFPE, but I'm not here in their capacity, so I'm not speaking on their behalf, just to be clear. I thought it would be helpful to kind of take a little bit of a macro level look at some of the things that are happening within research and technology overall. Oh, perfect. I can walk and talk. Like, that's even better. So there's a lot of specifics that Alex went through in terms of standards. There was a lot of discussion throughout the day, whether it was on 9540 or 855 or the IFC, or even state level things that were happening through agencies, PUC, CEC, whomever. But one of the things that I think is worth touching on is just what are some of the challenges and things that we see that come to light with a rapidly evolving industry like batteries. And so it may not be the best analogy. I know Matt, I think, gave me some suggestions at one point on this. I haven't fully implemented them yet, but is cake, okay? How many people like cake? Anybody like cake? Okay, good. All right, at least we're on that page, right? So what does that look like? Okay, somebody said a brownie. Okay. How about that? A tort? Okay. How about that one? Okay, that's cake. All right, so just for reference, I did a Google search on chocolate cake, and I got each of these 3 things plus dozens and dozens of others. And I didn't even have to go to the second page of images to get some of the, these kind of more tort or brownie looking things. They were right up front. All right, so why do I point this out? Well, the thing is, when we talk about batteries, there's oftentimes this tendency to lump everything together into one category. An LFP is an LFP, and an MC is an NMC, and so forth, right? But the reality is they're in many ways, I like to think of them kind of as cakes, in that even if we were going to say that an LFP is similar, right? That's the chocolate variety, perhaps. Maybe it's vanilla, whatever your preference is, but they're all baked with somewhat similar but slightly different ingredients in different ways, different form factors, and so forth. And so when we go through and we talk about how that impacts things, right, it carries through everything we do, right? So in the research and the testing aspect, it's going to impact the products of combustion that are formed. It's going to impact the gases that are released during thermal runaway and so forth. That has spillover effects into plume analyses and heat flux analysis and everything. So right from the very beginning, before we've even looked at anything outside of the cell, we collectively have a tendency to put things in buckets and kind of try and generalize them. And not that there aren't some benefits there, but what we find is that those details become really important and oftentimes are overlooked. And so we're trying to address that, right? And part of the gap there is that there is a real gap in the basic knowledge that's there and that is shared publicly, right? So is anybody aware of a publicly available database that lists chemistry or gas compositions by chemistry, thermal runaway temperatures, or anything like that that is freely available to use? Why not? It's proprietary. It's costly to put together, right? So there are some that may exist. There are select studies that have been out there. There's others that will publish, but there isn't really necessarily, as far as I'm aware, a comprehensive data set of that type. And that may not be the worst thing necessarily, but there are some gaps, okay? When we do have data of that sort, there's also sometimes an issue when it comes to how that data scales. Okay, so I can take something, and if I do it in a small combustion chamber or a small inert environment, I'm going to get a certain set of results, and it's going to tell me something about those gases. But that may not scale up to a large industrial size site. Okay, so we're looking at trying to identify how we bridge those gaps, and a lot of that work is happening in trying to occur in academia, in the consulting world, at FSRIs of the world, those kind of places. But there's still some big gaps there. On top of that is that anybody did like a master's or anything like that, anything that took a while, right? How long does the average master's degree take? Okay, and a PhD is like what, 5 or something? Okay, they're working on that project and they publish it, right? So by the time it gets published, probably whatever they've worked on is 4 to 5 years old, which is maybe okay for a very mature industry, but in something like this, where there's rapid development, it means that the latest and greatest published stuff in the peer-reviewed journals is probably 3 to 5 years old. Okay. So there's sometimes a gap between when the research is published and the latest stuff that's out there. Okay. So again, these aren't like necessarily bad things per se. They're just things that we kind of need to be aware of. Okay. On the flip side, when we look at it in terms of advances and what's there, we've seen quite a lot of improvements in some of the ways in which cells are manufactured, the chemistries that are utilized, the form factors that are used, the way in which things are assembled overall. There are supposedly safer chemistries as well. We haven't necessarily seen those used large large commercial levels. I'd also question a little bit how valid those are as well in terms of actually being safer, and does it create one hazard while mitigating another? But we're moving in that direction. A lot of what has transpired that's helping to push is we've got some real world data. We've got the standards and codes that are pushing forward. And so we're seeing that product level design is being influenced by a confluence of peer pressure, codes, and a genuine better understanding to turn out better stuff at the end, right? Another aspect that's kind of advancing, it's slower than I think most people would like, but is the reality is, and it's been kind of said multiple times throughout the day, right? Fires are toxic, right? There's a reason you have a chimney, if you have a fireplace, in your home, right? Because just the act of burning wood will produce toxic products of combustion, and that will kill you, right? If you don't exhaust it from the home. So that knowledge is not something new, but there's been a really enhanced emphasis looking at, in particular, BESS fires and the toxicity associated with them, more so than fires in frankly, many other industries. So oil and gas, petrochemical, et cetera, those produce a lot of toxic gases when there are events as well. So what's starting to happen now is to characterize both of those. And get a better understanding of how they compare to each other, how they're similar, what the differences are, so that better education can be provided, training to the fire service, to the communities, et cetera, in terms of what is kind of the true hazard. What's the relative risk between things, okay? Ideally, that's what all of kind of the challenges and gaps that we're trying to fill, as well as the advancements are moving towards, is better knowledge that we can make better decisions. All right, so why is that necessary? Because things are rapidly advancing, and some of the things that are coming, right? Nope, wrong slide deck. We're getting more advanced stuff, okay? There's going to be move towards stacked systems, okay? And most of what I'm talking about is on the kind of the utility scale side of things. There's equal challenges in residential. I'll touch on one thing here in a second, in the commercial space. But we're going to see stacked systems. We're seeing in-building applications as well, commercial buildings, residential, data centers, dedicated use, et cetera. And all these things are on the horizon. Okay. And yes, there may be pushback. And yes, there are challenges, but if you just look at the needs, the energy needs of the nation as a whole, there's no way that batteries are not going to play a critical role. Okay. So, you know, like it or not, some of these things are going to come. And so we need to understand them in a better way. Okay. All right, so the last thing I'll leave you with real quickly is that, you know, we're really looking at the codes and standards and industry feedback, fire service feedback, and so forth to really push the advancements in safety, because that can only happen in a rapidly evolving industry, kind of if everybody's hosting events like this, getting real-time feedback and making changes on I don't want to say on the fly, but in a pace that is generally more rapid than what we're used to for the normal code cycle, okay? Because that's generally out of sync with the state of advancements, okay? So The only way we fill that is with more research. And so I'll part with one thing here, and that is that we not that long ago got asked to look at a product, and it looked very much similar to these panels that we've got here on the wall. Really cool idea, but the company wanted to make batteries, decorative panels that would line the walls of buildings like this and other places. Said, we've got tons of real estate and we can do this. And they'd actually gotten pretty good investment. It spent a lot of money on it. And the first thing we asked was, have you looked into any of the fire codes related to this yet? Well, no. I said, that's probably a very, very small oversight. And the thing is that, you know, there's a lot of excitement. There's a lot of new opportunities that open up that are there. But, you know, fire is sometimes one of the last things to be examined. It's maybe should be closer to the top of the list. So anyways, if you have any questions, I guess we'll get to them at the end. The other thing I will say is this top website here, it's a free resource. If you guys haven't looked at it, we try and throw information on there. There's some tools, there's some checklists, there's white papers, there's other things. Feel free, but it's got, I think, some good information. If there's other things you think should be there, feel free to let us know. But all right, thank you for your time. Appreciate it.
All right, my name is Ray Byrne. I'm with Sandia National Laboratories. We're a DOE national lab. We're funded by the Office of Electricity, and we focused on mostly grid energy storage research. So I'm going to talk a little bit about just what we do, and then also have some movies of different types of battery technologies burning, just like everybody else. And hopefully they're a little different than other folks. So Sandia, we do several things with respect to energy storage, but one of the areas of focus is safety and reliability. And so for that, we do a lot of materials R&D. We look at thermal stability, gas evolution of different technologies. We do a lot of degradation work, and that involves long-term cycling. We've got some cells that we've been cycling since about 2016 or 2017, and we publish annual reports on how they're doing. We also do a lot with manufacturing defect evaluation. And then under cell and module testing, we look at aging. That's part of our long-term cycling studies. We look at different diagnostic techniques where you can put sensors in packs and modules, or maybe just inside the energy storage system to help figure out how the system's doing. We do a lot of abuse testing. So we have a battery test facility called the Bat Lab, which is an explosive test facility where we can destroy cells and modules up to a fairly large size. And then we also have a large outdoor test facility where we can destroy really large systems. And this picture up on the top right is just a rack mount system that we recently destroyed. And then so part of the destructive testing also includes looking at thermal propagation, how the one cell can propagate to another cell and eventually take out a whole pack. And then yet another aspect of this is simulation and modeling. So looking at multi-scale models, fire dynamic simulations, predictive simulations, and like everybody else, we're trying to apply machine learning to the battery safety and reliability problem. And then standards, we're super active in standards. We do a lot with IEEE. We're involved with several IEEE standards. One is focused on battery management systems. Another's focused on energy storage, energy management systems. And then we're also working on some standards looking at how you actually deploy energy storage systems. And then we've got a couple folks that are active with NFPA standards, and then we work with EPRI on their energy storage data guidelines. So the two things I'm going to talk about that are hopefully new and useful. So lithium-ion batteries, they're pretty prevalent everywhere. They do have some safety concerns. Two up-and-coming technologies that people are hoping are safer are solid-state batteries, and then also sodium-ion batteries. So I'm going to talk a little bit about each of those and how there still are some fire risk. So sodium, or I'm sorry, solid state batteries, this picture here just shows kind of the block diagram of how a normal traditional lithium ion cell is constructed versus a lithium metal cell is constructed, or a solid state battery. So in a traditional lithium ion cell, you've got a porous separator in the middle between the anode and the cathode. And that separator usually has some volatile solvents in it. And so you've got the fire risk both from just the lithium in the battery, but then also when it gets hot, that separator basically can put out gases that can contribute to fires. And so the separator causes a problem. So the idea was you replace that separator with a solid separator. And that will mitigate some of the fire risk and make the batteries less susceptible to catching fire. But one of the challenges here is there's something called thermite reaction, which is an exothermic reaction between a metal and a metal oxide. And so most people have probably heard of thermite, but like one of the industrial applications is welding railroad ties. So you wrap thermite around it, you light it off, and boom, it welds your railroad tie. They used to use it in World War II for basically if you capture someone's artillery unit, they can basically debilitate it by putting some thermite in there and it seals it shut. You can't use it. So anyway, so thermite burns really hot. It doesn't need oxygen. And so this slide just has some equations for known thermite reactions. You can kind of ignore the chemistry part of it, but the important thing to see is the top one is just the traditional thermite, which is aluminum and rust basically. And it gives off 3.9 kilojoules per gram. And then the other ones below it are lithium, and then discharged LFP cell, and then a charged LFP cell. And the interesting thing to note is that the amount of energy released from those reactions is even more than just regular thermite. So that helps explain, you know, why people are worried about different types of lithium ion systems. So what we're doing though is looking at basically the components of a solid state battery. So if we go back to this lithium metal cell, we haven't tested the full cells yet. That's next on our list to do. But we've just been taking the material from the anode, the material from the cathode, and mixing them together and see what happens. And sure enough, you can get a pretty good reaction. So how do we play this video? Do I have to do something? Oh, it's playing. So that's basically the materials of a solid state battery, 100 milligrams of lithium metal. So what happens basically is, and what our concern is the battery might be slightly more safe because you don't have the volatile organic type materials in the separator. But if the left side of the battery touches the right side of the battery, you can still have a pretty good fire. And there are different ways that can happen. If it's an electric vehicle battery, you could crush the battery. If it's a grid scale battery, you know, if the building collapses or there's some other kind of explosion or something, anything that or it could be just a battery manufacturing flaw or dendrite that reaches across the anode to the cathode. So I don't know, solid state batteries, they were proposed to, you know, be much safer. We're still in the process of doing more testing, but so far we do think there are still some safety concerns with solid state batteries. And for more information, there's a paper up there you can look at. The next one is sodium ion cells. So people think these are more safe just because they use sodium instead of lithium. This one's really interesting because every year, Sandia and Pacific Northwest National Labs have an annual safety meeting. And at last year's meeting, some folks from Sandia got up and presented these videos. The person that went right before them was testing a sodium ion cell, did the same type of test. We got them to catch fire and explode. The other person didn't. So there's still, you know, it might be cell to cell variations. It might be something else. But these cells, you know, are supposedly much safer. But here's some results from some nail penetration tests, and it still explodes, at least for us. And then the next one's a crush test. Yeah, let's see. And so bad things happen there too. So even though people say sodium ion cells are safer, there still is a potential concern. So anyway, that kind of wraps up what I was going to talk about before the Q&A session. We do have a website, the sandia.gov/ESS. It has a bunch of material on battery safety. It also has information from all our annual peer reviews and safety forums. And then just some takeaways for firefighters and first responders. You should always work with the proposed energy storage developer to be aware of any technology-specific hazards prior to construction. I think that mostly gets enforced through the codes and standards process. But another one, if you have an existing deployment, an important thing is to keep aware of the evolution of safety standards and the differences between the deployed system and the latest standard. The people who built the system, are usually only held to the standards that were in place when the system was built. But the Moss Landing fire is a good example of that. Those units, those racks were very close together, and they wouldn't have been allowed like in a subsequent standard. So you could have flagged that if you continually track and look at the differences between the deployed systems and the latest standards. And then the final comment is, this forum focuses on battery energy storage safety, but in energy storage systems in general for the grid, even if it's not a battery, there are a lot of hazards. Flow batteries are a different type of battery. They can have thousands of gallons of electrolyte that are highly acidic or a strong base. Mechanical energy storage, if you have a flywheel, those can have a lot of energy. Those can escape whatever they're in and blow the side of a building out, destroy a car. If it's a gravity energy storage system, it could easily crush you. So any kind of energy storage system used for grid storage, it can have a lot of safety hazards. So just don't think because it's not a battery, it's safe. So anyway, thank you and look forward to our discussion.
Scientist. So thanks Cal Fire for inviting me to talk this hot potato topic. I think it's wise to have an outsider to address this topic. So as one of the panelists earlier mentioned, all fire smoke are toxic. Lithium-ion battery fires have some unique toxicity. This table lists a range of air toxics that are coming out of lithium-ion battery thermal runaway, including carbon monoxide, hydrogen fluoride, hydrogen chloride, hydrogen cyanide, and heavy metals like nickel and cobalt. Just want to point out that hydrogen cyanide has this metallic taste. I will mention that later. So lithium-ion battery fires toxic. This table comes from the EPRI incidence database. I just picked a few recent incidences with air quality measurement. Most of them say the minimal or low impact. I'll skip the first one. I'll talk more about that. The second one, Chief Robert in the previous panel mentioned this. It says air quality and the water runoff were well below the accepted exposure limit. And it's similar to a typical structure fire. So as a scientist, it's always skeptical what people say, right? So let's look more into detail about this Moss Landing fire because this is very close to here and it's very recent. So the fire starts on January 15 this year, and it caused Highway 1 to close and about 1,500 people to evacuate. EPA did the monitoring very close to the, shortly after the fire started. They measured a maximum HF concentration of 71.2 ppb, which is well below the 300 ppb California standard. EPA also stated that PM 2.5 is typical of the regional level, so no impact due to the fire. However, residents reported symptom, headache, sore throats, and metallic taste. Remember, I just mentioned was HCN caused this metallic taste. So there are data gaps in the monitoring data. The PM 2.5 near the Moss Landing may have exceeded the regional normals. So I plotted the data. I just downloaded publicly available data. The green data on the right-hand side is from ARB database. It's measured at the Salinas High School, about 15 miles away from the fire site. It's measured by a compliance monitor used by EPA. Then the red and the black lines are public data from Monterey County website. From this data, I cannot conclude that what EPA stated, the concentration is typical of the regional concentration. You can clearly see the fire incidence concentrations are much higher than the regional background. I actually downloaded 3 sites of the compliance monitoring. They are similar, so I can be confident the regional concentration is much lower. Furthermore, the EPA monitoring, they measure the mass concentration. They don't measure the particle size distribution. As scientists, air quality scientists, we know the nanoparticles get deeper into our lung and more toxic. And they didn't measure the chemical composition, including the heavy metals in the air. Another group, they measured the soil sample 2 miles away from the fire site, and they detected these high levels, 100 to 1,000 times higher than background in nickel, manganese, and cobalt. Those are battery components. So there's additional data needed to assess the impact of water, air, water, and the soil. Then there are broader gaps. So many BESS fires, there's no measurement. All the measurement happens after the fire. The instruments are not always calibrated to federal reference method. So you get a reading, but you don't know how accurate that reading is. Those are typical for emergency response measurement. Then sometimes the measurements are delayed, so we don't really know what happened during the fire. A lot of data are reported in air quality index. Air quality index does not account for the battery-specific air toxics. So it's sometimes the information, cannot really tell how toxic the air is. Then I have a schematic here showing the plume dispersion is highly dependent on the fire intensity, the wind, the meteorology conditions. As a air quality scientist, we sometimes say the solution to pollution is a dilution, right? So you have high plume, go to high altitude, the wind will dilute the air, but sometimes the wind bring the smoke back down to the community. So you have to be careful where the smoke is going. Then I look further into what's available around the Moss Landing site. So there is a citizen scientist network called the Purple Air Network. There are about 100 monitors around the Moss Landing area. You can see a dramatic increase of number of sensors after the fire because people obviously are concerned about the air quality. And I just picked 5 sites. And remember the fire started on January 16. My eyes tell me, there is a concentration increase. These are PM 2.5 particular matter that measured by instruments. In all around the directions, the scale bar is 10 kilometers. So all these directions detected increased concentration. And what's interesting is one of the sites, the green marker there is the Marine Lab near the fire site, that data is inside the building. So even inside the building, it detects high concentration on January 26, which means the smoke infiltrated inside the building. So lithium-ion battery fires are more toxic than other fires. This table, is kind of snapshot as my co-panelists mentioned. There's no comprehensive database. So this is comparing the different air toxics emit from different fires. The first two rows are LFP battery and NMC batteries. You can see the HF is higher than most other type of fires, except that the electrical cable emit quite a bit HF. So the caveat is these fire emissions depend on the testing battery chemistry. There's a really wide range of emissions. And a lot of the compounds, we don't really know the toxicity of these battery emissions, like fluorine-related or lithium-related compounds that there's no data available about their toxicity. So we have to be, just to be prudent, we have to be very careful about the battery smoke exposure. Just one step backward, what are the factors that affect health outcome of the air pollution? It depends on the type and the concentration of the pollutants, the duration and the frequency, whether you get a single short duration, high concentration exposure, or you expose to the smoke for a longer period of time. They have different health outcomes. And each person is different. Some people are more accessible to air pollutants based on age, or do you have a pre-existing condition? So there are several additional considerations for lithium-ion battery fires. First responders face the highest exposure levels because you are just at the fire. Okay? The fire suppressant may produce harmful byproduct. The manufacturers may claim they're safe, environmental friendly, biodegradable, but we don't really know what happens when they're heated. Even water, if you pour water into heated battery, it sometimes increase HF emissions. PFAS has been known problem with some of the fire suppressant. And vulnerable populations, elderly, children, and pre-existing health conditions should take actual precaution. I want to echo Chief Robert's point that if you have a SCBA, please wear SCBA. But a lot of general population don't have SCBA, right? Sometimes you cannot just put a dust mask or N95, even N100, P100. It won't protect you from gases, HF, CO, HCN. These penetrate right through these particular filters. So these sometimes give you a false sense of security. So you have to be careful, what kind of respirator you wear. So just to summarize, lithium-ion battery emissions emit a complex mix of toxic compounds, many with unknown health risks. While past incidents show low air quality impacts, but more comprehensive data are essential. And rapid deployment of air monitors to detect key contaminants of concern are essential. You can do more mobile monitoring or distributed monitoring or UAS monitoring. These are all approaches that's available. And first responders and vulnerable populations should take actual precaution when you deal with these fires. That's what I have. Thank you.
With that, we're going to get into our questions. Waiting for my laptop. So the first question, new manufacturers are not able to go through UL 9540A testing to obtain a UL 9540 certificate because they only have one prototype unit. Is there an alternative method to obtain a certification? I think that's going to go to you, Alex.
I had a feeling. So with a single prototype, you can't necessarily go through the full suite of tests because some of them are destructive tests. But we are able to work with you kind of throughout the development process to start collecting the data on the samples that you do have, and work on it kind of as you go. So as it is more complete, we can do more and more of the test program, but it is definitely a reality of the testing protocols that you may need a few samples to get through the full thing. Not necessarily a few full-scale containerized systems, but certainly a good number of cells, maybe a few modules, and to get through the full program.
Okay, Noah or Ryan, I think this question will go for you, one of you two. With computer modeling, it was stated it's limited on its data with battery. If this use, or if this is the case, I think, what holes are created with applications we should be looking for?
So I don't know if this will directly answer it, I guess, but you know, the classic statement, garbage in, garbage out, I think is still very valid. And so, you know, when we look at appropriate use of modeling tools, the very first question is the tool appropriate for the use, number one? And what is the data that you're trying to get out of it? There are very simple tools that you can use that are empirical and they just produce you know, ellipses or things like that. They don't take into account obstructions or buildings, topology or things like that. And those are great for certain applications. There are more sophisticated tools like CFD that give you more temporal and spatial resolution. And so the first thing is, what is the data that you need and what's the level of refinement that is required from the analysis? Pick the tool based on that. And then second is the information that goes into it. And so I think the information that goes into it, that is something that, you know, is was just pointed out by Alex, a lot of that comes from the standardized testing in terms of gas release rates, heat release rate, if it's a module level test or things like that. But there are certainly gaps that are there. Toxics, I think Paul Hayes mentioned it earlier, it's not part of 855. So there is no requirement to collect data on toxicity in any of the test standards right now. It's basically calorimetry and H2. I think the FTIR requirement's still not, right? It was pulled out, so it's not required, right? So some folks will take FTIR data to get gas data to help populate models, but it's not required. So that I think is probably kind of the biggest gap in data sources probably that's there right now. Once you've determined that the model actually can do what you want it to do.
So Noah, would you say modeling for, let's say, what we're talking about in regards to here with lithium ion batteries is potentially like where we were 20 years ago in regards to fire modeling or egress modeling? It's still building and growing. And I mean, to me, I look at egress modeling, fire modeling as it's a tool. It's not going to be the solution. Is that the same thing that we're looking at here?
I think it's very much a tool. It's a very useful tool. And again, depending on what your use case is. So if you're an OEM, it can be really helpful in evaluating spacing requirements between units. If you're looking at effects to an area, then, you know, if you can make some reasonable assumptions, you can get good data on plumes and things like that. But yes, it's a learn is, you know, we're still filling in those gaps. The reality is, I'll say this though too. I pointed out that the SFP has a paper coming out and NFPA does comparing battery fires to non-battery fires. And part of the reason for that is that frankly, there's really not good data on large fires in general. So to the data that you showed that shows like the PM 2.5 concentrations after Moss Landing, I'd be really curious to say, take those same locations or equivalent radii for a non-battery fire that was significant and see what it looks like there. And I would guess that your PM 2.5 concentrations are going to go up also, as are some other things. So I think there's very much the need to view the whole thing kind of in a holistic manner in terms of what the role is that, you know, modeling or basically research and technology plays in general. So, yeah.
Ray or Alex, do you have anything to add?
Yeah, this is kind of tangential, but we've actually been doing a lot of arc flash modeling for electrical safety hazards with batteries. And surprisingly, we're getting really good results, and we're about to publish a paper on that. We're using COMSOL, and I think those models are actually much farther along than looking at the particulate and thermal models of a battery fire.
Okay. Alex, I think this one's for you. Does the UL 9540A also consider weather and locations such as high severity zones, landscape, and high wind areas and the risk of starting a large fire?
That is a good question. So the way that 9540A, I guess the quickest answer is not directly. What 9540A does is try to collect in a very a more standardized lab setting the heat flux and temperature exposure and heat release rate that could affect those different exposures. And then those environmental concerns, either to other exposure differences or once there's wind that can move the hazard a little further away than where the testing was. Right now, that's where a lot of modeling is used. So taking the data from the lab context where we can measure heat release rate and we know that the air is stable, and then afterwards iterate through different variables to see how it would impact that. So we collect some of the inputs that you would use to do that analysis, but those outputs aren't a part of the standard test.
All right. I just add real quick to that. I think that's actually one of the best uses of modeling is if you do the large scale fire testing correctly and you get really good spatial data on heat flux and temperature and things like that, then you can, I don't know if calibrate's the right word, but basically you can do the modeling to match the large scale fire test and then keep all the parameters the same except for maybe the wind. And then you do the wind profiles and then you can see what the impact is. And that way you can then effectively capture kind of various wind conditions. So if you're someplace where a 50-mile-an-hour wind is kind of a, maybe not every day, but a common occurrence, you can do that. And if someplace it's relatively calm, then maybe that's appropriate there. But that we do see that quite a bit.
Okay, thank you. And thank you for adding that additional information. And Alex, yeah, you're going to be on the hot seat for a minute. So, and I've seen this with different standards. And a perfect example of this would be the new requirements that came out for new smoke alarms, because we had existing smoke alarms. Now we had new smoke alarms. We had to go through this evolution. So the question is very similar related to that is when the updated UL 9540A test protocol is released, when will it become effective? And then additionally, will currently approved battery systems be required to undergo retesting?
Okay, that's a tricky one. So the effective date of our standards, it can vary a little bit. So the smoke alarms is a good example of a product category where the new edition of the standard came out. In that case, there actually was a process we call an industry file review to get the existing certifications up to the new standard. That was over a long period of time. I think it's like finished maybe like this year to get across that full product category. UL 9540A is not a certification standard. It's a standardized test method. So as the new revision comes out, I don't know how much it will be applied back to existing testing, but where it does come into play is the installation standard. So where you're working to the latest edition of NFPA 855, that standard expects a certain set of testing to be completed for the permitting authorities and the fire protection engineers to design systems. So if there is a gap, I could see that either requiring either additional evaluations or engineering judgments and modeling to extend some of those existing results.
Okay. I'm going to ask this question. I think I might have to answer it myself unless somebody else wants to jump in, but how do we recycle old chargers, solar charger, when manufacturers don't have recycling programs? I don't see anybody pulling up a mic, so I'm going to take this one. So my conversation is going to be is I would encourage those jurisdictions, those individuals to get in contact with your local recyclers, figure out what that could be, what they would take. If you don't have a local recycler, get in touch with a PV manufacturer or installer in your jurisdiction, your state, your community, find out what they would do with their unused devices. Get in contact with people that are in the industry, figure out where that would go. As for, and the question went away now, but for chargers, literally for like battery chargers, home battery chargers and home batteries, some of those you can actually take back to the location that you actually purchased them from, whether it was Lowe's, Home Depot, Ace, Hardware. Some of those folks have recycling capabilities, so look into that. Okay, if UL testing uses 9540A for batteries and 810A for supercapacitors, doesn't that indicate they're different technologies and should be regulated differently in regards to NFPA 855 standards?
That's a good question.
That's a mouthful.
I think Robert got asked that question earlier today, too. So that at a high level, that's where all of these different technical committees, to join that today's theme on collaboration, need to review the data around different technologies and determine where those exemptions are or are not appropriate. There is capacitor testing that can be done within the UL 9540A framework. And there are some products that use combinations of different things. But that's where the technical committees come into play to reconcile those different requirements together and make sure that this full ecosystem is all interfaced well. I think this is a theme we see where some of the technologies that are a smaller percentage of the overall industry have a added responsibility of having to educate all these different regulatory groups to make sure that everyone understands things fully to determine the correct requirements.
Okay, so I'm going to ask this last question. I'm going to start with Ray down there, and then we're going to go to Noah and then Alex. And I'll give you each about 30 seconds, 45 seconds. But I'm kind of curious, how do you foresee the role of BESS systems evolving over the next decade in the contents of the global decarbonization goals?
So for battery energy storage, this is, long duration energy storage is a term that's become popular just in the last few years. But if we do start getting higher and higher penetrations of renewables on the grid, the variability, there are different ways you can handle it, but one way is with massive amounts of energy storage. So we will start having, larger and larger grid scale energy storage systems. In the past, people have said that, lithium's a good short duration technology, like 4 hours is great, long duration, you don't need it. And the challenge is, lithium systems are pretty high performance and pretty low cost relative to other technologies. So they keep kind of pushing out their duration. One camp says it's going to be some other magical long duration technology that's going to be the magic bullet. But another thing that might happen is lithium just kind of gobbles it all up. So it's still TBD what's going to happen, but if we do have a lot more renewables on the grid, we are going to have a lot more storage.
Ray, you got anything to add? Not right, sorry, Noah.
Oh, yeah. So, no, I think that captures it. I think the one thing I would say is that, new technologies are great. But, they either need to be very disruptive or, you know, large scale manufacturers aren't in the habit of cannibalizing sales. So if something works, even if there's something better, I think, well, most of the folks in this audience, how many people remember Beta versus VHS, right? Okay, so I'm dating myself a little bit here, right? But you know, Beta was arguably better and it
I thought
lost.
you were talking about Blu-rays.
Well, you blew it. Yeah. Laser discs. No, let's say I could go down that path. But so I think there's an aspect of that from the commercialization standpoint. So I would expect to continue to see some of the current things that are out there technology wise, and folded into the grid. The other big thing I think is off-grid systems, right? So I think as the needs increase, there's already some data centers that are basically independent. I would not be shocked if we continue to see that just because the grid is unable to support some of the growing power needs. So
Sure. Well, and I think you hit on that key point there. I think data centers are going to become our next hot issue. Alex, do you have anything to add in the few seconds?
I was going to add, it's obviously clear from all of the projections we've seen today that battery energy storage is increasing. It's not going anywhere. What I hope from the fire testing perspective, over time that this fire testing for energy storage systems becomes relatively boring, standardized testing like a lot of our other product categories. As the best practices evolve and as it becomes a much more established part of the product design process, it'll become more routine like fire resistance testing and sprinkler testing, and I'm looking forward to that.
Cool. Let's give this panel a round of applause. Chief, I'll turn it back over to you.
Great. Thank you very much. Please also give Greg a round of applause as well. So as we wrap up this afternoon, thank you all for taking the time. I know we've had some come in and out. We have hundreds online as well, so very much appreciate. It can be difficult to join a session like this that's as interactive when you're not able to be in the building, but very much appreciated the interaction. So appreciative of the experts that were able to join us to part information. You know, not all of it is in this challenge that we have. Do we all know the right answers? We may not all agree also on some of those answers. But what's really important for us was just to make sure that we provide the opportunity for all of us to hear what's happening in codes and standards, in response, in firefighter safety, as well as in the research and development, what's coming down the pike. And so appreciate you taking the time and energy. Just a couple things as we end here. At the State Fire Marshal's office, obviously state fire training is a core component of our department and our office. And so one of the things that we have been working on is really trying to take this information and this work that's happening and embed it into our curriculums to make sure that future firefighters, future plan reviewers, future fire marshals, and all the other respective courses that we teach, that we are continuously updating this type of response, this type of information into those courses. So that we, again, are keeping the fire service educated. You already heard from our co-development team, but also is part of our office to make sure that the fire code and the building code in California incorporates these systems and incorporates all of this great research and technology that we're talking about here, but making sure that it is in the code to ensure safety. And so we've been very proud, as I bragged at the beginning, that we've continued to bring in items early on. But several of the panelists have mentioned that this work happens in the public. The work happens at the International Code Council and their committees. This work happens within our code development team and their subcommittees as well here in California. And so if you want to be part of the change, know that you have a voice, whether you are in the fire service, the building industry, or the energy sector. Everybody has a voice to doing this. So with that, I just want to take my appreciation to all the panel members, many of which traveled far and wide, many many people have come from the East Coast to join us, and so I'm thankful. I very much appreciate our moderators and our keynote, Chief Mike O'Brien. Appreciate the other moderators, Robert Marshall and Greg Rogers. But I do want to take a quick second. You know, two people have worked the hardest throughout the last 8 hours, and that have been our interpreters, making sure that that this information is accessible to everybody. And so I thank them. I don't know how they have worked so tirelessly, even with the two of them taking some breaks. But then lastly, on our team, several folks in the back from Sacramento State in the control room, Tommy and Alicia, who helped you check in. It takes logistics to make sure that we have the planning and to ensure that the space is utilized. But then from our team, and they're kind of hiding, but just peep out a little bit. Robert did a really good job of highlighting Deputy State Fire Marshal Kara Garrett from our Community Risk Reduction Division. And Tim Spears, our Assistant Deputy Director over a lot of programs that I won't bore you with because we don't have time. But these two have worked very hard to make sure that this information can be pulled together as well. And so lastly, the state agencies and the partners that were here, the industry representatives that have had their booths outside. I know a number are packing up, but again, just bringing us together to talk has been a wonderful day. Look for the future. The last thing I would ask is that you complete this after action survey. So take this QR code, give us some feedback. We've heard from plenty who could not get access to the in-person, even though we had a lot of people at the last minute not be able to make it. We have so many people online, and so we likely will do something similar, and so would love to hear what's next. If you were here in the room, what's next for you that you would like to see from us at the State Fire Marshal's office? For those of you online, what other opportunities would you like to see? How can we improve on this avenue of sharing information? But then lastly, again, look to our industry partners to be side by side with us as we continue to what I think is get past this idea that this is an emerging technology and this just become the norm of what we do. And we'll get ready as a fire service for what is next, whatever that may be. We often in our office talk about solar voltaic as was a really scary thing several decades ago, and now it is just part of the permitting process and the operational process, and we will get there with these kind of systems as well. So again, please take the survey. Tim, I'll turn to you just for if there's anything else to close out, but thank you very much for taking the time.
All right. Well, I don't have much to add after Chief Berlant's remarks, but again, please take time to scan the QR code, add your thoughts in regards to the survey. Please, again, thank you to all the panelists, the moderators, and everybody that was able to attend either in person or online. We really appreciate the contributions that everybody's been able to provide today. Before you leave, just make sure to maybe try to engage some of the exhibitors in the exhibit hall before you go. And thank you again.